Tribune.
Ontogeny. Ontogeny.
I have no idea to this day what that lady was singing about. The truth is, I don't want to know. I tell you, that voice soared. It was like some kind of pink dinosaur walked into a drab little cage and used its powerful tail to knock those walls away. And for the briefest of moments, every last man at Shawshank was a pink little dinosaur too.
Well, hello everybody, and welcome back to Paleontologizing. How are you all doing? Happy Monday. Really glad you could make it. We're gonna have a fun, chill stream today, so I hope you're ready for it. And especially if anybody's new, welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here on Twitch 5 days a week now. Holy cow. Trying to do some good old-fashioned science outreach. This is the best method that I've found for being able to do that, and anyway, yeah. So glad to have you here. As a dinosaur paleontologist, of course, I dig up dinosaurs across the American West with various different museums. I study dinosaurs, I publish on them in the scientific literature, and nowadays, I actually make my living doing outreach every weekday. Right here. So whether you're watching live right now on Twitch, and hello everybody in chat, welcome, welcome. Or whether you're watching later on in the VOD, or maybe on YouTube, I'm really glad you're here. If you've got any questions at all, people who are here live, questions about dinosaurs in particular, that's my research wheelhouse. Or if you've got questions about broader topics in science, about natural history, extinction, evolution, maybe how science works. Don't be shy with those questions either, you know? Q&A is kind of the bread and butter of what we do here, so, yeah. Type those questions into chat, and we'll get to them. Today we're going to be covering some fossil news. Going to be talking about some exciting new discoveries, including that new, relatively semi-complete European Spinosaurid, which is very exciting. And, yeah, a host of other fossil news topics as well. But we'll get to those after I get through chat. Let's see who's here, and, let's say hello. Oh, wait a minute. Arachnia, how are you doing? I haven't seen that name here before. You new, Arachnia? Right there at the bottom of chat. Pachycetus. Wonderful. Wonderful. Archaeocete whale. Kind of whale ancestor. Let's find that animation, and I'll play that in the background while I'm going through chat. There we go. Ah, beautiful. Let's loop that. Excellent. Well, yeah. And San Diego Zoo, I might be going to TwitchCon this year. I actually still have to determine that. Unfortunately, TwitchCon, it's on the same weekend as the Society of Vertebrate Paleontology meeting. So it leaves me with a choice. And I'm weighing my options here. But welcome, San Diego Zoo. It's good to see you. Let me scroll up to the top of chat. While these whales are evolving right here. And let's say hello to everybody. Already lost the top of chat. Holy cow. Martin Hoke, how are you doing? Visible Dimensions, welcome. Shaggy Rex, hello to you too. It's good to see you. I seem to recall that Science Streams was first in chat today. Balint, if you're watching, hope you had a great weekend. It's good to see you. And also Kodali, I think, was second. And then maybe Smorphosaurus and Jody Fish. So welcome all of you. It's great to see you. But chat, man, the top of it's already gone away. So let me continue scrolling down. Kelodon K, that was Monsieur Lou. Yes, indeed, Kelodon K, which I guess is like an old Greek folk song. But it's become like a surf guitar kind of staple over the years. Mighty Draz, how are you doing? Welcome. Gertis Pucka, how are you doing? Ghostly Ghoul, great to see you. The Lenina, always wonderful to see you, Lenina. I hope you and Blue had a really good weekend. It's great to have you back, as it always is. Thank you for doing what you do, Lenina. Blinkster 2, howdy. Bat Medler, what's shakin'? Did I say hello to you yet, Moonrise Rabbit? If I didn't, hello. If I did, hello again. Welcome, Moonrise Rabbit. Eddie Scarin, how are you doing? Ontogeny, indeed. Although this is phylogenetic evolution here. Pretty cool. There's Cuchicitus. I don't know if we've got Pachycetus in this, but Pachycetus is pretty similar to Cuchicitus. Yeah, kind of almost like an Ambulocetus grade whale, but maybe a little bit more aquatically adapted than that. Duck Admirer is here. Welcome, welcome, Duck Admirer. It's good to see you. RBRO. And thank you, Grunchy McFluff, for the follow. Welcome to Paleontologizing. Good to have you here. Just Crabgrass. Howdy, howdy. Neilf. What's shakin'? Good to have you here too, Sergeant Raccoon. A salute. And Pendrake, is today the Spinosaurids topic? We're going to talk a bit about Spinosaurids today, yeah. I had kind of a Q&A session about Spinosaurids on PaleoStream's channel on Saturday, which we ran into some technical snafus. It was not nearly as polished as I was hoping. But yeah. And Darth Goof.
Comprehend and appreciate
the great dinosaurs. Darth Goof, thank you for support for much longer than a brief moment. 19 months of support from Darth Goof. Thank you. Thank you for that. Truly extraordinary. Thanks for keeping me here on the air for the past 19 months, Darth Goof. I would not be able to do this if it were not for the generous support of viewers like you, Darth Goof. So, thank you. You know I appreciate it. Let's see who else is here in chat. Scrolling. Mitch Biocannon, how are you doing? Welcome, welcome. Harabothan, good evening to you too. It's good to see ya. Andy Then Did. This is Catch of the Era. How you doing, Andy Then Did? Welcome, welcome. Origin TT. How are things with you? I'm glad you could be here. Desmodus says, is this Aqua? Blinkster says, no, this is Patrick. There was actually a member of this community who turned me onto that song originally. I gotta figure out who that was. But, yeah, that's by somebody called Miss Papaya, apparently. Pink Dinosaur is the name of the track, which is... it's something. Oh, definitely an earworm. Yeah, I'll leave it up to you whether or not that's a good thing. Dorkalotl, how are you doing? Welcome back, Dorkalotl. It's great to see you. I hope things are good in your part of the world. How are you doing? And you're doing good? I'm glad to hear it, Sea-Films. Welcome back, Sea-Films. And there's Arachne again. Yeah. We can talk about a bit about Pachycetus if you would like. You know, we could talk about the evolution of whales as a first-time viewing treat for you, Arachnia. Yeah, we might even get started with that, actually, because that'd be a lot of fun. Hello to you, too, Go4Fluff. It's great to have you here. Drucifer. Howdy, howdy. How you doing, Drucifer? I hope everybody had a wonderful weekend, and I hope you're ready for some exciting paleontology news on today's stream. Yeah, don't let David Peters see that. Eddie Scarin. I mean... what do we care what Peters thinks? Anyway. El Smarto. Well, bienvenidos, El Smarto. A Paleontologizing. T-Matrix. It's great to have you here. And Rex, the Tyrannosaurus Rex, says, do you think we could watch a video about the Tyrannosaur family? We very well might later. Yeah, we're going to be talking about theropods, and I betcha we'll probably have some sort of discussion about Tyrannosauroids today. That's honestly most streams we talk about Tyrannosauroids. They come up in conversation a lot. So, yeah. But, let's see. Do we still have, Arachnia here? Let's see. Arachnia, let me know if you're still in chat, and we'll take a look at a video on whale evolution. Be a nice way to start things off. Yeah. And you had a great weekend? I'm glad to hear that, Bet Mother. I was able to get some science done. I continued work on my, my Trirarchuncus sculpt. Sculpting a dinosaur, a new dinosaur from 2020, where I'm an author on the original paper. I think Denver Fowler is first author on that. Jack Wilson found the specimen. There we go. It doesn't look like that. This is how it started off. But let's open that up. Churacuncus Feathers 2. New scene. There we go. Yeah, I'm kind of exaggerating the claws a little bit, but I'm sculpting this beastie for 3D printing. It's going to be replacing, at least for the time being, my Waterhouse Hawkins Iguanodon right there. So, yeah, I'm excited about that. Been working on it. This, of course, is Churacuncus, a kind of alvarezsaur, also known as, well, the name means Captain Hook. So, yeah. But anyway, I'm going to be posing this. Right now it's got perfect bilateral symmetry. The front, or the right and left sides are identical. But I'll turn off symmetry and then put it into an interesting pose before I go ahead and slice it and print it.
Simply astonishing. One of the most singular specimens I've encountered in all my distinguished career.
Well, oh well.
About my work. What did you want to show me?
I'm on Pelier. Thank you for the follow and welcome to Paleontologizing. So humble. It's good to have you here. Appreciate you. And that was Stephen J. Gould, Claire Burr. It was indeed. Yeah, we've got a surprising number of Gould alerts on this channel. But yeah. And what dinosaur would humans eat before chicken? Chicken ancestors, see films, you know. Red jungle fowl? I don't know. It's not the best question. I'm not a meat guy, you know. People ask me like, "Oh, Danny, which of your neighbors would you eat first?" Or, you know, what kind of pet dog would taste the best or whatever. You know, what's the tastiest breed of cat? What kind of dinosaur would taste? I don't know these things. I don't eat meat. So yeah, and I think I got rid of that command, Claire Burr, because I don't know, I didn't want that to become like a thing, but people just keep asking that question. Yeah. Anyway, I'm hearing some weird noises coming from the 3D printer. Let's check on that. I'm not printing a dinosaur right now, or anything fossil related, but I am printing some shelf brackets for my good friend Snail Chaser. And it's making weird noises. I'm afraid that something may have gone awry. Let me go look in person. All right, cross your fingers that works properly, because I've been having some real issues with that lately. A lot of failed prints, and I'm not sure why. Anyway, I had it working just fine a little while ago today. But, yeah, anyway, 3D printing, never a dull moment, right? But yeah, was I scolding the print head? I was trying to say 1 minute, because the microphone over there I don't have on. But, yeah. And let's see here. And Browse has got to go because of the time change here. The stream starts an hour later for me, so less Danny from... I'm sorry, Brow. But hey, there's always the VODs, and there's always the YouTube as well. Yeah, so if anybody would like to see what I've been up to lately, you can always go to the old YouTube channel. And here it is right here. And I'm missing... Oh yeah, we didn't have a stream on the 22nd, did we? I'm missing one of the streams, shoot. But I'll get it up there. Anyway, yeah. But anywho, yeah. And Darkolotto's got some pictures of the fossil she found. Very, very cool. Let's take a look at this. Very sandy sediment there. Figure out what this is. The symmetry is kind of... Is this a piece of a vert or a rib? I'm trying to figure this out. It's a toe bone. Okay, gotcha. It's a phalanx. That makes a lot of sense. Yeah. Very cool. Big old toe bone from a Gomphotherium. Gomphotheriums are, of course, these big proboscideans. Come on now. Gomphotherium. Big elephant-like critter like this. These guys are super neat. Yeah, look at that. Yeah. So yeah, pretty neat, Darkolotto, and that's so cool that you found that. Are you out there working again? Is this an active thing? Has work resumed at the that Pliocene site? Site is just lousy with gomps. It's incredible. That's really cool, Darkolotto. Yeah. Well, they have a fair number of toe bones too, so that's a fairly common element. That's really cool, Darkolotto. So for anybody not in the know, Darkolotto, who's been a community member here and a stalwart supporter of paleontologizing, she decided she was going to actually go try and volunteer on a paleontological dig, and she's been finding all kinds of cool stuff, which is really, really awesome. So, big congratulations to Darkolotto for contributing to the field of paleontology. You too, everybody in chat, can also do that if you really want to. There's probably opportunities around. Some closer than others.
Every corner of that world.
And Neil, thank you so much for the 4 months of support. I really appreciate that, Neil. Thank you, thank you. 4 months. Good stuff, Neil. Good stuff. Thank you, thank you. Yeah. And Darkolotto says, today was my last day at the site for the season, but it's going to keep going for another month or so. Nice. Very cool that you found a cool element like a phalanx on your last day, Darkolotto. That's really awesome. Yeah. Very, very cool. Yeah. And Sergeant Raccoon, I understand. Yeah, you go pay your dog some attention, and I hope you feel better soon, Sergeant Raccoon. Yeah. Yeah. Anyway, still no word from Arachnia, so maybe we'll skip the fossil whales thing and we'll just jump into some fossil news. But, oh, and very cool, Darkolotto. Hey, I would love that. Big email full of pictures. That'd be really cool. Maybe I could show that video again. But cool stuff. Yeah. Why don't we jump in to some fossil news here? Here we go. This is going to be pretty cool. We've got a whole host, well, at least a couple of different interesting dinosaur news items from Spain. And this is one of them. So let's play our fossil news sting, and then we'll jump into that. Fossil news starts right now. All right, welcome to Fossil News. It's the part of the broadcast in which we talk about newly published paleontological discoveries, various other things too. And Dr. Tara's sending us some YouTube links. Let's see. T-Rex contest. Let me open these up. Yeah. Oh, I did see this the other day, the Tenontosaur in the Woods thing. That was pretty cool. Yeah. But right now, we're talking about some fossil trackways from Spain. Dinosaur swim tracks, not swim trunks. Swim tracks. From the Lower Cretaceous of La Rioja, Spain, an ichnological approach to non-common behaviors. This is some pretty cool stuff. So these odd-looking footprints appear to be evidence of swimming behavior in these dinosaurs, which is pretty cool. And these look like they're supposed to be from a theropod. These look like theropod tracks, kind of Gralator or Eubrontes style. These look almost more like ornithopod tracks, but they're probably another theropod. Yeah, and here is the article. I will give you a link to it. Yeah. Dinosaur swim tracks from the Lower Cretaceous of La Rioja, Spain. An ichnological approach. Ichnology is the study of trace fossils. So using trace fossils to study non-common behaviors in these animals. Pretty cool stuff. Yeah. And let's go ahead and download that PDF there. And thank goodness this has been made freely available, without any paywall at all. Pretty nifty. Take a look at that. You love to see it. You really do. Yeah. So let's take a look at the abstract real quick. The abstract is basically a short summary of the paper, kind of describing the research. And it says, the reconstruction of behavioral patterns performed by non-avian dinosaurs, it's dinosaurs that aren't birds, as an important task of paleontology in order to globally understand how these animals interacted with their environment. Their relation with aquatic lifestyles has always been an intriguing question that has been extensively studied during the last decades, especially found in some specific groups. Present work describes a new track site with 27 swimming tracks located in a fluvial setting, that means like a riverbed setting, in a river, from the Lower Cretaceous Urbion group of La Rioja in Spain. They are preserved as natural casts with sizes between 8.5 and 29.2 centimeters, and a predominant orientation. Tracks have been classified into 6 different morphotypes according to their morphology, and grouped into 5 different categories depending on the different Pez substrate interactions. So how that dinosaur's foot was actually interacting with the bottom of the river, that's going to leave different kinds of traces. If it's a heavier dinosaur that's sitting lower in the water, in a shallower environment, it's going to leave a deeper track, etc. Some tracks were produced while the animal was moving in partial or complete buoyancy, and displacement was conducted by water and sediment impulsion, and not just a mere paddling. Other tracks could have been impressed in a bottom walked. I guess by walking in the bottom, which might have been kind of weirdly translated. When the track maker touched the digit tips on the ground vertically or subvertically. This new track site confirms the capabilities of some groups of non-avian dinosaurs to interact with shallow water environments where they could print their peds as they moved. Where they could reach the bottom is what they mean. I'm assuming this is originally written in Spanish. Either in complete buoyancy or during a displacement with some vertical component in the water column. This is really, really cool. So, and this is lovely. I've been out collecting dinosaur tracks in the field in the Frontier Formation, which is what, like Middle Cretaceous, I think? Frontier Formation. We were right on the Continental Divide, like basically right on the border of Montana and Idaho, kind of near where Oryctodromeus has been found. And we found some fossil tracks. They weren't None of them are quite this pretty. That is gorgeous. Holy cow. Lovely photo from the field right there. Isn't that neat? Yeah. And yep, it is mentioned in that prehistoric planet thing there. See, Rex? I told you we'd be talking about tyrannosaurs. I'll probably show you that in a minute here. But very cool. So there's the Laguna track site right there. In La Rioja province in Spain. And very cool. Natural cast layers narrow, indicating some of the natural cast and showing abrupt changes in thickness of the original track layer. Very, very cool stuff. So trackways are one of these amazing things, like a lot of other trace fossils, because they're actually showing you what the animal was doing when it was alive. With other fossils, what we call body fossils, that's much more difficult. Like, you're dealing with the remains of a dead animal, and so you can't necessarily infer behavior from that very easily. You can guess by looking at the, at the skeletal anatomy of a dinosaur. You can make good inferences, solid inferences about what its musculature would be like, what kind of muscles it had on its body, and how it would have moved based on that. But you're like kind of several layers removed. There's a lot of work that has to go into that, and there's a lot of kind of interpretation there. So if you're trying to figure out how did dinosaurs actually move, one of the best ways to do that is to look at the direct evidence they left of their movement. Footprints. Footprints show you what they actually did. It's one of the reasons why this is so cool. Cryolophos, how are you doing? Welcome to Paleontologizing. Is your name a reference to a certain Antarctic theropod there, Cryolophos? Because if so, you're in the right place. Welcome to Paleontologizing. Yeah, wonderful. Great to have you here. Let me know if you got any questions. So yeah, very, very cool. And I love how they've digitally mapped this like this. Like made a computer model. Really, really cool. And look at these beautiful traces. Just aesthetically, they're gorgeous. These tracks here. Lovely, lovely. Very cool stuff. And those are just kind of swipes along the bottom with the pedal unguals, the toe claws going across the muddier, sandy bottom of this river. It looks mostly muddy, actually. Yeah. Very cool. Very, very cool. And they've got that figure there. Oh, man, it would be great if they could have... They probably didn't have the budget for this. But if they could have hired a paleo artist to actually reconstruct several of these animals swimming. Like a life reconstruction.
Dave gifted a tier 1 sub to Cryolophos.
Thank you, Dinosaur Dave. Holy cow. Really appreciate that, Dinosaur Dave. Thank you. That's fantastic. Yeah. Yeah. And look, we're now at... We're 1/40 of the way to our sub goal for the day. Thank you, Dinosaur Dave. Appreciate you. Cheers. And enjoy those emotes there. Cryolophos. Yeah. Thank you for getting us started, Dinosaur Dave. Appreciate that. These emotes like these and these and these and these are now yours to use as you please, Cryolophos, all across Twitch. So yeah. Yeah. And I have not... Have I seen a new trailer for that? I probably have, Dinosaur Dave. It's called Dinosaurs Amazing or something, right? Yeah. And how you doing, Team Sonic Gaming? Welcome, welcome. We're discussing some fossil news today, including these really cool diagram here about how these traces would have been left. And this is really neat. I love how they match these up with like what the foot is actually doing there in the substrate. This is really cool. I like that diagram a lot. Oh man. Hypotheses for the different footprint group formations, the successive step of foot movement, and the generation of the depth profiles and footprint shape in apical view. Really, really neat. So yeah, again, if you would like to read this yourself, it is open access, no paywall, and there is the link right there. You know how much we love open access science on this channel. Enjoy it. Yeah. Now, to show you kind of why that's relevant, let's pull up this clip from Prehistoric Planet. Could T-Rex really swim? So, one of our chatters, Rex, the Tyrannosaurus Rex, who, as you might guess, is very interested in tyrannosaurs. They were saying, oh, could we watch a video about tyrannosaurs? Well, here you go. Take a look. Yeah. Could dinosaurs like Tyrannosaurus swim? And how can we say that? And let loose with that question, Cryo. I want to hear it. Yeah. We're all about Q&A here. And I really love these little videos they put together to kind of accompany Prehistoric Planet. Good stuff. Could T-Rex really swim?
The skull of Tyrannosaurus Rex, surely the most terrifying hunter that ever existed. These huge teeth are evidence enough of its efficiency as a hunter, and studies of the skull have also shown that it had an acute sense of smell. But what evidence is there that it ever went for a swim? The sight of a Tyrannosaurus Rex swimming with his young may seem surprising.
I so love that they opened up the whole series, Prehistoric Planet, like the initial shots are of a swimming T-Rex. Because to me, what Prehistoric Planet was all about was kind of reintroducing the idea of dinosaurs to the general public in a way that's thought-provoking and deeply authentic and just really engaging, you know? So kind of taking T-Rex and putting it in a situation that would surprise a lot of people, but one that is perfectly feasible, one that we actually have evidence for in the fossil record, at least to a certain extent. I think that's really, really cool. This is some beautiful science outreach, you know? I love it. Love it. Not monstrous carnivores that do nothing but kill. Exactly, Jodyfish, exactly. This is not a 65 style T-Rex. You know, this is an animal. Yeah. Hang on, let's check on the 3D printer again real quick. And, oh boy, the camera's frozen. Let me fix this. Deactivate, reactivate. So far, so good on the 3D printer. But that one corner is where it messed up last time. Let me take a look at that. I will continue playing this for you in the meantime. Here we go.
But like all of the dinosaur behavior in Prehistoric Planet, this is backed up by some remarkable science.
It's going well. It's going well.
These mostly land-living predators were massive, 13 meters long and tipping the scale.
Ooh, shoot, I'm sorry, I missed that question. Thank you to Claire Burr for reposting that. You know, anacondas give birth underwater. Do you think that Paleophis and other prehistoric marine snakes could do the same? Presumably, yeah. Yeah. To my knowledge, there are no... Are there any modern sea snakes that lay eggs? I think they're all viviparous, aren't they? Maybe sea crates. I'm not sure. But anyway. Yeah, I don't know. For whatever reason, it seems like that branch of squamates, that huge clade, you know, mosasaurs and snakes, and some of their relatives, they've got a really... It's not difficult for them to switch to vivipary, to live birth. So yeah, Paleophis probably did, I don't know, maybe did give birth in the water. I see no reason to say it couldn't, but I don't know. I'm definitely not an expert on fossil snakes. But great question, Krylofos. Great question. Welcome, Brannington. And yeah, Ghostly Ghoul says, are we still not sure if the T-Rex is a hunter or a scavenger? It was almost certainly both ghostly ghoul, as you see actually just in this segment from Prehistoric Planet. You see Tyrannosaurus both hunting and scavenging. So yeah. And Krylophus says sea kraits and sea snakes do lay eggs. Really? Even like the beaked sea snake and the ones with the big paddle tails? They lay eggs? Enhydrina schistosa. Distribution. Venom. I didn't think these guys laid eggs. Yeah. How many sea snakes are viviparous? Except for a single genus, all sea snakes are ovoviviparous. The young are born alive in the water, where they live their entire lives. Wait, what? But ovoviviparous means that the eggs are held within the mother and the eggs hatch inside of her, and then the young emerge from there, right? Yeah. The one exception is the genus Laticata, which is oviparous. Its 5 species all lay their eggs on land. Interesting. So this is what I was thinking. I thought that most snakes basically give birth live in the water, even if it is kind of a halfway. Like, kind of like we think mosasaurs would have done, where they still produce like an egg that has a shell, but it hatches inside of the mother and then the young kind of scramble out. Oh yeah. Interesting. And there we go. Thank you, Jody Fish and Claire Burr. It's a good question there, Krylophos. It's a very specific question. I like that. Again, really glad you're here. Welcome to Paleontologizing. I saw that in my notifications the other day that you'd followed, and I'm like, this sounds like somebody who's interested in fossils. So I hope you feel right at home here. Welcome. Yeah, here, let's continue this right here.
Was it around 10 tons?
Report. Very cool, Krylophos. Great to have you.
Not perhaps an obvious candidate to be a swimmer.
T-Rex is part of a group of dinosaurs called the theropods. That's the predatory dinosaurs. And one of the key features of this group of dinosaurs is they had large, very muscular bird-like hind limbs, which were mostly built for walking and running.
But such legs would also be effective in swimming.
Yeah, certainly.
A powerful kicking motion would have allowed theropods like T-Rex to cross large bodies of water.
Pretty cool. Which, again, might seem kind of nuts, but there's many big animals that do that today. Well, many big... there's a surprising number of large animals that do that, I suppose. I don't know if we could say many, you know, after Pleistocene megafaunal extinctions. But you know what I mean. Let's continue.
And in the fossil record, there is direct evidence for exactly this.
Yeah, here we go.
Score-like marks, known as swim traces, created when the claws of two-legged dinosaurs like T-Rex scraped sediment on the bottom of lakes, rivers, and the seabed as they swam.
Pretty cool. Yeah, this is precisely what we see in this publication here. Which is really, really neat. I mean, excuse me. How rude. Pretty awesome stuff. In fact, I kind of wonder whether this is one of the sites that they referenced there, and they just didn't talk about where because it hadn't been published yet.
And
but
the
anyway,
seabed as they swam.
We've got other trace fossils like this from, say, the Paluxy River in Texas. The Paluxy River is a river now, and it just kind of coincidentally used to be kind of a fluvial environment, kind of a river environment back then, too, when there were dinosaurs walking around about 110 million years ago, give or take. You know, the Cretaceous. Very cool stuff. Very cool stuff. And Claire Burr
distance.
Kleber says, presumably these places would have kind of lacked current. Otherwise, these scratches would have been washed away. They were partially washed away. They are definitely smoothed over by some current. But also, you got to think, these are like big animals, and they're leaving fairly deep gouges in there. And so, even if it's getting washed away a little bit, it's not... Yeah. For one thing, this wouldn't be like a rushing river. You know, there's no rapids or anything through here. Any place where you've got sediment that is this fine, you know, basically like silt or very fine sand or mud, that means that it's a very low energy environment. I wonder if I could find you a video about that, but this is one of those things that I always think is really cool because it kind of has applicability to people's everyday lives. The next time you're near some flowing water somewhere, pay attention to the clast size. Let's see. Grain size, energy. I'm trying to find you something that'll talk about that. Grain size in river. Boulders, pebble, sand. Meander evolution simulation. Oh, let's take a look at this. This might talk about that a bit. But have you ever noticed that when you're near a river or a stream or even like a delta going out to the ocean, the size of the little bits of crud there on the bottom correspond to the level of energy that's flowing through. If it's a really high energy environment, and by high energy I mean like the water's got a lot of power, it's flowing really quickly, it's got a lot of force behind it, you're going to have larger clasts, larger, you know, bits of rock. In like a raging river with a lot of rapids, you'll have huge boulders and stuff like that. And how did those boulders get there? Well, they were carried there, and then they basically go until there's no more energy to push them any further. All the little tiny bits of sand and silt and stuff like that would get washed way downstream from there. But the big boulders, there was just enough energy to bring them there, and then as the energy decreases, the closer you get to the coast, things kind of come out of suspension after a while. They tend to drop. And I wonder if this is going to talk about that. Let's take a look. Just kind of guessing here. I've never actually tried to find topics like this on YouTube.
A simple meandering channel was built for this simulation. Riprap was placed on the cut bank of this meander bend.
Okay. Man, this takes me back to like geomorphology class back in college. But yeah.
4 houses were placed at different locations around the 2 meander bends.
Oh, interesting.
Some portions of this video run at higher speeds than normal.
This is really cool. Has anybody in here ever used a stream table like this?
The river undermines the cut bank, causing it to collapse.
Man, I really don't know enough about this kind of thing, but I find it really fascinating nonetheless. Like, I've studied this sort of thing just enough to be really fascinated by it, and not enough for it to become mundane to me. It still seems like magic. That there's just these really simple explanations for why you get these different landforms that occur. It's really cool stuff. Yeah. Oxbow University. Yeah, we could get an Oxbow lake forming here. See right here, it's going to continue to cut into this more and more and more. Eventually, the stream is just going to flow straight through here.
Stream of the riprap.
Yeah. Really, really neat. But whenever I go walk to the beach...
This meander has migrated towards the home, leaving it perched on the edge of a cut bank.
Uh-oh. Watch out, home. Whenever I go to the beach and, like, the tide is receding...
Upstream of the riprap.
I love to see, you know, just kind of watch this naturally occurring on the beach. You get
These swirling currents further eat away at the
these
base of
natural
the
experiments right here. Yeah, it's really really neat. Very cool.
Now,
But this sort of
we'll
thing has
increase the discharge. Higher
oh, so they're going to
discharges tend to increase
put more water into
erosion.
there.
The riprap continues to keep the meander from migrating.
But look, this is getting eaten away right here. Eventually, this is just going to
Also
straighten out.
have accelerated
And we're going to have an abandoned channel right here. That'll turn into an oxbow lake. Oh, this stuff is so cool. Yeah. And we'll get back to the Tyrannosaur bit,
water, moving
Rex,
on the
in just a little
outside
bit.
of the meanders.
But, yeah. And Cryolophos, I don't think we actually have any evidence at all of crop milk. That sort of thing's really difficult to decipher in the fossil. Like, I don't think we have any evidence of that in the fossil record. How would that leave any sort of trace? It's a good question. We will be talking about enantiornithian birds later on in this stream. These weird birds with teeth, and looking at the shapes of their bills and the shapes of their teeth to try and figure out what they're doing in their environment. What are they eating? What are they adapted for? We'll get to that later on, probably in about an hour or so. But, yeah.
The meander neck is becoming thinner as it
Yeah,
is
check
eroded
that out.
from both
Like I
sides.
said, this is going to be eaten away, and that's just going to start flowing right here. We'll have an abandoned channel here, and that'll turn into an oxbow lake.
Eventually, the river will cut through the meander neck and bypass the channel in the bottom of the screen.
There you go. Oh, do we get to see that? Tell us we get to see that. Oh, it's starting. It's starting.
Spring sapping is causing the meander neck to erode rapidly on the upstream side.
Yeah, look at that. Oh, there goes a home.
The house has collapsed into the river.
Hope you had insurance. This is why geomorphology is so important. Oh, my goodness. Yeah.
Here is a close-up view.
And it's not even just one big flood and you got a shortcut. This just, even if you don't have a big flood, even absent that, it will still be eaten away by the flow of the river over time. And there have been times when this has actually caused, like, disputes over territory. Like, this actually has, like, geopolitical significance. We'll talk about that in a minute. I could probably find you a cool video on that.
Through the meander neck,
Yeah.
causing material to erode, otherwise known as spring sapping.
Yep.
Note that the house in the bottom of the screen has collapsed into the channel.
Hopefully some gold gets stuck there. Yeah, maybe. Maybe strange.
It will only be a matter of time before this meander is cut off by the river.
Tell us we get to see that. You don't stop before that happens, right? I want to see a dramatic... Oh, it's starting to happen. Another home fell in. Or maybe that was the same one as before. There you go. There it goes. Yeah. Ooh. Let's see it go. Let's see it go.
The meander is cut off, leading to a rapid increase in slope.
Very cool. It actually happened really decisively right there. I'm kind of impressed.
Channel erosion as the upstream portion of the
Yep.
channel downcuts to the level
there's-
of the downstream channel.
That's what we call an oxbow lake beneath it now. This is so really, really cool stuff. I realize it's very, very basic, but I feel like there's somebody in chat watching this and going, holy cow, that's really cool. You can upscale this to the point where, man, it's, yeah. Oxbow Lake borders. Let's see here. But there have been times when, like, the boundaries of U.S. states have had to change because rivers are things that are alive. They're moving. They're changing. Yeah. I wonder if, Oxbow Lake. Let me try river meander. State borders, maybe? Yeah. see here. Man, I thought there was gonna be like... Why aren't YouTubers all over this? Does Tom Scott have a video on? I feel like this would be right up his alley. Let's see. This might do it. Let's check this out. He's gonna shout at us for a minute, so maybe protect your ears. Maybe I'll turn it down too. That might help. There we go.
I am in Baton Rouge, Louisiana. How do I know that? Because it is written in enormous letters on this levee just here. And this levee is on the Mississippi River, the most important river in America. Not just because of the amount of water that it moves, but because of the amount of cargo. Look at all these barges just here that are waiting to have whatever they're carrying moved to the container ports. And
barge contents.
That line this river for
gotta get that barge content, you know?
But here is a problem, and something you might not know. The Mississippi River doesn't want to be here anymore.
Yeah.
You see, about a century ago, in the age of steamboats, there was a bend in the river, about 80 miles away from here, called Turnbull's Bend. And that took you 20 miles out of your way. And of course, we're humans, we don't stand for that. So a canal was built to cut that bend out the way. Now,
ooh, uh-oh. Amerispace says there is a peninsula that is part of America, but it is entirely disconnected from the U.S. You have to drive through Canada to get to the rest of it? Yeah. Yeah, it's called Alaska. No, I'm just kidding. Holy cow, we've got a big ol' raid from Ox Tiberius right now. Ox Tiberius, hello, hello, and welcome to Paleontologizing. How are you doing? It's great to have you here, Ox Tiberius. What's shaking? If anybody's here for the very first time, let me introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist.
Animals that have ever appeared on this planet.
Gyre Security, thank you for the follow. Welcome to Paleontologizing. Great to have you here. Ox, how did your stream go? First of all, I hope it was really, really good. Thank you for your raid. My name is Danny. I'm a dinosaur paleontologist. I'm a scientist who studies dinosaurs. Most paleontologists work on other kinds of critters, actually. Dinosaurs are just but one star in the great galaxy of paleontology. They're but one set of sand grains on the great beach of fossil science. If that analogy makes any kind of sense. Most paleontologists don't study dinosaurs. They study all kinds of other different fossil critters. But I work on dinosaurs, and I'm here to talk about dinosaurs and whatever else you might be curious about with regard to Earth history. Irisakai, thank you for the follow. Welcome to Paleontologizing. Yeah. Did you catch that? The first one wasn't actually a dinosaur. That was a Dimetrodon. But anyway, Yumel Jokan, thank you for the follow. Welcome, welcome. And it's just Tiberius, but... Oh. Alright. Tiberius. You got it. Thank you again for the raid. I really appreciate that. But yeah. Yeah. And we were just hacking web apps now that we're learning about dinosaurs. Hexorcism, it's great to have you here. You were going to learn so much about dinosaurs and about the world around you if you stick around here. We were getting off on kind of a tangent here. And thank you, Ivan99PG. Great to have you here. We were watching a video from this guy about how rivers move over time, and I guess he just kind of stands here and talks the whole time. But anyway, we were talking about grain size in different rivers and what that tells us about the amount of energy that's going through, the speed of the water, and how you can kind of measure that, and how by looking at the fossil footprints of dinosaurs, these are what we call swim traces. This is evidence of dinosaur swimming behavior. Because it's basically just like the tips of dinosaur toes going down into the mud and going on a river bottom. This sediment represents a river bottom there. You can tell based on how it is. It's clearly, these are fluvial sediments. These are river bottom sediments. There's little dinosaur scrape marks along here. And because we have stuff like this, we think that dinosaurs like Tyrannosaurus would have actually been pretty decent swimmers, which you see reflected here in Prehistoric Planet. So anyway, we'll get to all of that in a minute, but we've got a bunch of cool new people here. If there's anybody who's just watching and lurking, feel free to say hello. Anybody who came in with Tiberius there. I'm going to play you a quick little welcome video to introduce you to the channel. We're going to say hello to our good friend, previously recorded, Danny.
Who ruins a movie by telling you how it ends.
Natural Joel, thank you.
Some things we don't want to know. Important things.
And Exorcism, thank you for the follow, too.
He simply grew spears which projected
Welcome.
from his body armor.
I'm going to introduce you to our friend, previously recorded, Danny, and he's going to tell you a little bit about who I am, what a paleontologist is doing here on Twitch in the first place, and all that good stuff. So without further ado, let's call him forth. Previously recorded, Danny. Take it away. Well, thanks, present day, Danny. Well, if you happen to be new around here, then welcome to Paleontologizing. You may well be wondering to yourself, well, if this is Twitch, then where are the video games? I'm gonna level with you here. I don't really do much in the way of video games. I'm a paleontologist. My name is Danny Anduza, and dinosaurs are my area of study. But how in the world does a paleontologist end up on Twitch? Well, you're about to find out. When I finished high school, I moved to Montana and immediately started work at the Museum of the Rockies, which at the time was an unparalleled powerhouse of paleobiology. That program was built by this guy.
Famed paleontologist Alan Grant.
Well, kind of.
You consulted on that movie.
I did consult on all those
movies. And they said that the guy Alan Grant was you.
Yes. Yeah, well, fortunately, he didn't get eaten.
Meet Jack Horner, the real-life Alan Grant. He's one of the most prominent and controversial paleontologists in the country, a dyslexic MacArthur Foundation genius who never finished college and who says he doesn't care why dinosaurs went extinct. To him, the important part is how they lived.
It was at Museum of the Rockies, under the auspices of Jack Horner, that I learned how to be a dinosaur paleontologist. And a huge part of that I learned by working with Jack's final graduate student, a guy by the name of Denver Fowler, who would later go on to become curator of the Badlands Dinosaur Museum. Working with Denver, I did summer after summer of fieldwork in the remote Badlands of Montana. Together, we dug up more dinosaurs than we knew what to do with, at fossil sites numbering in the hundreds. In 2012, I discovered a new species of ceratopsian dinosaur, hopefully soon to be published. The next year, we excavated the world's smallest and youngest Tyrannosaurus rex. Then, we dug up a brand new ankylosaur.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
So we found its head, we found parts of its armor and plates, and so it should be a new species.
Not bad, right? Well, anyway, much like my fieldwork, my research also focuses on dinosaurs. For example, here's Triarchunkus, the last of the Alvarezsaurs, just published in July of 2020. One of my current projects focuses on Spinosaurids. I can't really talk too much about that until it's a little bit closer to publication, so stay tuned for that. Anyway, let's get back to how I ended up on Twitch. A couple years ago, things in Montana were declining rapidly, so I picked up and moved on to greener pastures. I'm so glad I did. And with that new perspective, I also realized that I have very little patience with the soul-crushing bureaucracy within academia. So for the time being anyway, I decided to take my career in a slightly different direction. I got hired for a job in early childhood education. As a teacher, I get to have a positive impact on kids' lives and help them find a passion for science. Then, when COVID-19 showed up, the school had to close. But that didn't stop the teaching or the learning. We just moved online. All right, friends. So we're going to be looking at a book in a little bit, but I thought we'd start off with a song. At 3, 2, 1. Oh, give me a home where the hadrosaurs roamed, where triceratops bellowed and grazed, where erosion uncovers bones we seek to discover, for to strike the whole world amazed. Home, home on the range, where the deer and the antelope play, where seldom is heard a discouraging word, and the skies are not cloudy all day. It was a pretty easy jump from teaching online to streaming on Twitch. I had my first broadcast in May, and I've been on here ever since. Now, I believe pretty strongly that any good scientist should also be a public servant. In my opinion, talking to everyday people about her science is one of the most important things that a researcher can do. I now have a golden opportunity to reach out directly to people where they are. This is what I'm all about, and now, thanks to Twitch, I get to share it with you. And I'm so happy to be able to do so. It's my intention to continue this mission of education by answering your questions, providing good science content, and working to grow this channel. And if you could help by following, or if you could afford it, by subscribing, I would be deeply grateful. So anyway, to my regular viewers, thank you again for sitting through this. To everybody who's new, welcome. I'm genuinely, earnestly glad that you're here. And I hope you stick around. We've got a remarkable little community here, and I'd be delighted if you join us. Anyway, let's go ahead and get back into it. So, present day Danny, back to you. Well, thank you very much, previously recorded Danny. And of course, thank you even more to our friend Tiberius for that incredible raid. I really appreciate that. And if any of you came in with the raid and you're still lurking, feel free to say hi if you want to. It's wonderful to have you here. Welcome to Paleontologizing. Yeah. Good stuff. Good stuff. And holy cow, look at this. We've got a beautiful Tinamou bird here to announce the gifting of 10 subs from Murph. Look at how excited this bird is. A little too excited, maybe. You might want to take cover.
Murph is overloading the system with 10 gift subs.
Holy cow, Murph. Thank you, thank you.
More likely that we're here today because,
really appreciate that.
by the luck of the draw, dinosaurs who had been dominant over mammals in ordinary times got felled in a mass extinction.
And thank you, Daikaiju.
Here to learn about more dinosaurs.
Really appreciate you, Daikaiju. Thank you for the 11 months of support. 11 months. Holy moly, I appreciate that, Daikaiju. And 10 gift subs from Mirth. If you're one of those 10 lucky recipients of those gift subs, well, I'm sure you're feeling, hopefully, just as grateful to Mirth as I am right now. Thank you, Mirth, for your support. I do this full-time now. This is actually how I put food on my table. This is my full-time job. You could call me the world's first full-time live-streaming paleontologist. Yeah. Our first full-time paleontologist live streamer? Whatever. Etymology is not important. The thing is, I talk about fossil science 5 days a week right here on Twitch, and you're making that possible with your contribution, Murph.
Blaming the dinosaurs.
And thank you, Bet Medler, for those 100 bits. You got it kicked off of the hype train there. Beautiful, Bet Medler. Really appreciate that.
Sure do.
Thank you. Holy cow. Yeah. Excellent stuff. And Kalma.
No other creature in the world looks like a half-plucked turkey and walks like a pot-bellied bear.
But Kalma does. Thank you for the 17 months, Kalma. Thank you. Really appreciate that.
Much larger mysteries still remain.
And Drusafate2, thank you for following. Welcome to Paleontologizing. Great to have you here. Holy cow. Kalma, 17 months is a long time to support any kind of Twitch channel. Thank you for supporting science outreach here on Paleontologizing. Kalma, that is, that's pretty stellar. And I'm grateful to you. Thank you very much. So yeah. And Krylofos, I saw your question a few times. Sorry, yeah, it was during the video. Do I think Protospirena would have been an apex predator in the Cretaceous seas of North America and Western Europe? I'm not actually familiar with that taxon right off the top of my head. Let's look it up. I wonder if it's a, is it an early marine snake or something? Oh, no, it's this guy! The kind of, like, swordfish look-alike kind of dealy. Yeah, very nice. Top predator? I mean, it depends on what you mean by top predator. These guys probably would have been eaten by larger fishes and probably mosasaurs, too. But yeah, I mean, it seems pretty well convergent on like a, you know, a modern sailfish or a marlin or a swordfish. Probably occupying a similar kind of niche. There are other animals that eat swordfish, but man, are they hard to catch. They're very fast. These guys, given that they've got presumably the same kind of tail, that tail, holy cow, evolved for extreme speed. You know, it's not like these guys are eating everything else in the ocean, but there's probably very few creatures who are eating them until they're, you know, until they're dead. Hard to imagine other creatures catching this. This might be, might well be the fastest vertebrate in the ocean at the time. But yeah. Yeah, what a neat critter. We've got another question from Rex, the Tyrannosaurus Rex. They've got an advice question here. I'm wondering, is there any way to start learning to become a paleontologist early? There is. You could do what I did. I'll tell you about it. I'm almost done with high school, and I want to start my paleontology career as soon as I'm done with high school. Very nice, Rex. Yeah. The best piece of advice that I can give you is to start working at a museum, if it's at all possible. Yeah. Let me tell you kind of a quick story. So back when I was in high school, growing up in the beautiful, sunny San Francisco Bay Area, where I live today, we don't have a lot of dinosaur fossils. And we don't have a lot of museums around here. But I was very lucky in that there was one museum that was just maybe a couple of bus rides and then a train ride away from where I grew up. And I started working there when I was in high school. I started volunteering at the University of California Museum of Paleontology on the campus of the University of California, Berkeley. Yeah, this is before I had a car. This is before, I don't know. So I would either get a ride to the train station, or I walked to the train station a few times, like 7 or 8 miles. And John E.C., hey, thank you for the follow. John E.C., welcome. And yeah, shoot, I think it was like the summer after my freshman year of high school, I started volunteering at UCMP. And this is the best piece of advice that I can give to anybody who wants to get involved with fossil science is, you know, of course, you can go to school, you can take all the right classes, you can do the right coursework, blah, blah, blah. But that's not what makes a paleontologist. What makes a paleontologist is actually doing work in that scientific field. Whether it's work in the laboratory, or in the collections, or out digging fossils in the field. And I was lucky enough to be able to get started really early on. I think I was like 14 at the time. I started volunteering at the University of California Museum of Paleontology. This is their one big dinosaur display that they have outside. Their one big mounted dinosaur skeleton. But it's, for the most part, a research collections. It's not really like a public museum. This is actually there in like a classroom building that the Tyrannosaurus skeleton stands. Yeah. Let's see if I can find... Oh, there we go. Yeah. So I did various things to help out at the museum. Here's me dusting the Tyrannosaurus skeleton. Yeah, I helped in collections. I escorted visiting researchers. I helped with specimen labeling and repair. Like tracking down specimens and stuff like that. There's the Tyrannosaurus again. When a donor to the university, presumably like an alumnus who'd had too much to drink during some sort of fundraising soiree, they decided to steal one of the claws off of the Tyrannosaurus skeletal mount. And it's just a cast, it's not the real bone. But still, it was really lousy. I ended up making a cast of one of the claws, and then gluing it back onto there, so our T-Rex would again have 4 manual unguals, 4 hand claws like that. Be back to normal. So yeah, this is me. I was probably 16 at the time. Yeah. So yeah, you know, just a few years ago. But this, more than any of the classes that I've ever taken, more than anything I ever did in school, this is what set me up to be a paleontologist. And I was really lucky in the sense that I already had a roof over my head. I already had, you know, at least one hot meal every day. I'd go home and I'd have dinner with my family. I didn't necessarily have to, like, bring in income at age 14. So I was in a position where I could volunteer my time. And that is really how I got started as a paleontologist. It was all because of that. And because of the connections that I made there, when I later went off to college at Montana State University in Montana, I was able to just start working in the laboratory at the museum there like that, because I had connections. I said, hey, yeah, I've worked with Pat Holroyd and Mark Goodwin and Bill Clemens. And so they're like, oh, yeah, you can come in tomorrow. We'll start you off right away. Start you off prepping some Triceratops fossils. More so than your, you know, the classes that you take or the degrees that you get. One of the things that I really like about paleontology, dinosaur paleontology in particular, is that even if you do come from like a working class background, even if you can't afford to go to school for as long as other people do, you can still become involved, you can still do important work, you can still make contributions to the science. And I've been lucky enough to be able to do that, even if my path has been a little bit unconventional in a lot of ways. Or maybe a lot unconventional. I mean, here I am on Twitch 5 days a week. This is how I make a living nowadays. But I'm doing fieldwork, I'm doing research, I'm publishing papers in scientific journals. I'm living the dream. And that all kind of started with me working at UCMP. By the way, they didn't have a volunteer program at the time. Like, that did not exist. I kind of had to... Well, I was lucky in that some of the people who worked there were receptive to the idea of taking on a volunteer. And nowadays, they actually have a volunteer program, which is pretty cool. So yeah. And Natural Joel, holy cow. I don't know why an alert isn't popping up, but thank you. There it is.
If they're removed, America loses them forever.
Natural Joel, thank you very, very much for that pledge of ongoing support. I really appreciate that. That is a recurring sub right there. Thank you, Natural Joel. That is extraordinary. I appreciate you. Holy moly. Yeah. Very cool. Yeah. Oh, and Johnny C. Sorry, I missed your message there. Johnny C. says, hello, brother. Hope you're doing well. Greetings from Greece. Again, greetings from the San Francisco Bay Area. Maybe not quite as beautiful as Greece, but it's close, Johnny C. Thanks for saying hello. Yeah, and Liminal Music says, amateur paleontologist here, do you really think dinosaurs are extinct? I mean, we've got birds, so no, dinosaurs aren't extinct. We've got over 10,000 living species of dinosaurs. Today we call them birds. So there you go, Liminal Music. Welcome, welcome. Yeah. Yeah, so anyway, Rex, the Tyrannosaurus Rex, if you can get yourself involved with a museum, you know, that is really I think the best thing that you could do, you know? Yeah. Alright, scrolling down. What do I think Lamasquama's plumes were for? Krylophos? Yeah, were they for gliding, or were they for display? I don't know, Krylophos. They could have been like a sort of a parachute device for jumping from trees if they indeed were arboreal. But I don't really know a whole lot about Longasquama, to be honest. Not enough to have a strong opinion on what its plumes were used for. It's a good question, Krylophos. For anybody wondering, Longasquama is this critter. Is it a basal archosauromorph? What is Longasquama? Is it a squamate? But it's this weirdo critter. Holy cow. Yeah. What a weird animal. Yeah. I always thought that, I think of Longasquama, this very, very cool, early Triassic critter? What is this critter? Let's see. Middle to late Triassic of Kyrgyzstan. All the specimens are in Moscow. The current opinion is that Longasquama is an ambiguous diapsid that has no bearing on the origin of birds. Well, yeah. So we don't know, is it related to lizards? Is it related to basal archosaurs? Shoot, we don't really know. But I can tell you, every time I see this, I think of Longasquama. Every time I see this, I think of Longasquama. I realize it's supposed to be a griffin, but that reminds me of Longasquama nonetheless. So, yeah. La cerveza más fina. Corona. I'm sure it wasn't intentional, but yeah. Anyway, what a cool critter. Yeah. Longasquama. And Rex says, I'm lucky to be so close to the Museum of Ancient Life in Utah. That is like the ideal museum to have near you, Rex. Go see if you can volunteer there. And here's some other advice. If anybody is in a situation, you know, maybe you come from a working class background. Maybe you can't afford to volunteer at a museum. You can't afford to spend a bunch of time giving free labor to an institution like that. See if they have any job openings as a custodian, as front desk staff, as anything. When I first sent an email to UCMP, my dad encouraged me to do this. He said, Mijo, say that you'd be happy just sweeping the floors there if they don't have a volunteer program. Anything to get your foot in the door. Anything to just put yourself where the action is. And it was really good advice. And so I started off doing all kinds of weird tasks. I spent one of my first weeks there numbering thousands upon thousands of turtle shell fragments. Just writing the same two numbers again and again, thousands of times. The locality number and the specimen number on all of these just thousands of shards of turtle shell. And that was kind of a task that you know, my mentor there gave me to make me kind of prove my mettle, you know? So yeah. But it was something important that needed. It's true, Jody Fish. It's true. It wasn't the most exciting of tasks, but yeah. But Pat wanted me to prove that yeah. That I could be trusted, I guess. That I could be, you know, that I'd be okay even doing boring tasks. And I think, does Pat show up in this video? Let's see. There's Lisa, there's Mark. I don't know if Pat shows up here. Let's see. Campanile fossils. This might be the same video over again. I'll show you what I'm seeing here. Sather Tower in Berkeley. You know, this big old clock tower, which is something of an emblem for the university, it's full of fossils. There were fossils in this before there was a proper paleontology museum at Berkeley. And, yeah, Pat is kind of in charge of those to a certain extent. But yeah. Berkeley fossils. Here we go. Yeah. This is what we're looking for. Yes, indeed. And I actually got to work up in the Campanile a few times while I was at UCMP.
It's such a landmark of the university. Like,
That's Pat.
The symbol that is unique to Berkeley. For students,
One of my favorite people in the world, Pat Holroyd.
Myths and legends associated with the Campanile. One of the most frequent ones we hear is that there are dinosaur bones in the Campanile. Sometimes they want to know if there are human bones in the Campanile. Neither of those things are true, but they are part of the mythos of the tower.
And I could be like, well, actually, Pat, there are some dinosaur bones in the Campanile, and that's because you have fossil bird bones from Rancho La Brea, and birds are dinosaurs, but we all know what she means. I'm not going to be like that, and I wasn't like that. So, yeah.
The first thing I always want them to know is, no, there aren't any dinosaurs in the Campanile, but there's something better.
Except for birds. Except not. I'm not going to be like that. Not going to be like that.
Bison and camels and things that you never imagined lived here in California, but are as much a part of California as anything else. There is something about fossils that captures the imagination because it tells you about the life of the past. You know, we often think about history as just going back a few thousand years.
It's true, Moosey Fade.
We actually have, especially here in
Moosey Fade is like, well, actually, technically, there's human bones in the Campanile whenever a human goes in to look for them. You know, you can't argue with that, Moosey Fade. You know what? Yeah, mind blown indeed. True. But yeah. From a well. There you go, Vigilanta. Oh, no. Yeah. Luckily, here on Paleontologizing, there is not a snooty scientist to be found anywhere. All of our scientists strive to be approachable, to be down to earth, and, you know, I try very, very hard to make this sort of place where, you know, where everything's relatable, you know? I don't want to be snooty or elitist or intimidating in any way, you know? I think that's one of the most important things about science outreach is to just be cool, you know? Just be chill, you know? Scientists, we tend to be very passionate people. As much as academia tries its darndest to beat that out of us, you know, we have this burning passion in us, this this simmering curiosity for the world around us, and I love that I can let that out 5 days a week here, and I hope that in some small way inspires you to foster that own curiosity in yourself too. That own, to foster your own passion for whatever it is that you're curious about with regards to the natural world around us. This incredible planet that we find ourselves on. So yeah. But yeah. And Cryolophos, I have a headache, so I'm gonna take a rest. Oh, thank you, Cryolophos. I hope to see you around sometime. You get some rest. I hope your headache subsides soon. Drink plenty of water. It usually helps me. Oh yeah. And Vigilantis says, one of the things I loved most about studying anthropology, where I did that, was that all the lecturers were slightly bonkers and unconventional and easy to ask questions to. It's so important. It really is. It really is. Yeah. I mean, let's be honest. Being completely normal is kind of a red flag. It's like, you've got to be a little bit kind of bonkers and unique. You can't be afraid to let your passion show in a field like this. Or maybe you can. I don't know. I know plenty of people who've advanced very far in the field, and they now have like full-on tenured jobs, and they hate their research subjects, and they're miserable. And I think part of being a good scientist and being passionate about what you do is being okay with being a little bit weird, you know? Yeah. We've got a fair number of freaks and geeks in science. And misfit jocks and weirdos and former goths and whoever else, you know? It takes all different kinds of people. There's as many different ways to be a paleontologist as there are different paleontologists, I think. And it takes all kinds. So yeah. Just try and be cool though, you know? Just be chill. If you're gonna be doing outreach to the public. That's what I say. Yeah. Can't be normal. I'm tall enough as it is. I'd rather be strike slip. Jody Fish with the geology jokes there. There you go, Jody Fish. Appreciate you. And how did I miss this? Here, we'll get back to the video in a second, but Smorphosaurus has got a finished Ceratosaurus drawing here. Let's take a look at that. Holy cow. Look at this. Very nice, Smorphosaurus. Very nice. I love the small forelimbs with the correct number of fingers there. Very nice, Smorphosaurus. Very nice. I like the coloration on it. And the fact that this is my favorite part. My very favorite part is the bright coloration on the nasal horn and on those lacrimal horns there too. Here's my Ceratosaurus model right here. So this animal has got these big, ridiculous display structures that it evolved on its skull right there. And these, I think it only kind of makes sense if those are brightly colored. Well, unless they were like a cassowary cask, actually, or the cask of some hornbills. But, I don't know. I like to have them brightly colored because if you have to make a decision about it, I'd say make them brightly colored to kind of shake people out of this complacency that they have that like, oh, old dinosaurs were just green or brown. No, dinosaurs, like modern birds, had full color vision. Dinosaurs could actually see more colors than we can, on average, presumably, because they've got the same kind of, you know, eye anatomy that birds inherited. That's where birds got their color vision. Birds can see more colors than we can. They could see partway into the ultraviolet spectrum. So it really only kind of makes sense to make dinosaurs brightly colored too. especially when they've got big, garish display structures as part of their anatomy like this. So very nice, Morphosaurus. Good work. Good work. Very nice. Yeah. And you can go follow Smorphosaurus. Smorph was working on this live on her channel, so go check that out. I love the little speck of blue right here too. That's really nice. Just a little touch of something a little bit extra. I like it. I like it a lot. Yeah. So yeah, good stuff. Yeah. And hang on, Bette Medler. Let's see. Bette Medler says, I wonder if it helps to be LGBT+. Kind of grew up alongside mainstream culture when realizing you're outside of it. Yeah, I mean, shoot, I think a lot of people in paleontology have got some kind of thing like that. We've got a growing number of LGBT+ people in the field, and that's, you know, it's always a good thing. You know, to have a diversity of different perspectives. Paleontology actually used to be pretty homogenous. Where, like, there was a time when almost all of the paleontologists in the world, they didn't even really call themselves paleontologists at the time, but like in Victorian England, you know, just about everyone was Anglican, white, male, English, maybe French. I guess the French wouldn't have been Anglican at the time, but you get my meaning. Yeah. But yeah, I don't know. With different life experiences, with different backgrounds, people bring new ideas to the table. And that is rarely a bad thing, in my opinion. So yeah. And in a lot of ways, paleontology is still fairly homogenous. But, you know, that's changing. It's changing slowly, and I think that's a good thing.
Those claws on the wings are once again invaluable.
St. Louis Mo, thank you for the 22 months of support. I appreciate that, St. Louis Mo. I really, really do. Yeah. So yeah. And Mayor Space says there's still only humans doing paleontology. Mayor Space, I gotta get that the permanent gift sub for you. I forgot to look into that this week. But you know what? Yeah, paleontology is a very human science. This is true, Mayor Space. Maybe that's why we have so much emphasis on early hominids. And derived hominids, too. But yeah. And Email Chokan says, Pith helmets. Hey, I will not hear any besmirchment of sun helmets. I don't know. Maybe it's just... Here in the States, we've got maybe a slightly different view of sun helmets, but I wear a sun helmet in the field. Yeah. Because it's just about the best thing that you can have in a hot climate when you're outside in the sun. You know? A sun helmet like that, there's a reason that the U.S. Postal Service issues these. It's not for fashion reasons, I can tell you that. You know, there's a reason why, you know, why the Viet Cong and the North Vietnamese army used sun helmets. And it's not for fashion reasons. It's because it's a very practical piece of equipment. Yeah. Here, I'll show you mine. This is my sun helmet that I wear in the field if it's very hot outside. I'll wear a different kind of hat. Unless it's above like 90 degrees, then I'll wear a sun helmet. Because there really is no better... There honestly is no better head covering out there. And the secret is right here in the band. So there's actually... You know, you can kind of slip a finger in there. There is some air that's allowed to pass between your head and the helmet itself. So that means if there's even the slightest breeze, it gets directed directly over the top of your head. And it's like analog air conditioning. I don't know of any other hat that does that. It's pretty excellent. This thing's probably saved me from heat stroke. I don't know how many times. But yeah. And Mayor Spaces, I've seen TV postal workers wearing sun helmets, but I'm not sure I've ever seen it in real life. Mayor Space, you live in Florida, right? I would think that would be sun helmet capital of the world. USPS Florida sun helmet. Yeah, shoot. I would think if postal carriers are going to wear sun helmets anywhere, it would be in Florida. But we definitely have a lot of... I see that a lot here in the San Francisco Bay Area. But, I don't know. Maybe Florida's Postmaster General doesn't encourage them or something. I don't know. So, yeah. But I do recognize what... Which chatter was it? I'm sorry, I'm forgetting who you were, and I didn't mean to jump down your throat about this. But yes, I recognize that, especially from a European perspective, pith helmets, which my sun helmet is not made of pith. It's like pressed plastic material. It's U.S. military surplus. Like in Europe, pith helmets are seen as like a symbol of like colonialism, the white man's burden, Rudyard Kipling, you know, Dr. Livingston, I presume, all that stuff. In the U.S., I feel like we don't have as much baggage associated with it because of the U.S. Postal Service, because of the Vietnam War, where the other side was wearing pith helmets, the freedom fighters, not the imperialists. You know, that kind of thing. So yeah, I don't know. But I can understand why my old crew chief, Denver Fowler, would be like, oh, I can't wear a pith helmet. Like, as a British man, I could do no such thing. And he doesn't actually talk like that. He wouldn't say no such thing. He's not snooty. But, anyway. Yeah. Mayor Spaces, I do live in Florida. I don't go examining mailmen all the time. Fair enough, Mayor Space. Fair enough. But yeah. Quite literally taking the pith. There you go, Troy Division. Yeah, here in the U.S., it's got a different connotation. It's associated with government workers, you know, working class people doing difficult jobs in the hot sun, and it's associated with the Viet Cong or the North Vietnamese Army during the Vietnamese War, the U.S. Vietnam War. So yeah. And no, you're good. You're good, Email Chokan. I appreciate you. And, again, any opportunity to talk about this kind of thing, this is something I'm, you know, it's a soapbox of mine. Here, I can show you, Jim Jensen's sun helmet. He was a paleontologist in Utah. Jim Jensen, yeah, he named Torvosaurus, I believe. Dug up a bunch of big old dinosaurs in Utah. There he is. You can tell who he is because he's wearing the sun helmet. This is what he would wear in the field. That's another military surplus one, like I have. There he is next to the forelimb. One of these big sauropod dinosaurs. Formerly known as Ultrasaurus. Today we would call it Supersaurus, I guess. But, man. There's sauropod paleontologist Matt Wadle holding the shoulder blade. That's just the shoulder blade. Just the scapula of Supersaurus right there. It's pretty nuts. Yeah. But anyway, when I got to visit, briefly, the Brigham Young University Museum of... Oh, thank you, Tommy Ploticus, for that gift sub. Appreciate that. I don't know what happened with the alert there. But, thank you. Appreciate that very much, Tommy Ploticus. Yumel Chokan, enjoy that gift sub. Enjoy not having to watch ads for the next 30 days. Thanks to that gift sub. This is Jim Jensen's field shirt and sun helmet that they actually have on display at the BYU Museum of Paleontology. And yeah, mine is a very similar design. I think his is probably U.S. Army military surplus, and mine is U.S. Marines. So you can tell it's slightly different. The number of like grommets air holes on the side is fewer on his. His might be World War II vintage, and mine might be Vietnam or something.
Have a moment where it was kind of heartbreaking?
No.
Sazi.
No, glue is cheap.
Ooh.
Welcome, Asazi, for the... thank you, Asazi, for the 3 months of support there. So, yeah. Anyway. Glue is cheap, Claireberry. Yes, indeed. Thank you for helping me afford it, Asazi, with your 3 months of support. Really appreciate you. Thank you, thank you. Cheese, grommet. Yeah, Mayor's Space. What are these called? They're not... Are they rivets? Are they grommets? Is it still a rivet if there's a hole in it? Because the point is to be able to let air go through. It's probably an eyelet. That's probably what it is. It's probably an eyelet. Yeah, that's what it is. It's an eyelet. Yeah. Yeah. Good stuff. Anyway, shoot, let's get back to... We've gone far afield from where we were. Let's go back to this video with my old mentor, Dr. Patricia A. Holroyd at UCMP. This is where I got my start as a paleontologist, so let me just show you this real quick. Then we will dive back into some fossil news.
It's such a landmark of the university. Like, it's the symbol that is unique to Berkeley.
Yep.
For students, there are a whole series of myths and legends associated with the Campanile.
There's a series of myths and legends associated with the T-Rex skeleton, too. Holy cow. So when I was working there at Berkeley, when I was in high school, there would be these tour groups that would come in, where a tour guide who would be very good at walking backwards while talking would be walking people through the Valley Life Sciences building here, and they'd walk past the Tyrannosaurus skeleton, and they'd go, oh, well, here's our Berkeley Natural History Museums. There's the Museum of Paleontology behind the T-Rex skeleton. And yeah, they'd say, this T-Rex skeleton is actually the biggest one in the world. Or it's the smallest one in the world. Or it's the only one in the world. Or it's entirely made out of wood. Or it's actually real bone. Or... And they just, it's like every tour guide had some sort of interesting fact about it that was completely wrong. This is a cast of a Museum of the Rockies specimen, which, that's a long story, but it's in Washington, D.C. now, the original. We kind of gifted it to the Smithsonian when I was working at Museum of the Rockies. But this is the Wonkel Rex specimen, previously Museum of the Rockies specimen 555. And, yeah, and people... it's like, do they have all these myths and legends about the Campanile too? And then I heard some tour groups one time. I heard a tour guide tell all of her prospective students, they're like, oh yeah, the Campanile right there. This is actually, it was a war trophy, and it was brought back to Berkeley after the Second World War. It was taken after the Allied occupation of Italy. That's why it's called the Campanile. It's like, that's completely false. Where do they get this stuff? Yeah.
It's the symbol that is unique to Berkeley. For students, there are a whole series of myths and legends associated with the Campanile.
Yeah.
One of the most frequent ones we hear is that there are dinosaur bones in the Campanile. Sometimes they want to know if there are human bones in the Campanile. Neither of those things are true, but they are part of the mythos of the tower. The first thing I always want them to know is, no, there aren't any dinosaurs in the Campanile. But there's something better, because it's filled with saber-toothed cats.
Something better. See, Pat is a mammal person and a turtle person. of course she's going to say that Pleistocene mammals are better than dinosaurs. And, yeah, I've got a lot of respect for Pat. So we'll let that slide. We'll let that slide for now. But saying that's better than dinosaurs, my goodness.
Dinosaurs in the Campanile. But there's something better because it's filled with saber-toothed cats and ground sloths and bison and camels and things that you never imagined lived here in California, but are as much a part of California as anything else. There is something about fossils that captures the imagination because it tells you about the life of the past.
Yeah, neon coffee cat, closed
captioning.
captioning.
About history as just going back a few thousand years, but we actually have, especially here in California, we have a history that stretches back millions of years, and we can see how the modern world came to be. We don't know exactly how many fossils we have in the Campanile, so we estimate there are probably
You bet,
close
Rex.
to
Thanks for
30,000
being here.
that are there, but only about 6,000 of them are entered in computer records.
Wow, so a lot of this stuff is not actually digitized. Which, yeah, and this actually looks like it's in the museum proper. This doesn't look like it's in the Campanile. This might even be in Mark's office or something. Anyway, Campanian, that's a stage in the late Cretaceous.
If you're feeling a bit cheated, try blaming the dinosaurs.
Thank you, GP
Do
Bear.
you know of any cases of island syndrome among dinosaurs?
Island syndrome. What do you mean, island dwarfism? GP Bear? What do you mean by that? Like getting smaller from being on islands? Because I do.
Everything has been touched at least once.
No, and by the way, have I not said hello to you, Aberrantologist? Welcome back, Aberrantologist. It is lovely to have you here. And I don't want you to feel neglected. Appreciate you being in chat. Yeah, for now, says Aberrantologist. I don't know what that's a reference to. I'm sorry, I missed that, but I'm sure it was clever, Aberrantologist. Good to have you here.
They pulled it out of the ground.
Yeah.
But in terms of scientific research, I would say fewer than 5% of all of our fossils have ever been studied. What we hope is that in the next few years, we'll actually be able to focus more on the collections in the Campanile and actually get that data also out there and on the internet for everyone to search.
Which is, that's a tricky thing to do. That's a big part of Pat's job is like organizing, well, being able to set things up so that visiting researchers can come to the museum and use those collections for their research. And that's kind of why we have a fossil collections there in the first place, is for it to be a resource to scientists to be able to conduct research on these extinct animals. So yeah, Island Boy Syndrome. Mayor Space, are you referencing this? Oh boy. Is this what you're referencing?
Island boy, and I've been trying to make. Oh, I'm an island boy. I'm just island boy. I'm just island boy. I'm gonna get key white grind. You're gonna keep
Is this island syndrome there?
I'm just out full gazing. I'm like, pull where I'm staying.
Anyway, yeah. No, island dwarfism is the thing that that we see in multiple groups of animals. Yeah. Be they elephants like that, where we've got dwarf elephants from like the Channel Islands off of California, or we've got dwarf titanosaurs, which is pretty neat. From Europe, from the late Cretaceous, there's Europasaurus right there. And there is actually a there's an episode of that old goofy documentary Dinosaur Planet that kind of uses this as a major plot point. There we go. The episode was called Pod's Travels. And there's a dromaeosaur who, he's kind of in mainland Europe, and then he stumbles across a... Let's see. I'm trying to find this particular point. I think Scott Sampson might talk about that a little bit. Yeah, here we go. Check this out. And actually, just to be careful, we'll probably have to do it in this scene so that we don't get, YouTube doesn't freak out about this. Yeah. So anyway, the story is this dromaeosaur shows up on this island. He kind of washes ashore. Yeah, and there's some troodontids there. Anyway, he's like one of the biggest dinosaurs around on this island because it's a small island and everybody's involved, you know, insular dwarfism there. Yeah. Yep. Yes, indeed. Isn't that cool? And
well, it's so thin, it's about the same dimension.
strike a brink, strike a check.
The wall of a dirter. A dirter
Strike
is one
brink,
of those
strike a check.
things you get at the end of the paper towels, the cardboard thing in the middle, you go dir, dir, dir. Well, that's what this thing is like.
Oh, 9 months. Is it boy or girl?
Unless we find medullary bone, it's going to be impossible to tell, strike brink, strike a check, if it is a dinosaur. Welcome to welcome. Excuse me. Welcome back to Paleontologizing, strike brink, strike a check. Thank you so much for the 9 months of support there. I appreciate that tremendously. Thank you for keeping me here online for 9 whole months. That's a long time. And I appreciate your ongoing support. I really do. Let's get back to this. Yeah. Yep. That's nuts. Yeah. Those Channel Island mammoths, they got small. Yeah. Sort of. To a certain extent. Yeah, it's not like on Pangea dinosaurs were bigger than they ever were because there was more landmass that they could reach. That's not quite how it works. There's other constraints that work on it, but big animals that show up in small environments, they like get stranded on islands. Over tens of thousands of years, they will trend smaller and smaller and smaller because it's just more efficient to be a smaller animal in an environment with less food and less space, fewer resources. You're going to do better as a smaller animal, and you can have a larger population. Your genes will spread further if you've got genes that code for small body size. So yeah. Yeah. Anyway. Yeah. Yeah, that's one way to put it. Marooned Troodon. There's a bunch of troodontids that show up in that. I'll give you a link. There's a link to the full episode on the old YouTube. So check it out if you're curious about, if you'd like to see a dramatic recreation of island dwarfism and an earthquake and kind of a Gulliver's Travels sort of scenario. It's pretty wild, you know? Yeah. And then, like a final showdown between an Abelisaur and, Oh no! Yeah. Anyway, it's fun stuff. I think you'll enjoy it if you like kind of goofy dinosaur documentaries. So yeah. Anyway, and it's narrated by Christian Slater of all people. It's a little bit schlocky, but it's fun. Yeah. So yeah. Some birds becoming flightless on islands. Reasons are similar to this, and why kiwi have such big eggs. There you go, Nolo. Yeah, absolutely. We've talked about that on this channel before. For the same reason that you get island dwarfism in big animals, you get island gigantism in other animals. Creatures that typically start off small, things like, for instance, dormice. Like on small Mediterranean islands, they would get really big during the latter part of the Cenozoic era. Yeah. Giant dormice the size of cats used to live on Sicily. And it's because they didn't have predators to kind of constrain them to be small. Normal dormice today are small because that helps them hide from predators. You remove the predators, suddenly they can get a lot bigger. So big animals have a tendency to get smaller on small islands, but small animals have a tendency to get bigger. So it's an interesting, like, topsy-turvy kind of thing that's going on with that. Anyway, but yeah. Did Quetzalcoatlus live on islands, Tommy Ploticus? We've got very little fossil remains at all of Quetzalcoatlus, so saying anything about biogeography is a little tricky. Maybe they lived on islands? I don't know. Yeah. It would make sense if they nested there, but we don't really have direct evidence of that. Yeah.
Every specimen is exhibit quality, in the sense that when you look at it, you know what it is. You know,
yeah.
Skulls. And you look at it and you go, oh, that looks like a dog skull. People are like, oh, well, you know, why would you store fossils there?
The Campanile fossils were there from the beginning of the Campanile.
Before
Yep.
there was a museum
True.
of paleontology, there was a department of geology, and
This is the Valley Life Sciences building in which UCMP is housed. So I go here all the time. It's mostly classrooms in here, but there's also some natural history museums that are like research collections. And students work in there, scientists work in there. There's a lot of research that comes out of this building. And the VLSB, the Valley Life Sciences building, once upon a time, when it was built, this was the largest building in terms of area west of the Mississippi River. It isn't anymore. There's probably Amazon warehouses that are 1,000 times bigger than this. But anyway, yeah, the Valley Life Sciences building. And this is actually where there were a number of different Hollywood movies that were filmed here. Yeah. Filmed in VLSB Berkeley. Yeah. Yeah, I think the movie, was it Junior? The one with Danny DeVito and Arnold Schwarzenegger? Yeah. I'm pretty sure this was filmed in the... I want to say it was this one. It was one of those movies that DeVito and Schwarzenegger were in together. Yeah. The University of California in Berkeley. Yep. I have never seen this movie before. Yeah. But, there's a German poster. But apparently that was filmed in this building. Anyway, it's a big, important building, is my point. And, Shoot, where did that go? There we go. That's it there. So yeah. Yeah. It's dated but fun. I should watch it sometime. Yeah, truly our cultural pinnacle, says Bette Midler. Yes, American cinema, that was its peak. It's all downhill from there. And they did not bring it back from Italy, Fall Machine, no. Did he pronounce it Junior? Junior, hello. What are you doing? Get to Berkeley. Go to the Life Sciences building. Let's continue.
And these fossils were collected by J.C. Merriam, who was a faculty member here.
Oh, yeah, and holy cow. So, I know this photo of J.C. Merriam. So, yeah, J.C. Merriam. John C. Merriam. John C. Merriam, Paleontology. The exact, like, photo that they have here. It looks like this, and it's at... They keep it in the back room, or they used to keep it in the back room. And I used to say hello to this every day when I was a volunteer at UCMP, because this photo's got a really strange kind of aspect to it. Its eyes follow you around the room. When you're there and you're walking around, no matter what angle you're looking at this from, the eyes, like, follow you. So I would say hello to John every morning as I would come in, because, like, I don't know, it felt like he was right there. It was good stuff. It was good stuff. It's only a little terrifying. It felt rude not to. Exactly, Jody Fish, yeah. Like, he's just always looking at you. So I'd say, hello, John Merriam. Good morning. How you doing? I'm gonna go number some more of these turtle bits, or I'm gonna pick through this Judith River Formation matrix and try and find some more dinosaur teeth. Hope you had a good weekend.
This is
yeah.
not what paleontology is like.
Lucky Scarf, thank you for the follow. Welcome to Paleontologizing. Good to have you here. So yeah. And you are feeling better after hydrating and relaxing. Great to hear it, Cryolofos. Thank you. For coming back. And yep, there's John C. Merriam on the UCMP website. Yep. Anyway, very important figure in the early history of the University of California Museum of Paleontology. So here we go.
These fossils were collected by J.C. Merriam, who was a faculty member here. There wasn't enough storage space for all the fossils, and so they had to keep running back and forth across campus. And about that time was when they were building the Campanile. And they said, there's all this space available. Can we please use it for our fossils? Many parts of the collection are still housed much the way they were in the 1910s and 1920s.
Some of the original boxes and stuff. Yeah.
Actually, I probably shouldn't try to lift this, but it's too heavy. Whoops. No, that's okay. That actually happens fairly frequently. Other parts of it have been slightly upgraded, but not up to modern curatorial standards. This is the part of the collection that is also the most in need of more attention and particularly funding. I was up here yesterday with one of the graduate students, and she was frightened when she saw these shelves. She's like, they're sagging. This could just go any minute. And I said, well, they've been about to go any minute for more than 20 years. But
true.
But this is something that, we live in an earthquake zone, and this is the sort of thing that frightens me, to know that this is here, and if we ever have a big one, I will have to come and clean it up.
Yeah.
One of the things that's very nice,
because that's the thing, is that Pat is... This is like her purview. She's ostensibly in charge of this, but she's not given the funding necessary to actually have, better conditions for these fossils to be kept in. So, I don't know. That's got to be a frustrating position to be in, They also store a number of spiders in there. I think those spiders are more stowaways, Mayor Space, but Yeah. Yeah. Anyway, and Claire Burr says, I saw a compact. Oh, very cool, Claire Burr. And a certain kind of store that's very cryptic, Claire Burr. I'm sure it was on the up and up, whatever it was. But yeah, yeah. Anyway.
This is the sort of thing that frightens me.
Yeah.
To know that this is here, and if we ever have a big one, I will have to come and clean it up.
Yeah. Pfizer says, could she get some of the trade school people to come make some shelves for her? Maybe, Pfizer. In fact, I kind of volunteered to do this at one point. I don't know. I didn't know anything about carpentry at the time, but I'm like, I'll learn and I'll help work on some of this stuff. But there's a lot of bureaucracy in the way. Where it's like, no, you got to be permitted by the university to do this, and yada yada yada. So, anyway, yeah.
One of the things that is very nice about the campanile is that it maintains a fairly stable temperature, which is very good for fossils.
Yeah.
The campanile, as it turns out, is like a nice little refrigerator unit. It's never too hot, it's never too cold, and so it helps maintain the fossils and to actually maintain the structural integrity of even the smallest fibers in the fossils.
Very cool. And there's the Smilodon skeleton.
Is that we can rehouse them and really properly curate them to modern standards. To be able to do the whole tower would probably be...
This is one of this same rows that... it might be this one or it might be the next compactor over, but that's where the Berkeley ground sloth femur is housed, the one that was dug up during the excavation of downtown Berkeley BART.
Several $100,000 just in cabinetry. And then you need the people to transfer this to capture the data. There are so many new discoveries to make. I'm looking forward to sharing more of these stories. Most people don't have any idea that these are even paleontology at Berkeley, or they kind of have a vague notion of it. I at least can't imagine the campanile without the fossils in it, because it's just part of the story of the tower itself.
Yep. Pretty cool. Pretty cool. Here's a link to that video. Holy cow, it's got only 6 likes? And one of those is mine? Go put some more likes in there, everybody. Holy moly. Only 185 views. Let's rectify that. You know? Oh boy. But yeah, that's my old mentor. Well, my mentor when I was in high school. I don't mean to call Pat old. Dr. Patricia A. Holroyd, who is a mammal and turtle paleontologist at the University of California Museum of Paleontology. She was my mentor through high school, and without Pat, I would not be where I am today. I would not be who I am today. So, tremendous gratitude to Pat Holroyd. Yeah, one of my favorite people in the world. So yeah. For Princess Bookworm. Hey, Princess Bookworm, how are you doing? Welcome. Yeah. So yeah. So if Danny is 21, she is probably 22 or 23. Bingo, Fall Machine. Bingo. Yeah. Yeah. Anyway, yeah. Shoot, before we got off on that big tangent, we were talking about dinosaur swimming behavior from this new, Trackways paper that came out, showing swimming traces in these dinosaurs. Let's go back to the beginning of that, I guess. And, yeah, anyway. There we go. From Prehistoric Planet. So excited for the new Prehistoric Planet coming out in May. Can't wait. Gonna be fantastic. Such good stuff. Yeah.
The skull of Tyrannosaurus Rex.
Yeah.
Probably the most terrifying hunter that ever existed. These huge teeth are evidence enough of its efficiency as a hunter. And studies of the skull have also shown that it had an acute sense of smell.
Absolutely. That's because we actually have endocasts. Like, we can make a model of the brain of this animal, and holy moly, is the area associated with smell up here at the front of the brain. This is, like, freakishly large. So we know that this animal had an extraordinary sense of smell. Just mind-bogglingly good. So yeah. Yeah.
But what evidence is there that it ever went for a swim? The sight of a Tyrannosaurus rex swimming with his young may seem surprising. But like all of the dinosaur behavior in prehistoric planet, this is backed up by some remarkable science.
Pretty cool stuff.
These mostly land-living predators were massive, 13 meters long and tipping the scales at around 10 tons. Not perhaps an obvious candidate to be a swimmer.
But you'd be wrong.
T-Rex is part of a group of dinosaurs called the theropods. That's the predatory dinosaurs. And one of the key features of this group of dinosaurs is they had large, very muscular, bird-like hind limbs, which were mostly built for walking and running.
But such legs would also be effective in swimming.
There we go.
A powerful kicking motion would have allowed theropods like T-Rex to cross large bodies of water.
Sure. Yeah.
And in the fossil record, there is direct evidence for exactly this.
Not of Tyrannosaurus itself, but of other big theropod dinosaurs, certainly.
Score-like marks known as swim.
And Vigilantis says if they were featheries, does not seem less likely. There's plenty of animals that have got fur or feathers that swim like this, as you will see, Vigilanta.
Traces.
Yeah.
Created when the claws of two-legged dinosaurs like T-Rex scraped sediment on the bottom of lakes, rivers, and the seabed as they swam.
Yep.
Further evidence that Tyrannosaurus rex could swim has been found within its fossilized skeleton.
Yep.
Using a CT scanner, scientists found
those air sacs and hollows.
Bones have a hollow structure that would
Pneumaticity.
help massive bodies to float.
Pneumaticity is what we call it.
On the basis of this evidence, we think that T-Rex would have been an excellent swimmer and that it would have used this behaviour to expand its feeding opportunities.
To dispel any doubt that such a large animal would take to the water, you need only look at the animal kingdom today.
Yep.
Where some of the heaviest regularly go swimming.
So neither horses nor elephants have got hollow bird-like vertebrae, and yet they are still really decent swimmers. And they'll actually make, you know, elephants like this will go swimming in the ocean and have a raucous time doing it. It's a lot of fun for them, you know?
And that's true for some of T-Rex's modern relatives.
Yeah.
In the modern world, the animals that are most similar to T-Rex in general body shape are giant flightless birds like ostriches and emus. And perhaps surprisingly, these animals are really good swimmers.
Yep, they are.
There are places where these birds make sea crossings, sometimes of several miles, so they can reach offshore islands and find new sources of food.
So some people might be really surprised to hear that, but yeah, emus and ostriches, emus in particular, decent swimmers. And they can swim for miles. Imagine how much further a Tyrannosaurus could swim, you know? Pretty cool stuff, right? Yeah. SB Harkin says, I've swam a horse across a river once. There you go. Yeah. Yeah.
Giant flightless birds like ostriches and emus. And perhaps surprisingly, these animals are really good swimmers.
They are.
There are places where these birds make sea crossings, sometimes of several miles, so they can reach offshore islands and find new sources of food.
Pretty cool. Pretty cool.
But 66 million years ago, venturing into coastal waters would not have been without risk, even for T-Rex.
Uh-oh, here comes a mosasaur.
mosasaurs hunted beneath these waves.
Uh-oh. No spoilers here, but you'll have to watch Prehistoric Planet to see what happens. But yeah, dinosaurs like Tyrannosaurus could certainly have swum. And we actually have direct evidence of that from these fossil footprints. Like you see here in the Journal of Cretaceous Research, which we were talking about at the beginning of stream. Here is a link. And there we go. There. We've just finished that piece of fossil news, our first one for the day. And there you go. So yeah. Yeah. Krylofos says, have you ever heard of the Rhinogradentia family? Jeroboa could evolve since... Can't say I'm familiar. Is it some sort of mammal, Krylofos? Can't say I've heard of it. No. No. But yeah. Here, let's get rid of these tabs here. And, wait, speaking of swimming, this is not really fossil related, but it does have something to do with the beautiful San Francisco Bay Area, which is home to me. Friendly seal bites San Francisco man, sends him to the hospital. Very nice of this seal to make sure this man made it to the hospital after biting him. Certainly a feel-good story. I wish more marine mammals would call an ambulance after inflicting damage on... anyway. Yeah. No, I just saw this pop up the other day and I thought it was funny because this happened in a place where I've seen some cool marine mammals before. Yeah. When local librarian, and holy cow, I'm so glad this happened to a librarian and not a more reactionary person. When local librarian Miles Cooper went for his usual swim in San Francisco's aquatic park on Thursday, he felt something strange and large brush up against his legs. And let me show you what aquatic park looks like. It's basically like a little enclosed area. Yeah, Aquatic Park Cove looks like this. I wish they'd turn to the side so you could actually see it. But, here we go. Aquatic Park. It's like a popular tourist destination. It's right by one of the most touristy areas in the city. And it's a little cove where lots of people go to swim and stuff like that. It's just kind of inland from the Golden Gate Bridge. Ghirardelli Square is right there with the chocolates and everything. Yeah, very popular area. There's also the Maritime Museum right there with all these old ships and stuff. Really, really neat. But, there it is. So this is all enclosed by like a kind of seawall right here. It's a popular place for swimming. People moor their boats here. Yeah. A member of the historic South End Rowing Club, local librarian Miles Cooper was well aware that many harbor seals likely swam beneath them in the bay's murky blue waters. After all, they do bump swimmers every once in a while, just with their snout as a kind of a curious gesture, he told SF Gate. They're very friendly. It's amazing that I'm so glad that somebody who knows about these animals and is sympathetic toward them is the one who got bitten. Anyway, he just didn't expect one of these doe-eyed 285-pound mammals. They can't be that heavy. That's got to be like maximum weight. To bite both of his legs and send him to the hospital. I think it just wanted to play, he told SF Gate over the phone. It kind of felt like roughhousing with a dog. At first, the bites on his ankles didn't seem too worrisome. The teeth marks were faint, and as long as the skin wasn't broken, he wouldn't have to seek treatment. But as the day went on, they started to ooze a clear liquid that clung to his socks. Ew. That's why I had to go to the hospital to get antibiotics. Because pinnipeds, and I can't believe he knows, this is wonderful. Pinnipeds are seals and sea lions and walruses. He knows the term pinnipeds. Pedipeds have certain bacteria in their mouth that doesn't jive with our land mammal status, he said. Yeah. Anyway, interesting stuff. I'm glad this is... Man, if it had been a less knowledgeable person who'd gotten bitten by this, then you would see like a media frenzy about this, maybe. I'm really glad that such a learned person had this happen to him, because A, he won't be too upset about it, and B, there's not going to be any reprisals. Yeah. It's not going to be like this kind of a situation. I don't know. You're not going to have sensationalistic stuff like this. Weasels ripped my flesh. But anyway, this made me laugh. So yeah. Yeah. So Danny is happy when people of knowledge get bitten. I mean, better us than, you know, somebody who's going to write a story like this for an, you know. Anyway. And how you doing, Miss Yvette? Good to have you here. Yeah. So anyway, not really a piece of fossil news, but I thought it was interesting anyway. Because it's so local to me. Friendly seal bites San Francisco man, sends him to the hospital. And look how adorable these animals are. That is a harbor seal, the same species that bit this man. Probably mostly did that accidentally. Just kind of a little test bite. You know. So yeah. Yeah. Anyway. But, you know, stay away from wild animals. Give them their space. In this case, the seal bit the guy as he was swimming, so it's not really the guy's fault. But, you know, just a reminder. No matter how cute and cuddly an animal might look, give it some room if you see it near you. Give it some space. You know, don't get too close to it, because it might bite you. You know? Don't be like this, all up in its grill, you know? Don't do that. Don't do that. So yeah, seal is innocent of all charges, says Desmodus. Well, this wasn't the seal who bit him, but it's the same species, harbor seals. Yeah, they are very cute. They're very cute. But, you know, they're carnivorous mammals, and they'll, I don't know, they got teeth. They've got teeth on them. Look at those chickens. Yeah, Yup Goch, 200. Thank you for the follow. Welcome to Paleontologizing. Yeah. Let's take a look at a harbor seal skull so you can see those teeth. They got some chompers on them. They really do. Not the sort of thing that you want to become acquainted with, you know, on your... You don't want to have an encounter between those teeth and your skin. So yeah, give them some space. They're wild animals. Respect them. You know? Yeah. Cool critters. And seal of approval. Hey, Yop Coach, I'm glad you're enjoying this. Welcome, welcome. Here, we're now going to get into some more fossil news here. And let's take a look at this. And please, let's be mature as we're talking about this next topic. Keep your jokes clever and mature here. How mammoth poop is changing what we know about their extinction. And this is, of course, talking about the woolly mammoth, Mammuthus primigenius. These creatures that lived very, very recently. So yeah. Yeah. And about oceans on the moons of Uranus, says Deltarain. Is there news about that? Notice how I pronounced it, too? I think that's how a lot of astronomers pronounce it nowadays. There is? That's cool, Deltarain. I'm going to have to look that up after stream. But yeah. No toilet humor, chat. I'm not going to say no toilet humor, but I'm going to say keep it clever and keep it... I was going to say the word classy, but classy is one of those words that's like... It's almost kind of self-defeating. It's like the more a person uses that word, the less likely they are to engender its meaning in the way they carry themselves. But anyway, keep it classy and keep it clever, chat. So yeah. Anyway, when did woolly mammoths go extinct? Their fossilized bones say one thing, but their poop paints a messier picture. Oh man, this journalist was real excited to be able to use some wordplay there. A growing craze in the ecology world, and craze, oh boy, this makes it sound like it's hula hoops or something. No, this is a new methodology that's really exciting. Growing craze in the ecology world involves using DNA left in the environment called eDNA, environmental DNA, to learn about ancient ecosystems. A major study in 2022 analyzed eDNA and revolutionized our picture of prehistoric Greenland. But some scientists argue that decoding the past with left-behind DNA might not be as precise as researchers hope. Interesting. We actually covered this when it came out. Does anybody remember this? Oh, come on, New York Times. Yeah, goodness. Here. Try and find this real quick. But, yeah. This is back in December, I think. A 2-million-year-old ecosystem in Greenland uncovered by environmental DNA. We talked about this when it came out, and it's a really cool study. Yeah. And where was that figure? There was a really neat piece of paleo art that kind of reconstructed this ecosystem and showed all these animals all living together. It's not there. It is... well, shoot. There it is. Yeah, really neat stuff. Was anybody here for this? Yeah, you remember Golganek? Yeah. Yeah. But yeah. Anyway. In a much-publicized paper in the journal Nature, scientists claimed that mammoths survived in North America and Eurasia much later than previously thought, based on remnants of their poop left behind in ancient soil. But two fossil experts are butting heads with these researchers over their new way of uncovering the past. The conflict may reveal new insight to the impacts of climate change and humans on animal populations, from the prehistoric world to today. And this could have huge ramifications. Let me explain to you, maybe lay out some groundwork why this is important. Because there's a big debate right now in Pleistocene paleontology. So what do we mean by Pleistocene paleontology? The Pleistocene epoch is very, very recent. Like, let me show you. Let's switch to linear time here on our chart. There we go. So here's the age of dinosaurs, back here the Mesozoic. Then you get into the age of mammals, the Cenozoic. The Pleistocene is this last little sliver of the age of mammals before we get to today. So the Pleistocene is essentially like last Thursday, geologically speaking. Super, super recent. The Pleistocene is when humans spread out across the world and you know, people reached the New World by crossing the that land bridge over the Bering Strait from Siberia into North America, and then spread out down into South America as well. That all happened during the Pleistocene. And during this time, during the Pleistocene, you had these magnificent creatures walking around. You know, woolly mammoths, woolly rhinoceros, American lions, ground sloths the size of elephants. All of these different creatures, this is just in North America, all of the creatures that you see here. Mastodons, mammoths, dire wolves, short-faced bears, American camels, American lions, ground sloths, giant bison, and American horses. Really cool stuff. And then in other parts of the world, you had other huge Pleistocene mammals as well. Glyptodontians in South America. You had giant wombats and critters like that in Australia. There's a big old giant wombat type critter. Right there down in Australia. Yeah, and all of these critters seem to go extinct roughly the same time, just a few thousand years ago. Between like 16,000 years ago and 10,000 years ago. Which, geologically speaking, that's the blink of an eye. And why did these creatures go extinct so quickly? There's two kind of primary hypotheses about this. They're not mutually exclusive, although that's often the way that they're portrayed. The two hypotheses are it was climate change that killed them, or it was humans who killed them. And it's probably some combination of the two. But anyway, there's been a big debate over these two hypotheses. Because that's around the same time that the Ice Age ended. And we kind of got into our modern warm period. Our interglacial period, you might call it, like we have today. Yeah, so either like the climate changed and that's why all these animals died. But for some reason it kind of targeted only larger animals. And it seemed to kind of happen strangely at the exact same time when like people showed up in these environments. You could probably tell I kind of favor the overhunting hypothesis more. I think it might be our fault. And when I say ours, I mean human beings, Homo sapiens. It may have been overhunting by humans that did this. But there's a debate about this. And you can read more about this in, yeah. There we go. The Quaternary Extinction Event. You can read to your heart's content about that right here on good old Wikipedia. So yeah. Yeah. You've been reading on this today? Oh, very cool, Tommy Platicus. Awesome. Well, I'm glad. And is changing oxygen levels a myth? Mostly, Email. Yeah, yeah. Oxygen levels, we know, did not change significantly at this time. So yeah. And Spawny Bard says, why not both? .gif? Yeah. ¿Por qué no los dos? Yeah. It could have been that changing climate allowed humans to spread into new environments and exploit new sources of food like these remarkable animals. But yeah. Yeah, Andy then says, "'Twas a space rock." That's one hypothesis that seems to have zero evidence for it, is an asteroid impact. Yeah. Although you will see that in here, but it's like... Yeah, man, article has multiple issues. Get on that, Wikipedians. But anyway. And... my mouse is battery dying on it. It's acting kind of squirrely. But anyway, this is going to be a really long Wikipedia article, but you can read about it if... Yeah. Younger Dryas impact hypothesis. Arguments for/against the impact hypothesis. Yeah. Anyway, I don't think there's any reason to implicate an asteroid impact here, but yeah. Anyway, it doesn't really seem to explain why you've got different extinction events happening at different times on Earth, like thousands of years apart, if an asteroid impact is, you know, a singular event. It's like, why would the creatures, the megafauna in Australia, go extinct before those in North America, like thousands of years before, and then hundreds of years after the ones in North America, the ones in South America go extinct? It doesn't really explain that very well. But anyway, yeah. But yeah. Danny, can I say why I think this is helpful for the environment, mammoth feces? Sure, Krylofos, yeah, go for it. Yeah. Anyway. Yeah. Do I think mammoths did the same with more meters spread to the dung beetle? Krylofos, I mean, mammoths would have been what we call ecosystem engineers. This is totally a thing. And so, also, this might kind of help explain why wiping out just a few species may have had rippling effects, but, ecosystem engineers. Let's take a look at this. Yeah. Here we go. This will help explain that. Hang on. Yeah, here. Let's hope this is decent. I don't know. Not off to a good start.
Elephant. Elephants are regarded as keystone species because they are essential to the health of our ecosystem. Keystone species are those that are crucial.
No. Let's have something else. Let's see here. Let's try this. Yeah, elephant dung in ecosystems. Here we go. Yeah.
Here in Amberselly with some wild elephants, some of our friends and study subjects.
Oh.
And today we want to talk about elephant dung. So elephants eat a lot. They build these huge bodies.
Mammoths are a kind of elephant, by the way.
It takes a lot
now
of
extinct.
food to do that. We have estimated that elephants eat about 18 to 20 hours in a day.
Holy
depending
cow.
on how nutritious their food is.
Yeah.
You can see how much elephants eat, and you can see they do it pretty constantly. The good thing for us is that elephants do loads of other things at the same time as eating, but it's a background activity for them. Basically, if they're awake, they're eating. Whatever goes in has to come out again. And that has a really big effect on the ecosystems that elephants live in.
Huge effect on the ecosystem.
Ecosystem engineers. Elephants, when they're born, they're suckling milk from their mothers. But they learn about the plant foods that they can eat, and they learn about how to eat them from watching other elephants, from picking up bits that mum drops, or from reaching up into her mouth and smelling and tasting what's going on. And they start doing that from a very young age, from like 2 or 3 months old. They'll start experimenting, even though they're taking most of their calories from their mother's milk. And that's really, really important for them and absolutely crucial for their survival until they're 2. By the age of 6 months, you'll find them feeding pretty regularly, and they'll just be tasting different
Too
plants.
cute indeed, S.V. Harkin. Yes.
What you find, though, is that it takes them a long time to learn the processing skills that they need. For some,
And yes, indeed, you can make paper out of elephant dung, Golganek. Yes, indeed. Maybe I'll show you a video about that. It won't be as gross as you think. But it's so fibrous that it's, you know, it's like wood pulp. You can make paper out of it. It's pretty cool.
some grasses, elephants kick up the roots because that's where most of the sugar and most of the energy is. And learning to do that behavior takes calves quite a long time.
Huh.
Elephants eat lots of different kinds of plant foods. The elephants that live in the Central African forests eat a lot of fruit. Elephants in Amberselly eat a lot of grass because that's what's available. But elephants are just like humans. They need a balanced diet. These guys couldn't survive by living on this all year round. They have to move across their habitats and use different kinds of resources. And that's something that's true for elephants across Africa.
Very cool. Now into the...
Not like cows.
Yeah, getting into the ecosystem engineers part. Here, let me give you a link to that video if you want to watch the rest of it. But we're going to move on to this right here. Let's talk about keystone species here. And SciShow does good stuff. Let's take a look.
The original keystone refers to a wedge-shaped slab at the peak of a stone arc. If you remove the keystone, you risk the whole thing tumbling down. And some ecosystems work the same way, relying on one keystone species. In biology, keystone species have a disproportionately large impact on their habitat, given their size or numbers. Their daily activities affect all kinds of other species, directly or indirectly. And a change in their numbers can cause a trophic cascade, where effects ripple through the ecosystem, often in surprising ways. Take the gray wolves of Yellowstone National Park in Wyoming. Their numbers dropped.
Wyoming and Montana, excuse me very much. As a former Montana resident, Montanans are very insistent on the point that Yellowstone has got a little sliver in Montana as well. I'm sure people from Idaho would also say, oh yeah, there's a little sliver of Yellowstone in Idaho also. Yeah. Here we go. Almost all of it is in Wyoming. But this little section up here is in Montana. See, here's the state boundary right here. I'll draw it for you. There we go. Yeah. Come on, annotation software. You can do it. You can do it. There you go. Yeah. No, go away. Stop. Ignore. Stop. Here is the Montana border right here. So that's Montana up there. And then all of this is Wyoming. So it is true. Almost all of Yellowstone is within the borders of Wyoming. But there's a tiny little sliver in Idaho right here. And then there's a little bit in Montana also. So yeah. Yeah. This much of it is within Montana. So, you know, we also have one of the big gateways to, three. We, Montanans, have 3 of the entrances, to Yellowstone National Park. The west entrance, the north entrance, and the northeast entrance. And Wyoming's only got 2. So, yeah. Anyway. Don't ever let anybody tell you that, Yellowstone is a Wyoming national park, because you know what? Yeah, not entirely. Let's continue with our video.
Do you think dinosaurs are put together correctly? The bones. You're smart. What do you think?
Do a research on that, Oliver. I'd never...
Spuny Bard, thank you for the follow and welcome to Paleontologizing. How are you doing? It's good to have you here. Yeah. But yeah. Let's continue.
All kinds of other species, directly or indirectly. And a change in their numbers can cause a trophic cascade, where effects ripple through the ecosystem, often in surprising ways. Take the
So, gray wolves are a good example in Yellowstone National Park, in Montana and Idaho, and mostly Wyoming.
Gray wolves of Yellowstone National Park in Wyoming. Their numbers...
And I guess the wolves are probably in the Wyoming part, so, you know, actually... Fair enough. But, yeah. This is going to have possibly really important implications for the Pleistocene extinctions, too. given that these animals were also around in the Pleistocene. I mean, gray wolves were around back then. The dire wolves went extinct, but gray wolves survived.
Numbers dropped to 0 around the early 1930s, mostly because of hunting. But in 1995, wolves were reintroduced to the park, and the wolves' impact has been monitored ever since.
Pfizer is right. Here, pay attention. It's going to be cool.
Important. The wolves' absence and reintroduction changed Yellowstone in large and often surprising ways.
Right down to how the rivers flow. This is pretty cool. We were talking about river flow patterns earlier. We were talking about oxbow lakes and all that stuff. Did you know that the presence or absence of wolves can actually determine the flow patterns of rivers? It's so cool how this stuff is connected. I mean, holy cow, callback indeed, Claire Burr. Yes, indeed. Really, really cool stuff. Here.
And reintroduction changed Yellowstone in large and often surprising ways, right down to how the rivers flow. For one thing, wolves prey on elk, and the elk know it, so their behavior changes when wolves are in the area. Elk are generally nomadic, staying on the move as they munch on plants. But without any wolves around, the elk became much less cautious, preferring to settle down and eat a lot in one place at a time. The elk even ate all the way down to the riverbank, somewhere they wouldn't dare linger if there were wolves around. Instead of eating a little bit from a lot of different plants, they ate so much at a time that aspen and cottonwood trees declined. And so did the riverside willows that beavers and some songbirds depend on. And beavers are also keystone species because of their special engineering talents. Their dams slow the flow of rivers, preventing floods and offering a wide range of habitats for all kinds of species. Ever since wolves were reintroduced to Yellowstone, willows have grown better, beaver colonies have increased from just 1 to 9, and songbirds are flourishing too. Elk numbers declined at first, but now seem to have stabilized. And bison numbers are up, probably because of decreased competition from the elk. Research is ongoing to assess the wolves' long-term impact, considering the many subtle interconnections in this complex ecosystem. But as top predators, it's clear that the presence, absence, and then reintroduction of wolves has resonated throughout Yellowstone. And research into other wolf habitats will help work out what's unique to Yellowstone and what can be applied elsewhere. Elephants also do a lot to manage their environment.
So we've got another Pleistocene species here. Elephants, of course, existed throughout the Pleistocene, and now we've got them today as well. Mammoths and mastodons went extinct, but these guys are still around. And they play a really, really important role in their ecosystem. Imagine if elephants were kind of hunted to what we call extirpation or local extinction in a given area. How much would that change the environment? How much would that kind of make things fall apart for all of their neighboring big mammals? I don't know. I can't begin to tell you. But yeah.
From what goes on in their mouths to what comes out the other end. They're sometimes known as the mega gardeners of the forest. For example, without African forest elephants, a single species of acacia tree tends to dominate African forests. It grows fast and shuts out the light from other plants. And the elephants help counter that. They sometimes knock down acacia in their search for food, opening up space and a critical shaft for light. Other plant species seize their chance, adding to the forest's biodiversity. The smaller branches that they knock down provide hidey holes for lizards, which are more diverse in places where elephants roam. When reaching for leaves or fruit, they'll often knock off a bunch more, and these windfalls get picked up by smaller ground dwellers like warthogs, as well as the kudu, which is a type of antelope. All this eating results in plenty of dung, around a metric ton every week, and all that poop becomes a mini ecosystem all by itself, since it's rich in nutrients that the elephants couldn't process. Fungi live in it, as do insects like beetle larvae, crickets, and spiders. In 2009, 3 species of frogs were found happily living in Asian elephant dung. And of course, it's excellent fertilizer.
Imagine if you were that important to an ecosystem that your dung, your droppings, your poop provides habitat to 3 species of frogs. Holy cow, how cool is that? Can we see some happy frogs indeed? I was going to say, can we see some iOS froggy emotes in the chat? Yeah, rent free. There you go. Good stuff. Good stuff. Yeah. Pretty cool. You know, ecosystem engineers. Neat stuff.
Species grow better in elephant dung than in poop from any other animal. Their wide roaming and variation in movement make them especially good at spreading seeds to new places.
Yeah.
You don't have to be as big as an elephant to have a jumbo-sized impact on your ecosystem. Parrotfish are
Oh, I thought she was going to talk about sea otters. But yeah, parrotfish, man, the way that they eat coral. We wouldn't have beautiful white sand beaches were it not for parrotfish, which I think she'll explain.
named for their tough, almost beak-like mouth parts. These hardened lips are well adapted for plucking algae off coral, their main food source in their warm reef environment. It might not be glamorous, but it turns out to be vital to keeping the reef healthy. Without parrotfish, macroalgae can smother the coral to the point of killing it off. And no coral means no reef, which would be big trouble for these species that call coral reefs home. A major report covering 4 decades of research in the Caribbean identified parrotfish as a group to keep a special eye on. Coral reefs are generally having a tough time of it, with climate change, ocean acidification, and pollution steadily degrading the ecosystem. The parrotfish's maintenance work helps keep reefs resilient so that they can recover from blows like sudden heating or a hurricane. Caribbean reefs, where the parrotfish are heavily fished, are suffering the most. So the report recommends more countries adopt policies to save the parrotfish, and hopefully save the reefs along with it. So like all keystone species, they really hold their ecosystems together. Thanks for watching this episode of SciShow, which was brought to you by our patrons on Patreon.
Very, very cool stuff. And, yeah. Here, I want to show you another example with some, because here's an example where overhunting of a Pleistocene/Holocene mammal actually caused major changes in the ecosystem. And, yeah. Does anybody know who I'm going to talk about here? Oh. Oh, I love this. The title is Some Animals Are More Equal Than Others. Keystone Species and Trophic Cascades. And I love these videos from HHMI. Really, really good stuff. These are produced by scientists, oftentimes. Very cool.
From jungle to desert, from forest to plain.
Yep.
From mountaintops to the seashore. The Earth is home to many habitats.
Yep.
And every habitat contains a community of plants and animals.
Yes,
Each
indeed.
community is populated by different.
And so, shoot, with this, if anybody is new here and you're wondering, like, what, this is called paleontologizing. Aren't you supposed to be talking about dinosaurs? We're talking about paleontology. We're talking about fossil science, but fossil science is basically an extension of biology back in time. The understanding of modern ecosystems helps us to understand extinct ecosystems so much better. And the ancestors of all of these creatures, whether it's a whale shark or those prey animals there, we can find fossils of these, and this is all part of a continuum. This is all a big old spectrum right there. It's all connected, Email Chokan. Exactly, Email. Yes, indeed. Yeah. Yeah.
By different species. And each species is present in different numbers.
Big web of life. There you go, Claire Burr. Yes, indeed.
So what determines how many species live in a given place?
Ah.
Or how large each population can grow?
How's the volume? Should I put it higher? Can you hear it okay?
The answers to such basic questions about how nature works eluded biologists for a long time, until on this rocky Pacific shore in 1963, young zoology professor Robert Payne pried a purple starfish off the rocks and threw it out into the bay.
Ooh.
And so began one of the most important experiments in the history of ecology.
Wait, what? Guy threw a starfish into the ocean, and that had a huge impact on the history of ecology? It did, and Sean Carroll will explain why. And yes, indeed, Tommy Ploticus, I think Paul Martin was up to... I think his hypothesis carries a lot of water. He has a book about this called Twilight of the Mammoths. I have it right here on my shelf. Right there. I would recommend this. Twilight of the Mammoths by Paul Martin. And he's kind of advocating for what he called the Blitzkrieg hypothesis. Yeah. From the University of California Press, Twilight of the Mammoths, Ice Age Extinctions and the Rewilding of America. It's good stuff.
If it disagrees with experiment, it's wrong.
David Peterson, welcome, welcome. Holy cow. Thank you for your raid.
How beautiful your guess is, it doesn't make any difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all.
Yes, indeed. Welcome, David Peterson and Raiders. How was your stream? It's great to have you here. Thank you so much for bringing everybody here. If anybody's new to the channel, then welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. And we're talking about the extinction event at the end of the Pleistocene. This is the Pleistocene right here. It's practically last Thursday, geologically speaking. This is when you had... No, not weasels ripped my flesh. Where's our Pleistocene mammals? Pleistocene megafauna. You know, mammoths and mastodons walking across North America. Woolly rhinoceros and ground sloths and dire wolves and Colombian mammoth saber-toothed cats, American lions, American camels, American horses, giant bison. All these critters kind of at the end of the last ice age walking around in North America, South America, Europe and Asia, and you had giant wombats and things like that in Australia. Look at the size of that wombat. Holy cow. Diprotodon, which may or may not be a true wombat. I'm not totally sure. But anyway, it's a big controversy as to how these critters went extinct. Was it mostly due to climate change, the end of the Ice Age? Was it mostly due to human overhunting? There's some new evidence coming from fossil poop. There we go. How mammoth poop is changing what we know about their extinction. We're talking about this piece of fossil news. So welcome, welcome, David Peterson and Raiders. Great to have you here. Can we get one more shout out for David Peterson? Creator of Mouse Guard. And somebody was asking me earlier about David Peters, who is a real character in the world of paleontology. No relation to David Peterson, I presume. But, yeah. You know how you get kind of fun and interesting cranks in some different fields? Sometimes in science, David Peters is one of those in paleontology. No relation to David Peterson, who is an acclaimed artist in his own right, and yeah, one of the coolest channels here on Twitch. So check him out. Yeah. But anyway, Aberrantologist knows what I mean. Yeah. And Spoonie Bard says, I adore MouseGuard. Did you know that the creator of MouseGuard streams on Twitch here? Go follow him. Holy cow. Yeah. Anyway. Yeah. Oh, and I do wish you luck, Cryolofos. May you be confident of your knowledge. May your nervousness subside. May you ace that test. And then laugh about it afterwards. There you go, Krylofos. Yeah. So yeah. Good stuff. Anyway, welcome, David Peterson and Raiders. It's great to have you here. Welcome back to Paleontologizing. So we're talking about this, and we're talking about keystone species, first of all. Because elephants, including mammoths, are what we call keystone species. They are remarkably important. And, yeah. As this video title says, some animals are more equal than others. Keystone species and their trophic cascades. So, here, this is biologist Sean Carroll. Let's go back just a titch to get us resituated. There we go.
The answers to such basic questions about how nature works eluded biologists for a long time, until on this rocky Pacific shore in 1963, young zoology professor Robert Payne pried a purple starfish off the rocks and threw it out into the bay. And so began one of the most important experiments in the history of ecology.
Okay. Let's find out how. Yeet? Yes, indeed. Yeah. Animal Farm reference there. Oh.
So what brought Robert Payne to this rugged coast? And why was he hurling starfish?
Yeah.
The answer takes us back a few years to a classroom at the University of Michigan.
It was a lovely day. The old
pretty far from the ocean.
Arbor had a courtyard, and in that courtyard there was a tree which was beginning to bud out.
Professor Fred Smith asked his students a seemingly simple question.
And he said, "Class, I want you to think about this. Why is that tree green?" And someone said,
"Chlorophyll."
Fred said, "What keeps the leaves there?"
Although technically chlorophyll is what makes trees green,
yeah.
Fred Smith was asking a bigger question. He was thinking about food chains.
You obviously had producers. They are the energy suppliers to whatever lives off of them.
So these are, you know, your lowest trophic level on kind of the, you know, the food chain there, the food pyramid, I guess. They're probably going to illustrate it like a pyramid. I see those lines sloping inward. But these are, these are things that they take an energy from the sun and they produce food. They're kind of the basis of the food web.
And you have consumers on top of that. And you know them as herbivores.
Yep.
The popular idea at the time was that the number of producers limits the number of herbivores. In turn, the number of herbivores limits the number of predators that feed on them. Every level was regulated by the amount of food from the bottom of the food chain going up.
But it might turn out to be more complicated and more interesting than that. You know?
But this view didn't explain why herbivore populations don't simply grow to the point where they eat all of the leaves on the tree.
Yeah. Interesting.
Professor Smith had discussed this conundrum with two colleagues, Nelson Hairston and Lawrence Slobodkin. They proposed a new idea. The number of herbivores must be controlled not only from the bottom up, but also from the top down.
The herbivores had the capacity of destroying the plant community. Trees could be defoliated. But why weren't they defoliated? And the answer was, because there weren't enough insects around to do that, and that was the role of predators.
Yeah. Important stuff.
The world is green because predators keep herbivores in check. This was a radical concept that became known as the Green World Hypothesis. Up until that time, no one thought predators had any role in regulating ecosystems.
What?
This class was the first.
Imagine that. Imagine thinking that. But it kind of makes a lot of sense. I mean, if you look at policies around carnivores, back in the U.S., or, you know, there were bounties that were put on mountain lions in California. It's like, oh yeah, the government will pay you, you know, I don't know how much money to kill a mountain lion and prove that you did it. Because it's like, oh yeah, they're just predators and they're no good for nothing. Same thing happened in Australia, where the Tasmanian tiger, the thylacine. This remarkable creature here. Music is too upbeat for such sad footage. This is the last thylacine ever kept in captivity. The Tasmanian tiger. This looks like a wolf or a dog or something. It's not anywhere close to either of those. This is more closely related to a kangaroo or an opossum. It's a marsupial. And these creatures were persecuted by white settlers in Australia and driven to extinction. They were literally hunted to extinction because the idea was, oh yeah, predators aren't good for anything. You know? They don't really serve any purpose in their ecosystem. Just get rid of them and, make it, make it a better environment for human exploitation where you can raise sheep there and these critters won't eat them anymore. Little did they realize that these animals, apart from being beautiful in their own right, apart from being, worthy of our respect and our admiration and our protection just for being what they are, they serve a really important role in their ecosystem. They help keep the ecosystem healthy. So the last of these thylacines, I think, died out in 1938 at the Hobart Zoo. And nobody's got any definitive proof of anyone's ever since then. It's really tragic. But yeah. But at the time, even a lot of scientists thought, oh yeah, predators don't actually serve an important role in the ecosystem at all. So yeah.
Hypothesis. Up until that time, no one thought predators had any role in regulating ecosystems.
Which is nuts.
Class, this was the first public vetting of the Green World hypothesis.
Yeah.
And one of Smith's students, Robert Payne, would be the one to put this idea to the test.
And Cryolophos. Shoot, that might result in the animal's death. I don't know. Yeah. That's like its throat right there, Cryolophos. Ooh, I don't want to think about that. That's grim. But when those birds fight, they do occasionally go after each other's cooler pouches, I think.
Professor at the University of Washington, Payne went looking for a system where he could study the role of predators.
I discovered the Pacific Ocean and this magnificent array of organisms which lives along its margins.
Yeah.
There it was, spread out in front of me. It was nirvana.
He began by identifying all the organisms, and then he started mapping out who eats whom.
There were carnivorous gastropods feeding on barnacles. There were sea urchins feeding on algae. There was a lot of pattern.
His observation showed that a species of large purple and orange starfish called Pisaster ocratius was at the top of the food chain.
Interesting.
Starfish may seem like unlikely predators, but speed time up a bit and you'll see deadly hunters.
Yep.
If a starfish is feeding, you turn over and you see what the starfish is eating. They're eating mussels. They're eating a lot of other things as well, but they're eating mussels.
Yep. I don't know if you could really see that they're at the top of the ecosystem. And I'll see if I can find this for you real quick, but they are fed upon by dinosaurs today. Let's see if I can find that for you real quick. Yeah, where was that? Scrolling. But this was, I found this pretty amusing. The way they framed it was funny. Oh shoot, where was that? Scrolling, I'm trying to find it. Where was it? Shoot. There it is. So even top predators like sea stars occasionally fall victim to dinosaurs even to this day. So yeah. Good stuff. Anyway, yeah. But yeah, for the most part, sea stars, pretty effective predators, and they may not be at the tippy top, but they're high up there on the trophic web, for sure.
Deadly hunters.
Yeah.
If a starfish is feeding, you turn over And you see what the starfish is eating. They're eating mussels. They're eating a lot of other things as well, but they're eating mussels.
So Payne asked, what happens when you remove the predator starfish from a single outcrop?
Oh. And there you go, Krylophos. Yeah, they do that too. They can scavenge.
Down. It takes a strong wrist and a pry bar. I would then scale them as far as I could. And in those days, I could throw a starfish 60 or 70 feet out into deeper water.
Yeet!
There were always starfish marching in. So during the summer months, I would drive the 350 miles round trip.
Holy cow.
Low tide, do my removal, take other data, and then return to Seattle.
The ecosystem started to change rapidly.
Within a year and a half, I knew that I hit ecological goal.
Wow.
Although
What
the
a
top predator
what a cool experiment too. You know? Holy moly. Yeah.
had been removed, surprisingly, the number of species in the rock actually decreased from 15 to 8.
After 3 years, it went down to 7, but then by another 7 years.
Charlie's Dragon. 21 months.
21, 21, 21.
That's incredible, Charlie's Dragon. Thank you for your ongoing support. That really does mean a lot to me. Thank you for helping me do what I do with your continued support, Charlie's Dragon. Seriously. I appreciate you more than you know. Holy cow! Yeah. Good stuff. Good stuff.
Itself till it was basically a monoculture. I changed the nature of the system.
As the experiment continued, the line
And yeah, Claire's right. That is almost a whole year, isn't it? Yeah, Charlie's Dragon. You're right. It is almost a whole year.
of mussels advanced down the rock face, monopolizing almost all of the available space.
Holy cow.
And pushing all other species out. Payne had discovered that one predator could regulate the composition of an entire community.
That's nuts. Wow.
He coined a term to describe the power a single species can exert on an ecosystem.
This is where that term comes from.
I know very
Keystone
little
species.
about architecture, but if you build an arch, you have to get the two sides of it to put pressure against one another, and therefore at the apex of the arch, you have a keystone. You pull the keystone out, and the structure collapses.
There you go. Keystone species. Very cool. You see how that works?
Predators, like Pisaster starfish, turn out to be keystone species.
Yep.
These keystone species have a huge impact which extends well beyond to the species they primarily prey on.
Most species do not have large impacts. In other experiments, Payne had removed various species, but that had little...
Yeah, they're chitons like this, or anemones. There's another chiton. Another chiton. I can give 40... Save your money, Krylophos. It's your first time here, right? Holy cow. I appreciate the thought, but save your money, Krylophos. Appreciate you.
Or no effect on the ecosystem as a whole.
All animals are equal, but some animals are more equal than others. And that expresses the fact that all species don't have the same impact on the system they're in.
Yeah.
It takes experiments to tease that out, and that's often not easily done.
Payne's pioneering experiments and the concept of keystone species sent ripples through the field of ecology.
Yep.
And turned thinking about the regulation of communities upside down.
Very cool.
The predator system simplifies itself. This is
Yeah.
an ecological concept, which is general and global.
Very cool. A really, really important, concept to understand whether you're studying modern ecosystems or whether you're studying fossil ecosystems. Shoot, if you were to go back into the Hell Creek Formation 67 million years ago and somehow remove T-Rex from that, the whole ecosystem would probably collapse, because who would be eating all of these Edmontosaurus and Triceratops and ankylosaurs and pachycephalosaurs and everybody else, it would be devastating, you know? Species diversity would drop tremendously because of that. So yeah.
Continued his studies a little further from shore. He noticed another.
In fact, that may have actually been part of what happened with the asteroid impact at the time. Yeah.
Striking.
Yeah.
You know, speaking
There were
of
a lot of
dinosaurs,
tide pools.
Did you realize that chickens were a lot like little dinosaurs with feathers? I didn't. Until I read a book called The Dinosaur Chicken Conspiracy.
Jonathan's.
Apparently, the poultry farmers don't want us to know anything about it, so they've hushed it up.
Hope all is well.
13 months, Jonathan's. Thank you for your Prime sub. I appreciate that very sincerely. I'm grateful. Thank you, Jonathan's. And welcome back. Yeah. All these clips are gold. Email, I'm glad you enjoy them. I've accumulated them over years, and I'm glad you appreciate those. Yeah. And I'm grateful for you, Jonathan's. Thank you.
And some of the tide pools were dominated by urchins, some weren't.
In the tide pools with lots of urchins, there was much less kelp. Payne suspected the urchins were keeping the kelp from growing.
And I said to myself, that's my next round of experiments.
Payne removed all the urchins by hand from some pools and left nearby pools untouched. Again, the results were dramatic. In the pools where he removed urchins, the kelp started growing almost immediately.
Laryngeal sacs. Difference in whales and siamangs? Yeah, whales and primates, very, very distant clades within Mammalia, Krylophos. I don't know enough about laryngeal sacs. Yeah, sorry. I can't speak on that with any kind of authority. Yeah.
Urchins control the kelp. Therefore, this is a total violation of the green world hypothesis.
The urchins in Payne's pools were eating all of the kelp.
Uh-oh.
So why was nothing regulating the urchin populations? The
Well,
answer would come from a fortuitous meeting on a remote island in Alaska's Aleutian Island chain.
Could it be because people screwed it up? Well, take a look.
There, Payne would cross paths with another scientist. In 1971, James Estes was an ambitious young graduate student.
At the time that Bob and I met, I was just beginning to try to think my way through what it was I was going to do.
I was just there the other weekend down in Santa Cruz, California, at a UC Santa Cruz facility, the Marine Discovery Center at UC Santa Cruz. Very cool stuff. Yeah. Shoot, we were just talking about this. This wasn't this past weekend, but the weekend before. Yeah, let me find you a photo. Here's me with a whale skeleton at this facility. Very, very cool. It's a big blue whale skeleton they got there. Not as big as a sauropod dinosaur skeleton, but you know, it's still pretty big. You can compare certain parts. You know, the skull on the blue whale is a lot bigger than a sauropod skull. But you know, the femur on a sauropod is a whole lot bigger. The whales don't got femurs, so, you know. Yeah. Anywho, I was just here in Santa Cruz. Just over a week ago. Very, very cool. Yeah.
Was an ambitious young graduate student.
At the time that Bob and I met, I was just beginning to try to think my way through what it was I was going to do.
We met in a bar after a movie. I was interested in sea urchins, and Jim, I think, was doing a study on sea otter physiology.
Look at these critters. Oh, they're so neat.
I was explaining to him what it was that I was thinking of trying to do, which was somehow understand how an ecosystem like the one at Amchitka Island could support such a high abundance of predators.
Yeah.
Do that through an understanding of production and the efficiency of energy and material flow upward through the food web. And Bob's explicit or implicit reaction to that was, that's just not very interesting. And have you ever thought about what these animals might be doing to the system?
Oh, sea otters are so cool.
Realized if Estes focused on what sea otters were doing from the top down, rather than the kelp from the bottom up, he might discover the role otters play in the organization of nature.
By the way, I think some members of chat might be surprised to learn this, but I'm going to tell you something cool about sea otters. Sea otters are mammals who use tools. You saw that right there. There's a sea otter who's smashing open some sort of prey item, probably a mussel or something, on its belly, and it's holding a rock right there. So sea otters, you wonder, like, where did they get that rock? That's that otter's rock. Sea otters have favorite rocks, and they keep them with them 24/7. They actually keep them under a little pouch in their armpit. And I bet you I can find you a video of this. Let's see. Sea otter favorite rock. Let's see here. Yeah, let's try this from the Shed Aquarium in Chicago. Let's take a look at this. Yeah. Look. So those are mussels. Cracking them open right there to eat those soft, delicious innards. Yeah. But wait, did you see the otter pull it out of the pocket, though? Hang on. Let's go back. Wait, did you see how it's just producing these mussels? It's keeping them there in its pocket. That's so cool. You're watch that again. Watch closely. You can kind of see it emerging right here. Watch. Yeah. And so they have two of these, but they'll favor one or the other, just in the same way that, like, people are right-handed or left-handed. An otter will favor one pocket or the other, and it'll usually keep a favorite rock in there that it uses in the wild for smashing open prey onto. It's very, very cool. Yeah. Neat stuff. Neat stuff. Let me see if I can find you another video just to help illustrate this. And Wild 2009, how are you doing? Welcome, welcome to Paleontologizing. Yeah. Sea otters have pockets. Here, let's take a look at this. Yeah. Oh, they have pockets. These are actually pouches of loose skin found under their arms. Yep. Yeah, they use their pockets to store food and rocks for opening tasty treats like mussels.
My message up front. Try not to go extinct.
Wild 2009, thank you for the follow and welcome to Paleontologizing. It's good to have you here. And Dinosaur Dave, enjoy your lunch. I'll see you next time. Yeah. Yeah, so sea otters were nearly driven to extinction on the west coast of North America by overhunting. But they are a conservation success story. Anyway, they're such cool critters, and I wish I could find you a better video about how they keep a favorite rock with them 24/7, and they just keep it there on their person, or on their otter, I suppose, as the case may be. But, yeah, it's just there all the time. Because once they find a good rock, it's like, that's a good tool. You don't ever want to lose that. So just keep it with them all the time. So, yeah. But otters are extremely important to their ecosystems, and the ecosystem basically collapses without them. So when otters were, well, shoot, here. We'll talk about it here. And there's a sound.
Nature.
Yeah.
So I thought, why not? Let's go out and have a look.
And he
Yeah.
was suggesting an approach similar to his starfish throwing experiment. Remove otters from the ecosystem and test the impact that had on other species.
Huh.
And I don't think at that time that Bob had any perception of how that might be done, but I did because I knew quite a bit about the history of the otters. They were abundant across the North Pacific, and then the Pacific Maritime Fur Trade began in 1741.
Yeah.
And over the subsequent 150 years, otters were hunted to the brink of extinction.
Yep.
In 1911 or 1912, further take was prohibited, and a few of those colonies survived and served as the seed for the recovery of the species.
And holy cow, if those laws had not been written or enforced, these animals would have gone completely extinct. And we would have had ecological collapse up and down the Pacific coast. Which is nuts. I mean, how in the world people could go out and kill these animals in the first place just for their fur like that is, like, I find hard to fathom. Like, how could people be that incredibly heartless in the first place? But I guess greed is a powerful motivator, and I don't know. It's something that you see again and again. I mean, shoot, look at the U.S. healthcare system, for instance, which kills thousands upon thousands of Americans every year through lack of coverage, lack of healthcare, and yet this system is kept in place because it makes a tiny handful of people very, very wealthy. And we're talking about human beings here. Anyway, human beings who notably might not be as cute or fuzzy as these otters, but still, I don't know. That's the thing, is that if you let greed be your motivator, it will destroy everything.
Otters were hunted to the brink of extinction.
Yeah.
In 1911 or 1912, further take was prohibited, and a few of those colonies survived and served as the seed for the recovery of the species.
Yeah.
But the sea otter recovery was spotty.
They had completely recovered from the fur trade at a number of island systems across the Aleutian Archipelago, of which Amchitka is a part. There were other island systems where they had not yet recovered.
I'm trying to get through this, Cryolophos. Sungreaves. Interesting. Yeah. I don't know much about that. Yeah. I'm trying to get through this topic. We're way behind schedule here.
The experiment was simple. Compare ecosystems with otters to those without. He began with his home island of Amchitka.
I knew a lot about what Amchitka looked like. I knew that sea urchins...
And Patrick Pirate says, I could see it being used for fur, meat, etc. as a necessity up in the Arctic. Well, people had been, especially native peoples up in the Arctic, had been taking otters, on a really small scale for literally thousands of years. It wasn't until, like, the industrialized exploitation of these ecosystems, like, with the introduction of, like, industrial capitalism, that these otters were nearly driven to extinction. So it's like, it's just throwing otters into this, grinder machine of capitalism like this for profit. Subsistence hunters did not, they lived alongside otters for thousands of years before this. It wasn't until, massive exploitation of these animals that they almost ended up going extinct, So yeah, agreed, Patrick Pirate, agreed.
Were common but very small.
And see you, Crylophos. You, good luck with your stuff. Get some good sleep. I'll see you around.
For a dive at nearby Shemya Island, a location with no otters.
The most dramatic moment of learning in my life happened in less than a second.
Oh my goodness.
That was sticking my head in the water at Shemya Island. It was just green with urchins and no kelp. And it all sort of fell into place in just an instant. That the loss of otters from that system had completely reorganized that system, from which kelps had probably been very abundant before the loss of otters, to one in which the sea urchins now had become abundant in the absence of the otters and had eaten all the kelps.
It was a striking demonstration of the green world hypothesis. Sea otters, the predators, were controlling the urchins that fed on the kelp. Remove the sea otters, and the kelp forests disappear. Payne called these cascading effects of one species downward upon others trophic cascades.
Trophic cascade is when you have an apex predator controlling the distribution of resources, and they lead to these cascades of indirect effects. Lots and lots of indirect effects.
Very cool.
You have fewer sea otters, you have more sea urchins, you have fewer kelp.
I love this because this is a perfect example of just
lots.
You've got these passionate scientists here. Like I can relate to this so hard because these are people who are extremely passionate about what they study. They want to learn everything that there is to know about the natural world, especially in their particular object of research. And this can lead to really, really cool discoveries that kind of change the way that we look at the world around us. That's what science is all about, you know? That is where science influences larger society, hopefully, and helps us as human beings see our world in a different way and be able to preserve it. That's what gets me really excited as a scientist, you know? It's not just an ego thing, like, let's go out and let's learn new things. Let's get a species named after me if I discover this, blah, blah, blah. No. We want to learn more about this incredible world that we inhabit and be able to treat it better, you know, be better stewards of this environment around us. Yeah.
Lots of indirect effects. You have fewer sea otters, you have more sea urchins, you have fewer kelp.
Yep.
I expect every coastal species is probably impacted in one way or another by the presence or absence of kelp. Kelp forest fishes depend a lot on kelp. There are birds that feed in the kelp forest. There are invertebrates that feed in the kelp forest.
Yeah, these crabs.
Virtually everything that lives in the coastal zone depends upon that system in some way.
Yep.
So sea otters are another keystone species.
Yep.
They regulate the structure of this coastal marine community.
Extremely important.
Ambiguous
They're guardians of the kelp forest.
From the top down.
Yeah.
The message is clear, and it's been enormously important in how ecologists tend to view the world.
Estes returned regularly to Alaska to study otters. Some 20 years later, he noticed something strange was happening.
We were capturing otters, having a devil of a time catching enough.
Huh.
It was peculiar because I'd never had trouble catching otters.
Otter populations seemed to be declining.
Why could that be?
He tried to think of every possible explanation.
Ooh.
Essentially.
Anybody have any ideas why the otters may have suddenly started disappearing? Poaching? People? Mikey likes Claire Burr. Claire Burr says people. That's a kind of a safe answer, but we'll see. We'll see. Anybody else? Revenge of the urchins? Shaggy Rex says orcas hunting them for food. Mommy Does says toxicity in the food chain. Vacation says Tommy Platicus. Pollution says M.U. Lee. Well, let's find out.
Lined up all of the hypotheses that we could think of that could be causing this population decline.
He ruled out starvation. He ruled out disease. And then a third hypothesis emerged.
Tim Tinker, who is a technician, called me one day in the winter and said, you know, I'm starting to wonder if it might be killer whales. And I said, you're crazy. You know, I mean, this just couldn't happen. They don't eat otters. And he said, yes, they do. I've seen them eat a couple.
But how could he test it? Once again, nature provided an ideal site.
We went into a place called Clam Lagoon. It provided us a site that orcas could not get to. We had no problem catching about 30 animals in 2 or 3 days.
And why wouldn't orcas eat otters? I mean, usually orcas might pick off a few otters here and there, but they're not going to eat them left and right unless something else goes wrong. And orcas do eat moose. Speedy beard. Exactly, yeah. Holy cow. They will eat moose that are swimming from island to island and stuff. Orcas are... If there is one, like, truly apex predator, non-human apex predator on Earth, like a predator that will eat any other predator, you better believe that's an orca. Holy cow. If there is a tier list of Earth predators, orcas, they would eat the predator from the movie Predator, you know? Like that. Just without a second thought, you know? Holy cow. Yeah. Amazing creatures, and it's so incredible that we get to share our planet with them at the same time. That, like, the idea that we're alive at the same time as orcas is really, really cool. And it's doubly cool because they seem to leave us alone for the most part. Like, I don't think there are any recorded instances of killer whales killing humans in the wild. Maybe in captivity, when they're, driven to insanity by being kept in a small tank, they'll eat a SeaWorld trainer or two, but not eat, but they'll, kind of kill them out of boredom. But yeah. Anyway, it's pretty amazing that, like, we get to share this planet with them, and they mostly leave us alone. They totally leave us alone in the wild, Yeah. Anyway, but they don't normally eat a ton of otters, except if other food sources are missing, then they kind of have to eat otters. Take a look.
We had no problem catching about 30 animals in 2 or 3 days. And the fact that that little population did not decline when everything else did that orcas had access to helped me become convinced that it was a viable hypothesis.
Why were the orcas now eating otters?
Why
orcas
indeed?
Generally eat whales, not otters.
There were a lot of whales around after World War II. After World War II, the Japanese and the Russians started reducing those whales, and by the late 1960s, they had been depleted by 90%. And that the stripping...
Once again, industrial whaling. Once again, capitalism steps in and is like, well, I guess capitalism in the case of the Japanese, and I guess socialism in the case of the Soviets. But industrial scale exploitation of these animals, just, it's bad news for everyone. It really, really is. So yeah.
All these big whales out of the system shock these killer whales and force them to broaden their diet and start feeding on these other species. What had happened is that we had taken this 3-level trophic cascade, and the orcas had added a 4th trophic level.
Yep.
And it made that system behave just like theory predicted.
Interesting.
With the orcas eating otters, urchin populations increased, and kelp disappeared.
To me, the amazing part of that was the notion that something like whaling that started in the middle of the 20th century, way out in the oceanic realm of the North Pacific.
And whaling didn't start in the mid-20th century. He means whaling in these particular environments. Because for whatever reason, I guess the North Pacific was kind of neglected by, like, Herman Melville era whalers. But anyway, I'm assuming. And we hate mass industrialization. I mean, industrialization can provide many benefits, but you got to make sure that you do it responsibly and you're not killing off whales. Holy cow, haven't people seen Star Trek IV Revenge of the Whales? You can't kill off the whales. That'll kill your whole planet, The whales will show up in a giant spaceship and they'll blow up your whole Earth, You can't do that. So yeah, leave the whales alone, Captain, there'll be whales. That's the Arkin. Yes, indeed. Yeah. So anyway, yeah. Oh boy.
Pacific could affect something like.
And Charlie Stregan says, I've not seen Star Trek 4. honestly, as somebody who doesn't know a whole lot about different Star Trek movies, I've seen Wrath of Khan. I've seen the what's his name Star Trek movie, the 2009 one. And I saw the other one, Star Trek Into Darkness, which I thought was lousy. I didn't like it. It was bad. And then I saw Star Trek IV Revenge of the Whales, and that's the best one. See Star Trek IV Revenge of the Whales, and you'll know what I'm talking about, Charlie's Dragon. It's delightful. Even if you don't like Star Trek, it's a wonderful movie. And yeah, I will say, as this is going to make Star Trek people mad, but as somebody who doesn't know hardly anything about Star Trek IV Revenge of the Whales is the definitive Star Trek movie. And it's a must-see. So go watch it. Yeah. The Voyage Home. Well, I don't know what you're talking about, Machi. The title is definitely Star Trek IV Revenge of the Whales. No, I appreciate you, Machi. I'm just playing around. Anyway, whales.
Way out in the oceanic realm of the North Pacific
Yeah.
could affect something like urchins and kelp in the coastal ecosystem.
And Pendrake says during the U.S. Civil War, there was a huge North Pacific whaling fleet. Shoot, you're probably right, Pendrake. It's probably operating out of San Francisco, too. One of the Confederate raiders sank about 80 whalers. You know, even a broken clock is right twice a day. So, you good on those dirty rebs sinking those whaling ships. Anyway, let's. Yeah.
Something like
yeah.
urchins and kelp in the coastal ecosystem.
And I appreciate you, Machi. Thank you.
Mind-boggling to even conceive of something. It was almost like science fiction.
To Robert Payne, this was a satisfying confirmation.
And it provided an example of how the concept of a trophic cascade functions in nature, and it's Jim's work in the Aleutians, which in fact solved the case.
Very cool. These are like foundational studies in ecology.
Explored other habitats with new eyes. They discovered keystone species and trophic cascades in many places.
Yeah.
And just as with otters, the removal of predators, such as wolves, sharks, and lions, has had profound effects on the number and variety of other species.
Yes,
and
indeed.
on ecosystems as a whole.
Yeah.
These fundamental insights have changed the way we look at the world, and they've given ecologists and conservationists a new set of tools.
Very cool. There's some grizzly bears catching fish, which, shoot, is something that I'm looking at in my upcoming Spinosaurid ecology paper. Those of you who were here on Saturday, shoot, I wish that presentation went a little bit better. We had some technical difficulties. Excuse me. Technical difficulties. But, yeah, stay tuned for that. Cool stuff.
Ecologists and conservationists a new set of tools.
Yeah.
Turned us from a fundamental view of nature that was bottom up. More than any other single ecologist, he was the one that transitioned our thinking to the importance of top-down forcing.
Well, thank you.
That's true.
But from Payne's vantage point, humans still have much to learn.
To ignore the fact that there are top-down effects is to invite mistakes. One ignores at one's own risk what role apex predators play.
Yeah. Very cool stuff. I will give you a link to this video right here. And, Emily says, OMG, I love the idea of a Spinosaur chilling at some rapids, catching fish in its jaws like a bear. That's probably not what they were doing, Emily. That's kind of the whole point of the paper. But man, I'm excited to share that with you once we get it submitted for publication. So yeah. SV Harkin says, this is an amazing stream. I'm glad you think so, SV Harkin. Hey, I really appreciate that. I really do. Now let's bring it back home to fossil science here. Because we've got this to talk about right here. how mammoth poop is changing what we know about their extinction, about the extinction of mammoths, not of poops. Everybody poops, still to this day, as the book says. So when did woolly mammoths go extinct? Their droppings can actually give us some insight into that. And mammoths are, again, like elephants today. They would have been ecosystem engineers. These are animals that have a tremendous cascading effect upon their ecosystem, not necessarily by eating other creatures like urchins or orcas or otters, holy cow, or tinamous. Orcas don't eat tinamous, to my knowledge. Giant Straubs, thank you for those 10 gift subs. This bird seems very excited. Uh-oh, hang on.
Giant Straw BZ is overloading the system with 10 gift subs.
Holy cow, Giant Straubs. Thank you for those 10 gift subs. All of these lucky people just got a 30-day gift sub thanks to you, Giant Straubs. And you're also supporting science outreach here on Twitch. A fact for which I am deeply grateful, so thank you for that. Giant Straubs. We're now at 26 out of 40 gift subs. We're getting closer to our goal for the day. And there's now 10 people who won't have to watch ads on this channel for the next 30 days. That's pretty extraordinary. And they'll get to use all these emotes for the next 30 days, too. Lucky them. Holy cow. So, yeah. Giant Straubs with a giant gift. Indeed, Charlie's Dragon. Thank you, Giant Straubs. I appreciate you. Yeah. And Sleazy the Slacker Sloth says, mammoths don't eat orcas? We have no evidence of that, at least. Yeah. You'd think if they did eat orcas, we'd find evidence of that in their poops. But we don't. No orca bones in mammoth poops. But it does provoke the question, was there ever a time during the Pleistocene when an orca ate a mammoth? And I would say almost certainly yes. I don't know, because mammoths, you know, a lot like modern elephants, they're probably really decent swimmers. Yeah. Elephants today are very good swimmers. There's no reason to think at all that mammoths wouldn't be. Elephants can actually cross from island to island if the islands are close by. Like, shoot, if elephants were ever introduced to the Hawaiian Islands, if they were introduced to one of them, they surely would have made it to all of the Hawaiian Islands, all 7 of the main ones. 7, right? Because they're capable of swimming really long distances. They've got a natural snorkel. They've got powerful limbs for paddling. Anyway, elephants are good swimmers, and elephants, I don't know, I could picture, in the same way that orcas will eat moose. They'd probably pick off a mammoth here and there, too, if they got the chance. Yeah. From Surf Researcher. How do orcas eat moose? That's a bad Photoshop there. But orcas only feed on moose occasionally because the 2 species occupy different terrain. Yeah, we do know for certain that orcas eat moose on occasion. Yeah. Orcas might eat moose with an opportunistic approach. When they get the chance, orcas will hop up onto land and drag moose into the water to eat them. I don't buy that. No, moose will swim significant distances, especially up in, like, the Pacific Northwest. Yeah. Moose frequently swim between islands in search of their food. However, during this process, they risk a chance of becoming food for a killer whale. And there's a decent chance that some mammoths may have also suffered the same fate a long time ago. That is actually a paleo art scenario that I would love to see illustrated. I have never seen this before. Let's do an image search. Yeah. Orca eats mammoth. Yeah, so far I'm not seeing anything. Get on that. Get on that, somebody. Yeah. Yeah. Yeah, holy cow. Anyway. And Giblick says, I live in the Pacific Northwest, and I've only seen orca hunting moose in my neighborhood a handful of times. Gimpleg. Oh, you make me laugh. Because for anybody wondering, that it'd be like a once-in-a-lifetime thing that would be... It's surely never been captured on video. That'd be amazing if you actually observed that. But yeah. And you're open for commissions? There you go, NPL illustration. Well, to my knowledge, nobody has done this before. So if you want to do something new and interesting, I'm sure you've got lots of new and interesting ideas yourself, but there's another one to add to your quiver there. Yeah. Well, they prefer chocolate mousse. I don't know. Chocolate mousse tends to have less meat in it, Nolo, and killer whales tend to be... I think they're more interested in meat than they are in chocolate. But I don't know. Yeah. And Spuny Bard says it's more impressive after you actually see a moose. If you hit a moose with your car, which is probably the same size as the moose, keep driving and hope it doesn't get up. I mean, yeah, shoot, back in Montana where I used to live, yeah. Here's a popular bumper sticker. From Montana. I would see this all over the place. There were like 3 cars on my street that had this same bumper sticker. Yeah, holy cow. There are stories of people driving a compact car at night, and then they hit a moose, and then the moose is fine. The moose just kind of scampers off into the woods like a scolded dog, but all of the people in the car were killed. So yeah. Yeah. Don't drive too fast where you have moose around, you know? So yeah. Yeah. Cars crushed like a soda can. Have I seen that video of a moose running across water? I've not, Reaper Extra. What? What is this? Oh boy. Is this just a really...
Oh, I've got a moose that seems to defy gravity by running over open water next to a speedboat in Alaska. Jesus Christ. Yeah.
Hey, language. Anyway, whatever. So this is, very shallow water, obviously. No need for aliens or Bigfoot swamp truckers or, you know, Ghost Hunter Pawn Stars or Real Housewives of Bakersfield or whatever. This is normal behavior in its very shallow water. Yeah, anyway. Yeah. A moose once bit your sister? Sleazy the Slacker Slut? You're kidding me, really? I've only ever had one close encounter with a moose. And that was when I was in the field in 2018. I was with Giulio Panashi, and we were out collecting Cretaceous dinosaur tracks in the Frontier Formation. And I got up, it was like 6 in the morning, This would have been, I think, June of 2018. We were right on the, like, Montana-Idaho border, right near the Continental Divide, way high up. Really high elevation. We were at like 9,000, 8,000 feet elevation, something like that. And I got up early in the morning to go heed nature's call, as one does. And I'm making a deposit. You know, laying down some copper lights there, and I just got kind of a weird feeling, like somebody was watching me. Maybe it was a sound that I heard or something, but I'm kind of squatted down, and I turn and I look behind me. And there's a big ol' female moose just staring at me. Like that. Maybe 10 meters away, like, a little over 30 feet away. And I'm like, oh. I'm just gonna try and look as inconspicuous as possible, because a moose can very easily stomp you to death if it's angry with you, if you invade its territory, if you tick it off. Especially if you're crouched down, going number 2 in a ditch. And so, yeah. So I'm just there and I make eye contact with the moose. And the moose kind of snorts. And then just kind of slowly turns around and walks away. So, yeah. I've encountered moose in the wild. And they're not a creature you want to mess with. They're really, really not. So, yeah. Yeah. Email says the chance of being murdered by a moose is low, but never zero. I wouldn't call it murder. I'd call it more... that would be like dying in a turf battle. So, yeah. Yeah. And moose are like 4 times bigger than you think they could possibly be. They're big. They're big animals. Yeah, for certain. Yeah. And Reaper Extra says, my auntie got slobbered on by a camel at the zoo. It stuck its head in through the car window. She got away lucky. Holy cow. Camels also. If a camel wants to mess you up, holy cow, can it mess you up? Yeah. There's a... Yeah. Here we go. There's at least one documented case of a camel literally biting someone's head off. Like, documented case. Camel bites owner's head off after being tied up all day during a heat wave. This is in India, a number of years ago. Yeah, a camel has reportedly killed its owner after being left in high temperatures with its leg tied up all day. This poor camel, who could blame him? Or her? The incident in the Indian state of Rajasthan happened on Saturday during a record-breaking heat wave that saw temperatures reaching 43 degrees Celsius. That's like, what, 115 degrees Fahrenheit? Something like that? According to the Times of India, a man named only as Ujaram was entertaining guests at his house during the evening when he remembered he'd left his camel with its legs tied. After trying to untie the camel attacked him, throwing him to the ground. Over 25 villagers reportedly struggled with the camel for 6 hours. Yeah. The report quotes villager Thakara Ram, who says the animal lifted him by the neck and threw him onto the ground, chewed the body, and severed the head. The camel literally bit his head off. So the camel was, I'm sure, very aggressive after being basically broiled all day, tied up, unable to seek shelter. The animal's basically being tortured, and the guy runs over, he's like, oh shoot, sorry, I forgot you here. And the camel bit off his head. So, yeah. Yeah. Heat madness. There you go, Golganek. Yeah. And camels have got... Here's a link there, if you don't believe me. You can look it up, or you can read the link. But there's like several sources on this. But let me show you a camel skull with those teeth. You'd wonder, like, how could a camel actually bite off somebody's head? Well, there you go. Holy cow, have they got some pretty formidable looking teeth. Camels are such cool animals. They really are. Yeah. Really, really extraordinary. Camels, as far as we know, first evolved in North America, too. Which is pretty neat to think about. I always bring that up when we talk about camels. Camels are a North American original. You might associate camels with Asia, like Bactrian camels in Mongolia, or dromedary camels in Saudi Arabia, in the Middle East. Camels first evolved in North America. That's what the fossil record tells us, at least. Which is pretty cool. So yeah. Yeah. Codmo says, if all the prehistoric dinosaurs were still alive and running for president of the United States, which one would Danny vote for? T-Rex for me. I'd have to see their platforms, Codmos. I don't know. Yeah. I'm not sure. Yeah. And Gertie the dinosaur. Gertie's not a T-Rex, Codmos. You're changing your answer there. And yeah, llamas are camels too. Exactly, RBRO. Where do you think llamas came from? Llamas, guanacos, vicuñas, and alpacas are all camelids. They evolved from that ancestral North American camel. So yeah. Yeah. Oh man, would that be cool to get a camel skull cast? But man, is that pricey. Holy moly. Yeah. 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 Really neat. Really neat. But anyway, we gotta get back to this article here. Shoot. How mammoth poop is changing what we know about their extinction. Let's get back into that. Yeah. Oh, wait, shoot. Before we do this, Kunzit has got a good question. It's not a basic question. That's actually something that paleontologists still talk about and debate to this day, Kunzit. Why do big predatory dinosaurs like Tyrannosaurus tend to have such small forelimbs? That's actually an interesting thing. Some of them don't. Like the Spinosaurids, whom I study, they've got pretty big, beefy, muscular forelimbs on them. Like, yeah. And if we have time, we'll talk about that new European Spinosaur today. But these guys tend to have pretty, what we would call hypertrophied forelimbs. Very robust. But with, like, Tyrannosaurus, why did these animals have such small forelimbs? Were they vestigial? And short answer is kind of, yeah, I think so. Let's look at some adult T-Rex here. Let's find a Scott Hartman one. There we go. Yeah. Nope. Where's Scott's? There we go. So Tyrannosaurus, this huge, 13 or 14 meter long predatory dinosaur, huge heavy head on the front of its body, walks on two legs, very, very small forelimbs. If you're a human being over about 5.5 feet tall, your arms are probably about the same size, if not bigger, than a T-Rex's arms. Why would such a huge animal have such small arms? I'm inclined to think it's a lot to do with balance for the animal. Because this is something that we see again and again throughout a lot of big, two-legged meat-eating dinosaurs. All the meat-eating dinosaurs walked on two legs. And they've all got a balance right there on a kind of a central fulcrum. It's almost like a seesaw or a teeter-totter, And tyrannosaurs go really big with their head. They develop this huge, stocky, thick, heavy, powerful, deadly head. That's the business end of the animal. This is how they kill their prey. This is how they eat. This is how they fight. That's the most important part of the animal. Their arms, a long time ago they decided, they didn't decide, they're evolving in this direction. Like, yeah, arms just not as important for us. So they're kind of sacrificing from the arm department and investing in the head department. They're kind of min-maxing there, I guess you could say, to use a video game term, right? Isn't that a video game term? Min-maxing? T-Rex is min-maxing there. That's what tyrannosaurs are doing in general. They're minimizing their arms, they're maximizing their skull. And they have to do that because they've got to balance on two legs like this. They had a big, heavy skull and huge, heavy, muscular arms. They just fall right over on their face. So it's because of being bipedal. They got to do something with those arms. And I would love to... Shoot, if we had more Tyrannosaurus specimens throughout the Hell Creek Formation, if we had, say, 50 or 100 of these critters, and they were all stratigraphically constrained, we knew from where they came from, 68 million years ago, 67 million years ago, 66 million years ago, then we can actually track those changes over time. Kind of like we can do for Triceratops already. But we don't have that many specimens for T-Rex. Were their arms actually getting shorter over time? I suspect they probably were, but we can't say for sure yet. There's a chance that if the asteroid hadn't hit 66 million years ago, these animals would have lost those arms altogether. If they had been allowed to continue to evolve, T-Rex's head may have gotten bigger and ever heavier and more deadly, and those arms would have gotten smaller and lighter, and then whittled away to basically nothing more than little nubs. They may have been vestigial, but this is something for future paleontologists to study because we don't have nearly enough specimens yet to really test this idea. We need more of them to be able to figure this out. So yeah. So anyway. And they're min-maxing. There you go, Kanzit. Yeah, okay, good. I'm glad that made sense. I'm glad I used that term correctly. Yeah. And you wonder which carnivorous dinosaur had the longest known arms? I think that would probably have to go to Spinosaurus, Cosmos. Although we're still kind of figuring that out. Because, shoot, Spinosaurus offers so many weird quandaries to us. We don't really know... Oh, boy. How big were the arms on Spinosaurus compared to its legs? These different pieces that have been used to, like, kind of mix... Yeah, I don't know. There's probably multiple different dinosaur species that were all mixed together to make this Spinosaurus. Probably multiple kinds of Spinosaurid. Spinosaurus seems to be a bit of what we call a chimera. Yeah. I can tell you the theropod with the biggest arms is certainly Dinochirus. This animal right here. But Dinochirus seems to have been mostly a plant-eating animal. So this is a member of the Theropoda. The group of dinosaurs that includes T-Rex. They're mostly meat-eaters, but some of them go plant-eater. And that's what Dinochirus did. It evolved to be a plant-eater. It had the biggest arms of any theropod that we know about. But it's a weird plant-eating theropod. So yeah. Yeah. So anyway. Yeah. Kanzit says, so if Spinosaurus had those big claws, it's not a matter of blood flow. It's just balancing those big jaws, right? We really don't know what the full skeleton of Spinosaurus looked like at this point. We don't have enough material. It's tough. It's hard to say. So yeah. Yeah. Anyway. Yeah. And all the theropods that typically have large arms tend to have relatively smaller heads and longer necks, like the Megaraptorans. Exactly. Good point there. Shaggy Rex. Yes, indeed. Yeah. So anyway. Yeah. And I don't know what you're talking about, Death of Barney. No, that's interesting. Hester Creek Arctic ground squirrel.
Try blaming the dinosaurs.
Sounds neat.
Hypothetically, would hominins be able to coexist with extinct dinosaur megafauna?
Nader, I don't know, Nader Fiend. Shoot. You know, in a situation like that, it's like the only reason that hominins evolved is because we didn't have extinct dinosaur megafauna in the first place. So throw them together and, you know, it's like asking, shoot, I don't know. Could Spider-Man and Batman share an apartment and get along? I don't know. I don't know. Could Lucy Ricardo and Tony Soprano share an apartment together and coexist peacefully? I don't know. I really don't know, you know? Yeah. It's a... I really can't answer that with any answer that I give you would be ridiculously speculative, Nader Fiend. Yeah. Giant straps. Oh, Tony! Wow! There you go. Lucy, why are you always being so dramatic? Why don't you calm down for once? Somebody needs to make this now. Oh no. Speculate for me, Professor, says Nader Fiend. You know, shoot, I don't know. You know, at the behest of a friend, I started watching The Sopranos recently. I'd never seen it before. Didn't think I would enjoy it. I kind of hated it at first. Kind of growing on me a little bit. I don't know. But to speculate for you, Nader Fiend, it seems that, shoot, Tony Soprano doesn't... I don't know, he doesn't seem to appreciate a lot of drama, but that's exactly the sort of thing that Lucy from I Love Lucy kind of thrives on. That's just who she is, and so I think there's going to be a lot of clashes right there, you know? So I really don't think that they're going to get along well. You know? Okay, Nader Fiend. Point taken. It's anti-Italian discrimination. And Pfizer, yes, indeed. Ricky Ricardo was the straight man. And shoot, that actually brings me back to... We're going way too far afield here, but that's okay. Bear with me for just a minute. Shoot. Back growing up, you know, on my dad's side of the family, we're Puerto Rican. And so, like, growing up, you know, I'd be watching TV with my family, with my dad's side of the family, because we're Puerto Rican on my dad's side of the family. And, like, somebody would show up on TV, and my dad would be like, or my dad or other members of my family would be like, you know what? Yeah, mijo, you see them? You know they're Puerto Rican? And, like, Ricky Martin, Puerto Rican. J-Lo, Jennifer Lopez, Puerto Rican. But then it would also be people like Desi Arnaz, Ricky Ricardo. And it'd be like, yeah, you know him? I know he plays a Cuban on the show, but he's actually Puerto Rican. And, like, I believed that for the longest time. And there were other people, too. It was like, there were several, like, there were other, like, major celebrities. Shoot, who's the guy from, Alfred Molina from Raiders of the Lost Ark, or Dr. Octopus from Spider-Man. I grew up thinking that he was Puerto Rican also. So anyway, it's just kind of funny that, like, yeah. Anyway, Ricky Ricardo He's Cuban in the show, and I think Desi Arnaz was from Cuba, but I grew up thinking that he was Puerto Rican because that's what I'd been told growing up. And anyway, it's funny when you grow up Puerto Rican how many other people are Puerto Rican. Yeah. Anyway, throw me the idol. I throw you the whip. There you go. Giant Straub. See, Giant Straub's nose. Yes, indeed. Yeah. Anyway, what were we talking about? Dinochirus. How did we get here? Shoot, let's retrace our steps. I've got too many tabs open. What's going on here? Oh boy. Let's get back to mammoths. And how mammoth poop is changing what we know about mammoth extinction. I don't think there had been many Puerto Ricans on the West Coast. Well, shoot, my ancestors on my dad's side came from Puerto Rico by way of Hawaii. And then to the mainland. So yeah, during apparently like a big famine and economic downturn in Puerto Rico, a lot of Puerto Rican people were kind of shipped over from that island to the island of Maui to help harvest sugarcane and stuff like that. And then later some of them made their way to the West Coast. So yeah, I'm descended from Hawaiian Puerto Ricans. They're Naderfiend. Yeah. Yeah. Anyway. Yeah. Migration. Indeed, Claire Burr. Yeah. So back to this article. How mammoth poop is changing what we know about their extinction. The extinction of mammoths, not of poop. Unfortunately. Yeah. This paper really extended the youthfulness of mammoths, Miller tells Mental Floss. It seemed to us like a great test to explore the alternative hypothesis for how one might interpret these data. Their alternative hypothesis, the environmental DNA came from the frozen remains of much older mammoths, rather than their still living descendants. Miller and Simpson show that in the frigid Arctic environment, animal bones can stick around for thousands of years before decaying and releasing their DNA into the soil. They say it's impossible to tell whether the 4,000-year-old eDNA came from the poop of a living mammoth or from the slow decay of an already long-dead corpse. In fact, Miller argues, if mammoths died out so recently, their carcasses would still be sitting on the Arctic tundra to this day. If you say that's when the last animal died, given how cold it is at that location, we'd expect that the bones of these last populations would still be recoverable out there, he said. Yet no such remains have been found. I kind of wonder whether this is due to, again, human butchering. But yeah. Yeah. Yushen Wang, lead author of the original paper, says isn't surprised that the method has its skeptics. For fossils, you have a bone, Wang tells Mental Floss, but with DNA, you don't have anything to show people. It's all data. And yeah, this is one of the reasons I don't work on environmental DNA. I'm a fossil guy. You know me. Yeah. But still, Wang is convinced that this data comes from real living mammoths. And living at the time during the Pleistocene, not living today. It's a little confusing. Anytime you use the word living, that kind of implies extant. Yeah. In a reply published alongside Miller and Simpson's comments, he and his colleagues defend their findings. They agree that most mammoths died 10,000 years ago when the Arctic got much warmer. But they argue that a tiny group of hardy holdouts lasted much longer, leaving behind tons of DNA-packed mammoth pies, but too few bones to find. The population size is so small compared to the previous one, Wang says, so it's extremely unlikely to find and date the latest survivors. I mean, I kind of wonder about the influence of humans on this, too. We all know that human beings tend to use bones for different purposes. If there's just a big carcass of a mammoth sitting there, then ancient human beings might take the fur, might take the meat, they might even take the very bones for various purposes. Humans, I guess my point is that taphonomically speaking, humans have a tremendous influence on what ends up being preserved in the long run. You know? So yeah, it's free real estate. Email, yes indeed. Yeah. Are we always overlooking ourselves, says SV Harkin? I mean, that's kind of to be human is to do that. Go, oh yeah. You know, don't mind me. I'm just being very disruptive over here, you know? Yeah, that's kind of how human beings work. You know? The surf rock version of Love Buzz? I don't know, Giant Straws. It probably was. I bet you... If you think you heard that, that's probably what it was. Here, shoot. Let me go back. Let's see. Let's go back a titch. It was from Nirvana. Yes, indeed. Yes, indeed, Giant Straws. You got that right. Yeah. But yeah. And Codmos? Oh, the beast from 20,000 Fathoms? That animal is completely made up. I actually have a video about that on the old YouTubes. Let's see. There we go. Yeah, let's scroll down and find that. But the Rhedosaurus completely made up. If I had to say it looked similar to any kind of fossil critter, I would say it probably looked similar to a mosasaur. But anyway, if, yeah, the beast from 20,000 Fathoms. Yeah.
Soldiers and their weapons would be powerless before the onslaught of the beast. The beast.
The what?
The beast.
The what?
The beast.
The what?
20,000 fathoms.
Yeah.
Mostly ignored the story's main themes.
Anyway, and I don't know why I look so grumpy right there, but, yeah, there's a video about that right here. And if anybody would like to see some past Paleontologizing broadcasts, pretty much every stream from this current year, 2023, I've made sure to download and throw up there on the old YouTube. So yeah. Yeah. Anyway, good stuff. And we're still on the Mammoth article. We are Shaggy Rex. We're just... Oh, boy. There's so many other things to discuss here, you know? So, yeah. Yeah. So, in a reply published alongside Miller and Simpson's comments, he and his colleagues defended their findings. They agree that most mammoths died out 10,000 years ago, when the Arctic got much warmer. But they argue that a tiny group of hardy holdouts lasted much longer, leaving behind tons of DNA-packed mammoth pies, mammoth droppings, dung, but too few bones to find. The population size is so small compared to the previous one, Wang says, so it's extremely unlikely to find and date the latest survivors. But Miller maintains that mammoths are too conspicuous to live for so long without leaving behind any fossils. The population is small enough to leave no trace but poop, he says, could never survive for several millennia. Interesting. Yeah. If the later extinction date turns out to be true, it would mean that mammoths and humans coexisted for thousands of years, putting a huge dent in the theory that we hunted them to extinction. I do tend to think that it was mostly human overhunting that caused their extinction. Again, huge caveat here. I want to emphasize that I don't actually work on Pleistocene mammals. I don't know much about mammoths. But it kind of seems to me like, you know, these animals are existing for close to 1 million years with all kinds of fluctuating climate. You've got huge fluctuations in the climate during the time when these animals manage to survive. But as soon as humans show up, they bite the dust. I don't know. I'm inclined to think that it was human overhunting, but I could very well be wrong about that. I'm a dinosaur guy. I don't work on these critters. Who cares what I think, honestly? With today's large mammals facing similar threats from both humans and a changing climate, this question is as important as ever. We really have to, as a community, understand the underlying truth of when mammoths went extinct, Miller says. The fossil record is a great tutorial to understand what happens when things go extinct, which is really important for understanding how to manage ecosystems today. Carolux. What? Thank you for the follow, Carolux. And welcome to Paleontologizing. And Aberrantologist says this is why dinosaurs are better. Simple explanation for their extinction. Big space rock. There you go, Aberrantologist. Once again, not wrong, but correct. Anyway, Wang is encouraged by the lively conversation surrounding the results. It's good to publish this kind of discussion into a high-profile journal so that people from other fields can also pay attention. Miller points out the growing importance of eDNA, that's environmental DNA. Research makes the debate especially timely. This lab and others are really pushing the envelope, he says. I think the exchange is really great and really important to have, and I'm really glad it's happening now. This is very, very cool stuff, and I look forward to seeing kind of a general consensus start to form around this after more evidence comes to light. But maybe let's take a look at a quick video talking about the importance of environmental DNA and it's how it can be used for wait, hang on a minute. Is this about the same thing? I was gonna show you a different video. Come on, stay still. Is this about eDNA? Well, here we go. Shoot. I was gonna show you a video about the Loch Ness Monster. But let's see. Yeah. Well, no, let's look at some actual science first. Anyway, there was a really interesting study that came out a while ago saying like, oh yeah, Loch Ness Monster, they sampled Loch Ness and didn't really end up finding anything in particular that would suggest the presence of a giant monster. And then the news agencies took that and ran with it, and they're like, oh, it means the monster's a giant eel. They also didn't really find giant eel DNA. Anyway. Yeah. Let's watch this instead with some actual decent science here. Take a look. Oh, and then, if you're a really well-behaved, chat, maybe we'll watch... I'll see if I can find the Loch Ness thing after this. But yeah.
Imagine that you're a scientist.
Imagine the volume is way too loud. Now imagine it's at a more appropriate level. Take a look. Yeah. And Codmos says it could be a plesiosaur member. There's 0 chance it's a plesiosaur, Codmos. Yeah. For like 100 different reasons. But yeah. If it were a plesiosaur, you would see it surfacing to breathe like 10, 20, 30 times every hour. It'd be immediately obvious. It's like, oh shoot, there's a plesiosaur in that lake. Those are air-breathing animals. You know? So yeah.
Imagine
yeah.
You're a
Anyway.
Scientist trying to track a species that's notoriously hard to find. Maybe you'll look for footprints or droppings. Perhaps you'll put out camera traps hoping to spot them as they move about. Or you could just scoop up a bottle of stream water or a cup of dirt and look for DNA fragments instead. That's the amazing potential of environmental DNA. Or
Yeah.
eDNA.
eDNA.
We're already using it to study animals in all sorts of ways. eDNA is DNA that can be extracted from an environmental substrate like soil or water. You see, all living things leave their DNA behind like a trail of breadcrumbs, thanks to biological cast-offs like saliva, feces, urine, or skin.
Extinction is no shame, no sign of disgrace or failure. In fact, in a world full of changing environments and occasional catastrophe, all species eventually become extinct.
For science.
Thank you, Stavros, for helping me prevent extinction for myself for the past 7 months through your support. 7 months of support from Stavros. Thank you. Thank you, Stavros. I appreciate you. Thank you, thank you.
Skin cells. And scientists can use this eDNA to essentially press rewind and see what's passed through an area recently. That's because...
Very cool stuff. Hang on. Death of Barney says, I think Science talked about this before. I bet you they did. Shout out to Science Streams, if you don't mind. Lenina, if you could give them a shout out, or Claire, or whoever's here. That would be great. Yeah. Go check out Science Streams. Oh, shoot. Lenina was... It was a race between mods. Lenina just a tiny bit faster. Anyway, thank you, Claire Burr, also. I appreciate you, Claire. But yeah, go follow Science Streams to see another 2 scientists here on Twitch. Balint and Lita are both scientists. They both run that channel. Good stuff.
Use this eDNA to essentially press rewind and see what's passed through an area recently. That's because species have unique genetic codes. Even regions of DNA that look broadly similar between species have unique differences that can be used to separate one from another. So a researcher can collect a cup of soil or water and sequence the DNA in it to see what species are around.
And this is super, super cool because this didn't used to be possible. You used to need a much larger sample for this kind of thing. But nowadays, we can sequence things from very tiny samples. And, shoot, this is not like CSI style, you know, where, you know, a lot of the DNA that's used in, like, forensic studies in the U.S. criminal justice system is, like, complete bogus, which is really awful. But anyway, but when you're dealing with different species of animals, their DNA is different enough where, shoot, it becomes immediately obvious who was here and who wasn't. You know? Telling different people apart, the human DNA tends to be remarkably similar because we're all members of the same species. And human genetic diversity is actually really, really low. Like, that's one thing that's kind of remarkable is that across all of humanity, people from different continents all over the world, their DNA tends to be very, very similar. There's typically less genetic diversity, you know, between somebody from, I don't know, North America and somebody from Australia than there is, you know, maybe native peoples from North America and Australia than there is between, like, members of the same troop of chimpanzees. You know, chimps have a much higher genetic diversity than human beings do, because we as human beings went through like a big genetic bottleneck before later diversifying. So human beings we're all far more similar to each other than even, you look at like a troop of chimps and they'll be more different from each other than we are, people from different continents, you know? So yeah, anyway. eDNA.
Around. Often, this is done by looking for fragments of mitochondrial DNA, and as the name implies, that's the DNA found inside the mitochondria, the cell's energy factories. Each cell can have dozens,
powerhouse of the
thousands
cell
of these mitochondria, so there are generally more copies of mitochondrial DNA than nuclear DNA per cell, and that makes easier to find in environmental samples, especially ones where DNA may be degraded or dilute. The tricky part is translating a presence-absence signal into a reliable estimate of how many individuals of a species there are. And scientists are still trying to figure all that out, as there are a lot of factors that affect how much DNA is shed from an animal and how long a given bit of DNA sticks around. For example, DNA may decay faster in a hot environment than in a cold one, or disperse.
Which actually has tremendous bearing on the study we were just talking about. Like, mammoth DNA might stick around for a lot longer in a cold climate where you've basically got a natural outdoor refrigerator keeping things fresh, you know, than in a hot climate.
For example, DNA may decay faster in a hot environment than in a cold one, or dilute and disperse more in streams and oceans than in soil. But even with these challenges, eDNA is already helping scientists manage and conserve species because it can be used to monitor animals that are rare, like to hide, or are otherwise hard to see. Take the bluegill sunfish, for example. Native to North America, this freshwater fish was introduced to Japan in the 1960s and has now become one of their most notorious invasive species. It eats basically anything it can and has the potential to push species towards extinction. So some areas are trying to get rid of them to help conserve native freshwater ecosystems. But in order to do that, scientists have to know where the bluegills are. And if you've ever tried to spot a fish from shore before, you know this can be difficult. What you see can be influenced by the fish's size, behavior, and habitat. So in a 2013 study, a group of researchers tried using eDNA to find bluegills in 70 ponds in Japan. They collected water samples from each pond, but also walked along the shore to see if they could spot the fish themselves. They saw bluegills in 8 of the 70 ponds and were able to successfully find bluegill DNA in the matching water samples. But they also found bluegill DNA in 11 additional ponds. So eDNA gave them a more complete picture of the fish's distribution. And sometimes eDNA reveals animals that scientists aren't expecting to find. For example, scientists in the Baltic Sea were testing an eDNA protocol for detecting harbor porpoises in seawater when they found something surprising. Their results showed DNA from a long-finned pilot whale.
What?
These whales are rarely seen in the area, with only 2 unconfirmed sightings. eDNA analysis in the ocean is a bit harder than in freshwater. The larger body of water creates more opportunity for dilution and dispersal of DNA. That means that authors couldn't rule out the possibility that the DNA had drifted
I don't think they're
over a long
cichlids.
distance or originated from a dead animal.
But I could
the
be wrong.
results still suggest that eDNA can be used to detect hard-to-observe animals in areas they rarely frequent. And eDNA can also help spot animals in their native habitats when they're just really hard to find. In Virginia, wood turtles are declining in number because people are destroying their habitat and poaching them to keep as pets. They're considered both an endangered species and a management priority. So scientists really want to know exactly where these turtles are. But they're turtles. Not only do they spend a lot of time underwater in muddy streams, they also tend to look like rocks. It can take years and a lot of money to train people to spot them reliably. So a team of scientists decided to try eDNA as a potentially easier and cheaper solution. They looked for turtles at 37 locations across Virginia by wading through streams with nets and aquatic view scopes, contraptions that look a bit like an overturned bucket with a lens at the end, which allowed them to peek below the water's surface. And at each site, they also carefully filtered water samples to collect eDNA. They saw turtles at 17 of the sites and found positive eDNA hits at 13 of those. Those false negative results were the eDNA did not correspond to visual sightings.
Interesting.
Factors that impact successful eDNA monitoring, like turtle density, days since last rainfall, and water temperature.
So again, to clarify here, in this case, it sounds like the researchers, they found more turtles by looking than they found through eDNA protection, or eDNA detection, excuse me, which is really interesting. They got some false negative results from eDNA testing. And I don't know, maybe they weren't doing it right. Maybe they had a bad search image in terms of the DNA. I don't really know. But that is really instructive. Interesting.
eDNA monitoring, like turtle density, days since last rainfall, and water temperature. By understanding these, the team was able to optimize their protocol to improve detection and sensitivity in future studies. But despite these limitations, the group found eDNA at 3 sites where turtles were not seen by the surveyors. The researchers think that those sites were likely places where they had missed the turtles visually because there were so few of them around. eDNA surveying also wound up being more cost-efficient than human surveys, so the team recommended it for monitoring these threatened turtles in Virginia and beyond. And these are just a few of the many ways eDNA is already helping scientists track and find species. It's also tracking invasive golden mussels, dangerous mosquito larvae, and vulnerable manatee populations, for example. A 2019 study even suggested eDNA could tell us how much coral there is on a reef. And it isn't just for aquatic animals. eDNA has also been used to look at things like earthworm communities and adorable lemurs called eye-eyes. And at least one project is trying to ID birds.
I don't know how adorable they are. They're a little creepy, eye-eyes. But yeah.
By sequencing eDNA pulled from the air. There are some kinks to be worked out, but ultimately, eDNA could completely change how we find and monitor all sorts of living things. And with thousands of species on the brink of extinction, the unique insights we're getting from eDNA may be more important than ever. Thanks for watching this episode of SciShow, which is produced by Complexly. If you liked learning about this neat way scientists study living things, you might like another one of our channels, Nature League. In every episode...
Yeah, neat stuff. So eDNA, very important. And maybe he was being sarcastic after Bandit Girl, I don't know. I'm guessing that he was just reading the script before they actually found the pictures, and then that's when he found a really creepy picture. But, yeah... Here, I'm trying to find that. Here it is. Yeah, so eDNA has also been used to try and figure out Is there a Loch Ness Monster? Apologies for no closed captions on this one. The video just doesn't have it. But yeah, eDNA can be used. Is there any more elusive animal than the Loch Ness Monster? So elusive that it doesn't actually exist? Well, let's take a look. Yeah. Yeah.
Loch Ness, Scotland. A place that for...
And Codmos says, suppose that I was looking in Loch Ness and did find a plesiosaur that was the basis for Ness. You found a plesiosaur in Loch Ness? That would be incredible. Yeah, a prehistoric creature from millions of years ago in a lake tens of thousands of years old. In such a scenario, would such an otherwise scientific impossibility... I mean, it's not impossible. We've got lots of creatures that are from the Mesozoic era that are still around today. Crocodiles would be an example. We had crocodiles back in the Cretaceous, and we have crocodiles around today. You know? That's not impossible at all. Would such an otherwise scientific impossibility, not impossible, be explained more with creationism or evolution? It's irrelevant to both, Codmos. It's just a thing. You know? Like, yeah, in the same way that, like, going, oh, well, shoot, there are, you know, there's crocodiles that are around today, and they existed 66 million years ago? You know, that shows that the Earth is only 6,000 years old. Like, no, it doesn't. That doesn't follow. You know, it would be a remarkable discovery, and holy cow, if I thought there were even a 1 in a million chance that there was a living plesiosaur in this lake, you better believe I would be there. I would live on the shores of Loch Ness if I thought there was even a 1 in a million chance that that were the case, you know? I would not be here today. I would be there. But, yeah. No. Extremely, extremely slim chance. You know?
Centuries has been home to one of the world's greatest mysteries. Some say a monster lurks beneath these waves.
And Petra Crusader says, in Beyond Loch Ness, Nessie actually lived in Canada and swam through underground tunnels to Loch Ness sometimes. Through the Earth? Is this like a hollow Earth hypothesis thing, Petra Crusader? Oh, boy. Let me guess. History Channel, right? Or Discovery Channel? Oh, boy. Here, let's continue.
Others say it's a figment of vivid imaginations run wild in the imposing landscape of the Scottish Highlands. Now, these waters may finally tell the tale, thanks to the long-awaited results of cutting-edge science known as environmental DNA.
eDNA! Good stuff.
Yeah. It cannot escape the building blocks of life.
Yep.
For more than a year, New Zealand professor Neil Gemmell and his team of scientists and researchers have mined the depths of Loch Ness, pulling hundreds.
And Gormabald says, Danny, if there were to be something in Loch Ness, what would be the most likely dinosaur that might possibly turn up there? No, we totally do have dinosaurs in Loch Ness, and some of them are responsible for Loch Ness Monster sightings. Would you like to see one? Yeah. Well, shoot. You ready? Here we go. I'm going to show you some dinosaurs which are responsible for Loch Ness Monster sightings. Here is one. Right here. Here's another one. There's 3 right here. Holy cow. Please, embiggen. Anyway. Shoot, look at that one right there. Oh my goodness. Yeah. Oh no, another one. See, these are what we call cormorants. These are these remarkable birds that They do stick their necks up out of the water like this. They've got a conspicuous, like, hump on the back like that. And when they spread their wings, they look like... That's a Facebook image, so it's not going to embiggen properly. But anyway, they, well, there's a model of one. Yeah, when they fly, they look like this. Come on, embiggen, please. Goodness. There we go. Yeah. So, cormorants, of course, are birds. Birds are dinosaurs. So, strictly speaking, I guess some of the Loch Ness Monster photos are probably those of living dinosaurs. Cormorants who live in Loch Ness. And they'll probably show up in this environmental DNA survey that we see here. So, yeah. Yeah. Anyway. And Shaggy Rex, yeah, that's actually a Darren Naish idea, Shaggy Rex, is that the release of the film King Kong in 1933 basically led directly to the Loch Ness Monster myth, which is pretty cool. But anyway, let's continue with this video here, shall we? Yeah.
A year, New Zealand professor Neil Gemmell and his...
And Gormabald says, okay, I got nailed with a commercial, so I'm going to stop being lazy and I'm going to do this. Do you mean subscribe, Gormabald? Is that what you mean? Holy cow. Well, let's see if Gormabald is going to support science outreach here on Twitch. Yeah.
Cannot escape the building blocks of life. For more than a year, New Zealand professor Neil Gemmell and his team of scientists and researchers have mined the depths of Loch Ness, pulling hundreds of liters of water out
Very
and
cool.
extracting DNA from the liquid. The results are in. Professor Gemmell can now say what creatures tested positive for being in the loch. And more importantly, what he didn't find.
Which creatures tested negative for being in the loch? Such a funny way to put that. Which creatures tested positive for being real? But yeah. And oh, and I appreciate that, Gormabald. Thank you. Holy cow. Appreciate you, Gormabald. Holy moly. Codmos says, if we did find skeletons of actual winged dragons, how would we determine it to be a winged dragon versus a pterosaur? I can show you a winged dragon. You want to see a winged dragon? I can show you a real one that's around today. Yeah. Here we go. Yeah. Very cool. Come on, play.
There are a lot of cool lizards around the world.
Oh, is this a Pecos Hank video? Holy moly, this is the greatest.
But one lizard has an extremely special ability.
Yeah.
It's a master of camouflage and spends its day on tree trunks, telling the other lizards to go away, so it can catch a buffet of ants and other insects.
Thank you,
marching
Gormo.
up and down.
Appreciate you.
Through the manipulation of editing, we're going to make it look like this paradise tree snake was interested in a lizard dinner. The lizard's first line of defense is its camouflage. Second is to run away. If the predator, in this case a human, is still in hot pursuit, the lizard unleashes its superpowers.
Holy cow.
Flying Draco leaps into the air and glides to another tree.
So this is a kind of lizard.
The flying Draco flares out its membrane-covered ribcage.
Look at that.
Wings and
That's
gliding flights
nuts.
up to 60...
So that's its rib cage right there. Its ribs actually form the wing membrane. Really, really amazing. Those ribs have gone from, of course, they evolved in its ancestors to kind of help protect its innards and everything. That's what the ribs did in its ancestor. But this animal has taken those ribs and then over the course of millions of years evolved a wing membrane like this instead. Really extraordinary stuff.
Its membrane-covered ribcage to create wings, and gliding flights up to 60 meters have been recorded.
Very cool. Look at that. Holy moly. Not true flight, but gliding at least.
Snake is a flying snake.
Yeah, holy cow. So shoot, if you've never seen this guy's videos before, you know, this is kind of his side channel, Wild Snakes, but this is one of the world's greatest storm chasers. And, yeah, Pecos Hank. Misspelled that there, but here is... He's got over 1 million subscribers. Good for him. Yeah.
Tornadoes manifest themselves in all sorts of shapes and sizes.
If you're interested in storm chasing, this is the creme de la creme.
Bright white, others dark, horrific monsters. Most are harmless, grazing over rural farmland. Others are worse.
Anyway, really, really awesome stuff.
I've been chasing tornadoes since 1999.
Really awesome. Really awesome.
Top 10 best tornadoes.
Yeah. Anyway, really, really cool. I don't even remember how we got here, but Codmo says, I meant if we found skeletons of fossilized winged dragons that are the type of dragons from European folklore, how do we distinguish them from the skeletons of pterosaurs? Well, pterosaurs are real creatures, Codmos, and we know what their fossils look like. I don't know what fictional European dragon skeletons would look like, because they're not real. So, like, I don't know. They'd look different from pterosaurs. I don't know what to tell you, Cosmos. They'd be different in various ways, you know? But yeah. Yeah. And someone called Ragnarocker, we will be talking about that on Thursday of this week. We're going to be talking about... Well, I'm going to be streaming Jurassic World Evolution 2, the Feathered Dinosaurs Feathers DLC. Actually, if anybody would like to gift that to me, I would be very grateful. I think I have that on my Steam wish list. I added that this morning. It's probably the only thing on my Steam wish list. Again, not much of a video game guy. But we will be playing that on Thursday, so tune in then. Ragnarocker. It's gonna be a lot of fun. I'm looking forward to it. It looks like it's gonna be really good. So yeah. Yeah. Anyway. Yeah. Geholopterus. Yeah, I know there's at least one. I think there's 4 dinosaurs and a pterosaur, I think. I think it's 5 taxa altogether. So yeah. Yeah. It's some sort of a Neurognathid, I think. At least that's what it looked like in the video that I saw. So yeah. Yeah. Anyway. Let's get back to our video here about looking for environmental DNA in Loch Ness.
Now we're going to tell you what we've found. We find a lot of different species in Loch Ness. We find the salmon, we find the Arctic char, and a number of other species that we expected to find in Loch Ness. We also find evidence of a large number of terrestrial species. These are species that live in and around the loch. I don't
think they have anhingas.
Living in the loch.
Golganek, no. I think anhingas are mostly lower latitude.
Badgers.
I could be wrong.
Weasel.
Hang on, I'm talking over this. This is important stuff. Shoot. So when they're actually collecting water from Loch Ness and looking at the DNA from various creatures in it, they don't just find, you know, your fishes and etc. Watch.
Other species that we expected to find in Loch Ness.
Yeah.
We also find evidence of a large number of terrestrial species. These are species that live in and around the loch.
Wild.
I wouldn't necessarily have thought of them as living in the loch, but they live nearby the loch. And these include things like red deer and badgers, weasels, and a number of other species.
That's nuts. It shows you how thorough this method is, that they're finding the DNA from animals that live on the land, too. It's not like, oh, this method is just really imprecise, and, you know, of course there's giant plesiosaur monsters that live in the lake, and they're just you know, this method's just not good at detecting them. It's like, no, shoot, you're getting weasel DNA, elk DNA, badger DNA from the land, and you like maybe wouldn't have even expected to find that in the first place. It's pretty cool. It's pretty cool.
Knows the breathless question on everyone's mind is.
Show the men. Weasels ripped my flesh. Yeah. How do we know? How do we know that weasels ripped my flesh? Well, you know. Weasels ripped my flesh. Yeah. Anyway. Oh, wrong button.
And badgers, weasels,
Weasels.
other species.
They ripped my flesh.
The breathless question on everyone's mind is, what about the monster?
Oh no.
First up, the theory that
there you
the
go, pattern
Loch Ness
juggler, yeah.
monster could be a giant catfish.
One popular explanation has been a giant catfish. So there's a species called the Wells catfish. It's found in Europe. It grows to 12, 15 feet in length. It's a very, very big animal.
Yeah.
It's scary, I would imagine, if it turned up next to your boat.
Shoot. Imagine if a huge catfish just like surfaced next to your boat.
Victorians supposedly had put it into the loch about 100 years ago or so.
So they do get massive Lenina. And why are catfish so cute? It's a great question, email Shokan. Yeah. It's tough to say. You know, maybe we should be studying that. Why are catfish so cute? Sounds like a nature paper right there. But yeah. This hypothesis that maybe the Loch Ness Monster could be a giant, you know, Wells catfish. It's been rumored that these critters were let into Loch Ness. This is not actually footage of them in Loch Ness. This is from somewhere else. Do they actually exist in the loch? Does eDNA show evidence of that? Let's take a look.
And we didn't find any evidence of that giant catfish.
None. No evidence.
Next in the breach,
yeah.
the idea that the creature could be a giant sturgeon.
Oh, and I will do that. Here, hang on a second. Thank you, Claire Burr. Nope, wrong. Not Stream Deck. No, Steam. Steam. Opening this up, and holy cow, Spino Breaker. Thank you. Let me continue the video.
A fish that can grow to enormous size.
How do I do this?
Over 12 feet long.
And we did not find evidence of a giant sturgeon, which had been another popular idea that Adrian Shine and others had discussed.
Many Nessie hunters have always believed the monster is not a fish, but a massive dinosaur.
Hang on a minute. Oh boy, I wish they had gotten this right. Rookie mistake right here. Complete noob error. Yeah, plesiosaurs are not dinosaurs. They're from an entirely different group of reptiles. They're not even anywhere close to dinosaurs. A crocodile is much closer to a dinosaur than a plesiosaur is. So yeah, plesiosaurs, not dinosaurs. Not dinosaurs.
It's not a fish, but a massive dinosaur.
Yeah, not a dinosaur.
A plesiosaur, which would fit the descriptions of thousands of eyewitness sightings.
It really wouldn't. No, goodness, none of these look like plesiosaurs.
There's obviously the Jurassic.
Oh boy, and Dinosaur Dave, oh my goodness. Thank you so much, Dinosaur Dave. I appreciate you tremendously. Thank you. So Dinosaur Dave says, I will gift it in the morning since I can't gift it until it releases. This is the, I think it's supposed to come out Thursday, which is 2 days from now, right? The Jurassic World Evolution. Although you're in the future, Dinosaur Dave, maybe you can gift it before then. But anyway, Dinosaur Dave, thank you. Appreciate you more than you know. And Breezy Bray, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Yeah. Yeah.
Thousands of eyewitness sightings.
There's obviously the Jurassic hypothesis.
And Ragnarocker says it's been, I think, a year or a year and a half maybe since I played Jurassic World Evolution 2. I last played it on stream. Right when it came out. I want to say that was like November of 2021. But yeah, complete the campaign. I tried to complete it and it was buggy. It wouldn't let me. There were glitches and bugs and it wouldn't let me complete it. All the dinosaurs I think it was the Allosaurus, had diseases, but that early in the campaign you didn't have the ability to actually treat them, and anyway, I was the victim of bugs. It was weird. But anyway, and but yeah, I appreciate you more than you know, Dinosaur Dave. Thank you very much. Yeah.
Which would fit the descriptions of thousands of eyewitness sightings.
Not really, but whatever.
Obviously, the Jurassic hypothesis, the notion that there is some sort of scaly reptilian creature, maybe a plesiosaur, that is stuck in Loch Ness, has been.
If there are massive multi-ton, Sauropterygian reptiles in here, presuming that they are Sauropterygian, they probably are. Anyway, you would find DNA out the wazoo from these animals all over the place. Did they find that?
Been there for a long period of time. There doesn't seem to be any plesiosaur DNA in Loch Ness. I'm really sorry for those of you who have the Nessie plushie toys that look like a plesiosaur.
Yeah.
There is nothing in the sequence that looks remotely like what we'd expect a plesiosaur or Jurassic Age reptile sequence to look like.
Nope. No big reptiles at all.
Somewhere in the tree of life between crocodiles and birds. Clearly these animals...
that would be if they're an archosaur, which they weren't archosaurs, but anyway. They'd be kind of more between I'd say between a tuatara and a crocodile, but if they'd found something in their samples that looked like it was between a tuatara and a crocodile, they would have reported on it, and they obviously didn't. So yeah.
Are extinct, but we can reconstruct what those sequences probably looked like. We don't find anything like that.
Nothing. No big reptiles in the loch.
But Neil says there is something in Loch Ness that does fit the description of what many have seen.
Kind of, but not really. Anyway. We've all heard eels make noises before. We've all heard an eel roar. Here, let's listen to that again.
We also have this idea that maybe a giant eel explains the monster. And we do find an awful lot of eel DNA signal.
Soldiers and their weapons would be powerless before the onslaught of the beast.
The what? The who? I'm sorry. Again? I didn't catch that. One more time? The what? The who? Gormbald.
Few hiccups, but everything should come through Danny.
Thank you,
so much for
Gormbald.
what you do and what you have brought to Twitch. You make my heart sing with paleontology.
Gormbald, thank you so much for your kind words. And for those 12 months of support there. Wait. Hang on. Gormbald subscribed at tier 1. They've subscribed for 12 months. Not they have been subscribed. They have subscribed for 12 months. Did you just subscribe for a year in advance, Gormbald? Is that what just happened there? Because if so, that is extraordinary. Thank you so much. Holy cow. It's the least I could do for all that you do to me. It's a small contribution of the education of a much larger population of people that need to hear these things and debunk so many things. Thank you, Gormbald. I appreciate you more than you know. Seriously, thank you for that support. That is extraordinary. 12 months. That's a full year's worth of support just right there in one fell swoop. Just incredible. Amazing. I am deeply grateful. Gorm, I really, really are. Thank you very, very much for that. Again, I could not do this if it were not for the support of generous folks like you, Gormbald. So thank you very, very much. I'm flattered that you see value in what I do, and I am deeply grateful that you want to help keep that going. So thank you, Gormbald. Holy moly. Good stuff. Good stuff. Excellent. Excellent. Shoot, let's... Yeah. Yeah. And...
We've got them. Amazing.
Uh-oh.
Million-year-old dinosaur eggs, and they're perfectly preserved. Cool.
No! Stop that kid!
What if it's an enormous mutant weasel from asteroid BENNU?
What if the Loch Ness Monster is an enormous mutant weasel from the asteroid Bijou? Oh, sorry, Bennu. Golganek. You know, we would expect it. Well, yeah, shoot. I guess there. You know what? Shoot, Golganek. Golganek. There was weasel DNA found in Loch Ness. I'm glad you weren't there when they were producing this video for Discovery UK. Now, they would probably be trumping that idea to the high heavens that the Loch Ness Monster is indeed an enormous mutant weasel from the asteroid Bennu. Uh-oh, Golganek. Golganek, 20 months of support. I appreciate that tremendously, Golganek. Thank you, and thank you for being such a wonderful member of this community. I feel like the luckiest guy in the world. We've got longtime supporters like Golganek. We've got brand new, amazing supporters like Gormabald. Extraordinary. I'm without words. Thank you. Let's get back to the science here. And shoot, when I pressed those soundboard buttons, it moved us around a bit. But where were we? We were talking about... Oh, yeah, eels. Here we go.
Of what many have seen.
Uh-oh. They saw the eels. No, nobody's actually really seen eels.
This idea that maybe a giant eel explains the monster.
Giant eel explains the monster.
And we do find an awful lot of eel DNA signal in our samples.
Lots of eel DNA.
Distributed right throughout Loch Ness.
Which is really cool.
Eel DNA is actually one of the more common hits that we get in our...
There is eel DNA. So the idea that the Loch Ness Monster is a plesiosaur, there's zero evidence suggesting that at all. Eels... Is there a giant unknown eel there? Almost certainly not, but at least there's eel DNA there, you know? It's much more plausible that it would be some sort of giant fantasy eel than some sort of giant fantasy plesiosaur, you know? So yeah. A giant eel? There you go. Yamil Jokan. Yes, indeed. Yeah.
Maybe these things called unicorns never actually breed, and they just keep getting bigger and bigger. It's possible that you can have eels that could grow to, I don't know, 6, 9, 12 feet in length. And so perhaps this idea that there is a large eel of some shape or form, people
Those
see
are
from
boat
time
wakes,
to time,
but anyway.
Maybe that is one explanation we at least can't discount at the moment.
Neil says about 25% of the samples remain unidentified.
The people who want to believe it.
That's probably unidentified at the species level. It's like, oh, well, shoot. What species of weasel does this come from? We don't know. What species of Arctic char does this... Well, what species of charfish does this come from? Oh, we don't really know yet. But yeah.
And the monster will go, well...
Yeah. And there you go, Yamel. Yes, indeed.
Clearly, that is where the monster lies, and you haven't done your job properly. Well, if people want to go on their own adventure and explore these sequences, and I'm sure others will, all those data are going to be available alongside our scientific analysis of those, and people are entitled to make their own interpretations of those data and their own exploration of those data.
Very cool.
They may
So
discover something that we have missed.
I guess you can go to their website and look at all these data. Very neat.
Without a definitive answer, those who have seen the monster and those who believe still think these dark depths hide a secret.
It's a characteristic of sightings that people are so clear in what they've seen. And if you were to try and say to them, well, that sounds like it could be a eel, they will laugh you out of the room.
Yeah, the feeling's mutual then, you know?
In my view, eyewitnesses are honest and accurate in what they see.
I have a feeling it might go on to be...
Which is really funny, because this guy here, this is, what's his name? Adrian... Somebody? I got a lot of respect for this guy. And they kind of cut that down to, like, nothing. Because this guy does not think that there's a giant monster in Loch Ness. He's kind of a scholar of Loch Ness monsterology, but he looks at it much more as, like, you know, folklore. This is you know, the Loch Ness Monster kind of speaks to... The real Loch Ness Monster lives inside of each of us. It is the friends we made along the way. That's kind of... Adrian... Is it Adrian Desmond? No, that's not right. Oh, that's his name. Anyway. But yeah. Yeah. And there you go, Dinosaur Dave. Yeah. Yeah.
See.
I have a feeling it might go on to be a mystery for a long time yet.
Those people who say, well, it's still possible that Nessie is there, that it's a dinosaur or something from that age, they will say it hasn't been ruled out.
I stand out here on the decking outside my van on my own, and there's this energy that comes off the place. It feels like it comes out the top of my head in a column of white light. When I first arrived
Sounds dramatic.
I used to feel that energy and think, well, that's because this is the home of one of the world's greatest mysteries.
We are the most interested in the things which seem imminently solvable. The things we're on the edge of discovery. That is how I account for the enduring popularity of the Loch Ness Monster.
There you go. Beautiful. Yeah. And we can use environmental DNA, both in modern contexts like in Loch Ness, or in ancient contexts like with mammoths. Again, let me give you a link to this article that we were talking about, which kind of spawned this whole thing. Spoored. Yeah. Yeah. A nice eel that bit onto my boot from behind last week. They get bit. Very cool meteor. Very, very cool. Man, I was lucky to see some eels. Let's see if I can pull this up. Some eels, not this past weekend, but the weekend before. At the Marine Discovery Center in Santa Cruz, California. Here is an eel being very reluctantly fed. This is, I think, a moray eel? Yeah. And here's one of the aquarium keepers trying to feed it. Seems a little confused. Yeah. Moray doesn't want to be fed, he wants to hunt. There you go, Lenina. Yeah. Jurassic Park reference there. I think eventually he gets it, right? Kind of mouthing it? No, I don't know. I almost feel hesitancy from this eel in the sense that, like, I wonder in the past if it's been too enthusiastic and has bitten the that plastic holder thing and hurt its teeth. So it's like it's being real cautious now. But yeah. I think I have video of it actually latching onto it. Is that here? I want to say it's here. Needs more salt, says Nolo. Yeah. Being real careful. Accidentally biting the plastic and like hurting its jaws. Maybe. You gonna go for it? You gonna get it? You gonna get it? Come on. Get it. There you go. You almost got it. Oh, come on. You almost got it. Come on, eel. You can do it. Oh. Grab it by the mantle. Yeah, and you got the head. There you go. Yeah. Good for you. Good for you. That's a well-fed eel right there. Finally. Good stuff. It's Charlie's Dragon says, this is the reverse of those claw games. You have to drop a squid into the thing and get the eel to eat it, but it doesn't want to eat it. Charlie's, that's brilliant. I like that a lot. And Meteor, I want to pull this up, this giant eel that you saw. Claire seems to be pretty impressed by it, and I want to see this. Where did you post it in the Discord? I'm notoriously bad at finding things in the Discord, so if you can give me a hint, I will find it more quickly. Let's see, general maybe? Let's random things? Memes? No. That's pretty good, Brandington. That's pretty good. And wild animal / travel. Okay. No worries, Meteor. I'm excited to see it. No, I'm excited. Meteor, this is gonna be neat. I need to get into the Discord more often, so... Gaming... Live on Twitch now, bot chat... Dinosaur pictures... Moderators... I don't see it, shoot. Yeah, darn it. Scroll down, says Claire Burr. Oh, is it in the same one? Nope. That's a different one. Don't see that here. No. Oh, and no worries, Meteor. No worries. Yeah. You're all good. Oh, community boards, third from top. Oh, hang on. Meteor, if it's okay with you, we'll take a look, because this sounds neat. I'm a fan of eels. I think they're pretty neat. I don't know where the community board is, though, Claire. What? I'm looking for things that are... I'm terrible at navigating Discord. Internet Paleo Videos, Paleo Gaming, 3D Printing Crafting are the ones that show new messages. And that's not one of them. So, Oh, is it a DM? Scroll down past Paleontology board. I don't know what that means, Claire. I think it's the channel above memes. Oh, okay, thank you. Let's try that there. Charlie's Dragon. And let's see. Fossil pics. Video gaming. The memes one seems to have... Oh, wildlife and travels. There we go. Why doesn't it show me notifications for new things there? Today at 7:31 p.m. This just happened. Why does it not show it up as a notification? Oh boy. But very cool. Take a look at the size of that eel. Holy moly. In such clear fresh water like that. Such shallow water. That's really impressive. Meteor, very, very cool. Nice freshwater eel there. Let's take a look at eels. What'll that be? Oh, yeah. Let's look it up on our tree of life here. How many species of eels do we have nowadays? And Meteor, where did you see this eel? Freshwater eels, maybe. Anguilla. There we go. Yeah, and was that a cuttlefish the eel was fed? I bet you it was, Gormabald. Yeah, yeah. No, actually, no, it's probably a market squid, actually. That's probably what it was. It wasn't a cuttlefish. Sorry. Cuttlefish have a cuttle bone inside their mantle. That would not be what you would feed an aquarium eel like that. You would feed them what we call market squid. Oh, yeah. How many different species of eels do we have? American eel, Japanese eel, snipe eel, gulper, spaghetti eels. Sound delicious. But I'm sure they would say the same thing about me. Pike conger eel is a type of eel that I looked at for our Spinosaur project. But, they'd turn out to... Well, we've got insufficient information. Holy cow, there's over 1,000 species of eels? That's nuts. Holy cow. Yeah. And they are together with bonefish and tarpons and something called halosaurs also. What in the world is a halo? Halosaurus. It's a wonderful example of when a saurus is not a dinosaur. The Sahara halosaur is a deep-sea fish in the family Halosauridae. Not a dinosaur. But it is related to eels, which is pretty interesting. Pretty neat. Anyway, there's our eels right there. And there's apparently... Whoop. No, further down. There's apparently about 1,070 species of eels around today, which is pretty cool. And they are plentiful, says PaleoStream. Yes, indeed. Very speciose, this group. Holy moly. And welcome, welcome, PaleoStream. Let's get another shout-out for PaleoStream real quick. PaleoStream, Joshua, I'm sorry that I was going to message you about this. I had a very busy weekend. Things have been crazy busy lately. Sorry my segment didn't go as smoothly as I was hoping. Those technical difficulties, the picture buffering and the images not showing up properly through Discord, it went a lot differently than it did when we were just kind of testing things out the day before. So I'm sorry. I'm sorry that felt like amateur hour when we were talking about Spinosaurids during PaleoStreamCon, but it seemed like the rest of everything went brilliantly. And I know for a fact that other people were very, very impressed with that, and congratulations, PaleoStream, on a really successful event there, my own segment notwithstanding. PaleoStream, very impressed with everything. Especially the roundtable discussion I thought was really, really cool on diversity in paleontology. So, yeah. Your biggest fear was that your internet would break? I'm glad it didn't. I'm sorry your Spinosaur segment kind of broke a little bit. But, anyway. Yeah. Thank you for including me, PaleoStream. I really appreciate you. And if anyone here watching right now is not yet following PaleoStream, so PaleoStream Joshua Gnupe is a well-known German paleo artist who streams about once or twice a week here on Twitch. And there's the video. Very cool. I didn't know you were saving the VOD from that. Nice. But go follow PaleoStream if you're not yet doing so, everybody. One of the real movers and shakers in the world of paleo art. And, well, thank you, Gormabald, for those 10 gift subs. Tinamu here seems quite excited about that. Recently upgraded, it should be able to withstand any amount of gift subs. Right? Uh-oh. Seems to be overloading.
Gormabald is overloading the system with 10 gift subs.
Holy cow, Gormabald. Thank you for that. Holy moly. And don't worry about that Tinamu bird. I'm sure he'll be fine. You know, those paleonates, they're pretty hardy little birds there, you know? Thank you, Gormabald. I really appreciate that. Love your support. I would not be able to do this 5 days a week if it were not for generous supporters like yourself, so thank you, Gormabald. Holy cow. By the way, there we go. Yeah. Enjoy that VIP, Gormabald. I think you've earned it. I got a good feeling about you, Gormabald. Thank you. Anyway, PaleoStream. I'm really looking forward to being able to show you the published version of the Spinosaur project, and yeah, it's going to be good stuff. And I'm really looking forward to that European Spinosaur that's going to be published soon too. Yeah, me too, PaleoStream. I got to get that done before I leave for the field this summer. So yeah. And currently cutting it down into segments. Very cool. Yeah. Let me know if you want me to actually, well, I feel bad that the video was so choppy and that things felt so disjointed in my segment. If you felt that my segment, you know, doesn't really go with the rest of them, I feel like it pales in comparison to, like, Natalia's segment talking about Polish paleontology. That was really, really cool. I don't want to, you know, drag down the overall quality, so if you don't want to post that to YouTube, I 1,000,000% understand, Joshua. So yeah. Also, I didn't quite clear it with my co-author that I would do like a full-on presentation about this before we publish it. I'm sure the state that it's in right now is fine. Otherwise, I'd offer to actually do a proper SVP-style presentation now that I have some time, Joshua, but we can talk about that later if you want to have something like that. Yeah. By the way, do you already have that master thesis on the Brazilian Spinosaur material, including a hand? They don't have any carpals. PaleoStream, yeah, you're talking about Oxalia, right?
The Dinosaur Dave gifted the Dinosaur Dave a subscription.
Thank you, Dinosaur Dave, for those 3 gift subs. That's where we met our goal for the day. Thank you, Dinosaur Dave. I appreciate you more than you know. But master's thesis on Brazilian Spinosaur material, that might actually be new to me, PaleoStream. Shoot. If you have a PDF of that, is it unpublished? If it's unpublished, I don't know about it. I don't think. You've got my email address, right? Or you can get to me via Twitter DMs, PaleoStream. I don't put anything out the presenter is not okay with. I'm sure it'll be fine, PaleoStream. I'm just a little embarrassed that I like to have, you know, I'll tell you what I'm concerned about, PaleoStream. I'll tell you what I'm concerned about most. Is that since I didn't have time to put together a sleek, polished presentation and had to kind of wing it a little bit on Saturday, had to kind of improvise things, I'm concerned that other people in the paleontological community would see this and that they would go, oh yeah, look at the dinosaur guy here. Typical dinosaur science. You know? Thinks he can just wing it and, you know, that nobody will notice because, you know, it's dinosaur science. Spinosaurs in particular. You know? That's what I'm concerned about, is that people would think that. And I have not watched the VOD yet. I should probably take a look. But I'm nervous about that, you know?
On the wings are once again invaluable.
I'm afraid that it didn't rise to the level of dignity implied by PaleoStreamCon, you know? Or the level of... It wasn't rigorous enough, I guess. That's my concern. Thank you, InGen, for the 22 months of support. I really appreciate that, InGen. Thank you, thank you. So, yeah. Yeah. But anyway. Yeah. But anywho. Yeah. And Dinosaur Dave says, any tips for doing an interview? I got one for my Lego fossil bids tomorrow. But yeah. And I think it's mirrored in the way of the quality of our Spinosaur fossil record. Perfect in that regard. Oh, PaleoStream. That's not as reassuring as you think it is. Oh no. Let me just put it this way. PaleoStream, if you don't feel like it matches the quality of the rest of the presentations, feel free to leave it out. I didn't go back and watch the VOD. I should do that tonight. But yeah. Yeah. Anyway. Dinosaur Dave has a question, though. Any tips for doing an interview? I got one for my Lego fossil builds tomorrow. Dinosaur Dave, I've got one very specific piece of advice. And if you're going to be, like, pre-recording an interview or something, if you're going to be... If it's live, this might not help you, but if you have to, like, pre-record something... Here's an old trick that I learned when I was in theater in high school. If you're really nervous about something, or if you keep tripping over your words, say you're, like, trying to do a pre-recorded little video snippet, where you have to say some lines, and you just can't get it right. Take after take after take, you just keep messing it up. Here's a tip. Here's something that you can do that might instantly solve the problem. Do some push-ups. Like, get down on the ground and do some push-ups. However many you can do in the minute or so before you have to do your interview or whatever. For whatever reason, exerting yourself physically like that and kind of putting yourself out of breath just a little bit makes it so that all of your nerves just go away like that. And I've given people this advice before, and it seems to work really, really well. I know people who would have to go on stage and give presentations, like at SVP or something like that, and they would be so nervous that they would be ready to vomit as soon as they walk on stage. But if they can go backstage and just do a bunch of push-ups or sit-ups or jog in place or something, it really helps with those nerves. I don't know how it works. I'm sure there's a simple physiological explanation for this, but it really does work. It's an old theater trick. So yeah. Yeah. The adrenaline fix, Gorman Bald. Yeah. Yeah. So anyway. Yeah. Thinking I can do a push-up, but I hear you. Do whatever you can. Physical exertion. It helps more than you would think, Dinosaur Dave. Yeah. Yeah. So anyway. With that said, holy cow, it's almost 8 p.m. here. I've been streaming for almost 6 hours at this point. It is about time to wrap this thing up in just a minute. But don't go away, everybody. Not just yet. And Gormabald says, Danny, you don't need validation, but one of the people I watched in a TED Talk several years ago back said the same exact thing, and it fixed the nerves problem. Very good advice, great advice. Gormabald, I've seen it work for people. Shoot. This past summer when I was out in eastern Utah, and a colleague of mine had to do some, like, kind of daily vlogs about his work out there. He kept trying to record things on his device, and he kept messing up his lines. He was getting really frustrated. And I told him, do 20 push-ups, stand up, and hit record. And it worked. First try after that. So yeah. So there you go. And I appreciate you, Paleostream. Thank you. Says Cindy the Thesis on Twitter. Thank you, Paleostream. Anyway, with all of that said, it's about time for us to wrap this thing up. There's so many pieces of fossil news we didn't get to today that we will have to cover tomorrow. Shoot, we're going to be talking about an antiornithian bird ecology, looking at these weird-toothed birds, figuring out what they're doing in their environments, what they're eating. We're going to talk about that new European Spinosaur. We're going to talk about the eyes of Thylacosmilus, this weird kind of stem marsupial saber-toothed predator, and why it had sideways-facing eyes. And we'll also take a look at this video, too, tomorrow. With,
Dr. Nathan Smith is the paleontologist here at the...
Yeah, that's Jeff Goldblum from Jurassic Park, and he's talking to some kids, and poor Nathan Smith barely gets a word in edgewise here, but we'll be looking at this video tomorrow, too. Very goofy. And we'll be talking about where does science outreach end and where does hype begin? Where do you draw the line between, you know, making things more accessible and kind of dumbing them down to the point where maybe they're not really doing much good in terms of science outreach. So anyway, it's gonna be fun, so I hope you'll join me for that tomorrow. But until then, it is time to wrap things up here. So let's go ahead and do that. There's a Smilodon to run our credits over. And thank you to everybody whose names are beginning to ascend here on the credits screen. Don't go away just yet. We're going to go see if we can raid into somebody else doing some science on Twitch right now. See if we can spread the science love around. And it looks like Moo Hoodles is on. Holy cow. We are going to go say hello to Moo Hoodles, who is currently doing some science and technology. Exoplanets, astrobiology, and space news. Sounds like the perfect destination for us. Yeah. Very cool. So if you're interested in planets outside of our solar system, or the possibility of life outside Earth, well, let's go see what Moo Hoodles has to teach us about that. Thank you, everybody who's showing up in the credits here. From the quietest of lurkers, to the most vociferous and rambunctious of chatters, to those moderators who help keep everything on the tracks, to everybody who supports the stream financially. I appreciate you more than you know. Thank you, thank you. Would not be here if it were not for your generous support, so thank you for that. And let's go see what Moo Hoodles is up to. And I hope to see you tomorrow for some additional fossil news, everybody. Take care of yourselves. Stay curious. I'll see you around. All right. Bye-bye.